Hey, Lightwater, how you doing, my friend? Thank you for the unmute. Can you hear me? Okay, let me just reconnect in case it's my connection.
Man, what's going on in this room?
What up?
Yo, what's up, guys?
Hey there.
I've been doing some cold welding research, and I found out that the so-called Galileo spacecraft, which was supposed to deploy a certain antenna, well, it didn't open due to cold welding. Yeah, so that's what I've been doing. Been also checking out spectroscopy. There's way more to it than meets the eye. The more I dig, the more I find it's almost impossible for their spectroscopy bullcrap to work.
Any of you guys watch what's it, the Blue Marble Science guys?
Would you go to Blue Marbles last night? What's it? It's Xanax Clover Daddy.
You watch that? The thing with the thing with Blue?
Yeah, I was
I didn't
listening
watch
to
it.
it. You know, it's
So
funny.
during the presentation, you guys went over to Blues. Is that it?
I watched it last night after I got home.
I didn't watch
Okay,
it.
and who was involved in that? Did any of the?
It was that one other Discord channel, Tartaria thing, or whatever.
Oh,
It
you
was
mean
on their
Blue went
channel.
to Tartaria?
The channel, you know, the Discord channel. No, they
Yeah,
were. Oh wait,
No, it was
yeah,
Blue Oracle's
it was a
Discord.
bunch of their guys that went to Blues Channel. It was on Blues Channel.
yeah, right. So who went over?
It was Blue Marble's Discord.
Witsit was there. I don't know. There was a couple guys I think there. I wasn't.
Oh, you
I
went
didn't
over,
really
or
look.
what's it? Let's hear what happened.
What do you mean?
Like, what did he say? What went on?
Oh,
What's
they were going over. You know how you measure distances. You know, like the guys with the surveyors and all that kind of stuff.
yeah.
It was pretty interesting because you could see their story was morphing because Witsit had them kind of trapped, and
Hey,
on the
can you
fact
guys
that
hear me?
all the data isn't there that they claim is, you know, they always tell us look at all the data, but all the data wasn't there, right? They throw out a bunch of data and then they end up with an average, and then Rumpus
Yeah.
kept rumpusing in, so it was kind of funny.
Well,
Hey,
that's
can you
why I
guys
The
hear me?
more,
mentioned it yesterday, because he was downing Witsit and Jeremy. So I said it, hoping that that's good. That's good shit. I gotta hear it.
yeah, it was funny. You know, it's funny. They're spreading the truth. The Globers are spreading the truth faster than uh, they think because they keep bringing all these things up, and then you know we're like chickens. We scratch and peck. We look. We eyeball things. You know, it's like the more you dig at these things, like just mentioned the spectrum. How you say it, the more you look at those things, the more you realize it's not what they were saying. They're making up a
Oh
lot of
yeah,
shit.
bro. I found out so many things. Like I tell you, the worst thing for them is to challenge me on something, because that's gonna make me look. And boy, did I found shit, man. Did I find stuff? It's unbelievable.
Hey,
Yeah,
can you guys hear me?
it's amazing.
Yeah, you're good now,
Yeah.
bro.
Oh, okay. Yeah, so it was on Blue Marble's Discord, but
Yeah, that's right. So
it
you
was
I
went
on
seen.
over?
Blue.
Yeah, I seen that yesterday. I seen that.
Yeah, so I've been looking into it a little bit more. I'm like pretty busy. I got a lot of stuff going on, so I can only put a few minutes into this PDF at a time. But well, MC Toon came in there, and dude, MC Toon got so mad. Dude, he called
Dude,
me
he
a
was
bitch.
interrupting Austin like he was asking a question, saying, "Huh? What about it?" Austin, huh? Austin's trying to answer. Dude, Big Toon just imploded, bro. What a joke that man is, dude. You have
Dude,
effect on that guy like no other.
dude, he called me a bitch like 12 times in a row. He was like, "Shut up, bitch, shut up." I'm like, "Yo, you're
Before he even
freaking."
joined, though, check it out, Austin. Before he even joined, like Larry and you were having a back and forth, and then Larry asks you a question, you go to respond, and then Rumpus jumps in with just stupid bullshit and admitting he don't even know what's going on. He's just taking up space, and then you try to respond again, and then Bob starts asking dumbass questions, like just confirming questions, and then Chaiki jumps in. It's like, dude, let Austin answer the question. And then before long, Larry just wound up leaving, so you didn't even hardly get to pin him down. But you did a good job with the time you had with him, though, bro.
Yeah, but
They
what
were
if
literally
someone was in
scared.
here calling you a bitch 12 times? What would happen?
Yeah, I don't know. Like this was on Blue's Discord, right? So like what happened was I went to the YouTube because as he mentioned it, and I'm like in the chat. I sent a few super chats, and they're just like subversively avoiding my question, pretending they're answering it. And then they're like, "Flyers are so scared to come in here and all this stuff." I'm like, "Come in where?" I had to drive to my RV, so I'm like, "Whatever, I'll join your Discord. I have to drive anyway." So I jumped in Blue's Discord, and it was just a joke. Rump is in there screaming over me and like admitting at the same time he knows nothing. But long story short, man, I went and looked into, like, I would have never joined Blue's Discord, but I was looking into it, dude. I found some epic stuff. So I found out where they baked the sphere, right? So I found it. They bake it in. What they do is they take the actual raw observed angles and then they turn them into azimuth readings using spherical coordinates. It just point blank says it in the document. They have
Yeah,
to use the Bessel and
Bessel, yeah, Bessel function.
Yeah, they literally turn it into. They take the base net and everything. They turn everything into a sphere before they even put the original data down.
And no matter how many times you asked Toon, you was like, well, just admit that you were wrong about, because you kept claiming that it's just the averages. And dude, he started calling you a bitch. I mean, I couldn't believe it, dude. What an idiot, man. You had to hear it. But yeah, on this channel, he would have got muted in a heartbeat, bro. And he just kept doing it over and over.
Yeah, because everyone would have been fucking crying if there was some Glober in here calling him a bitch 12 times.
Yeah, like
even Blue did say something though, but not directly to him. But he pretty much said something though. But
they're all
ridiculous.
like scared. They're scared of MT2 or something. But dude, I thought it was hilarious. Honestly, like when he was like calling me bitch, I'm like, I would have hated if someone muted him. I thought that was so funny. You know, like he was freaking out. He was freaking out because, bro, when I went and first talked to him, I'm like, so what does this correction column? And he's like, they just take the average of the observed angles and then that's the correction. I'm like, what? And come to find out that's not the case at all, you know? And I'm like giving him an opportunity to admit that that's wrong. And he starts freaking out. He can tell he shouldn't have jumped in there. You know, he jumped in and now he's live recording. And I'm like putting him on the spot to admit he was wrong about that. So he just starts freaking out. He just like implodes and starts calling me a bitch. Like he just like freaked out. It was really, really crazy.
Good stuff, bro. Didn't he already admit here the other day to us that they are not actual measurements, Maktoon?
Well, what they're doing is they're still rocking with the narrative that we don't have access to the field notes or the raw data in that sense, but that it's just a raw average of the angles. And so you can see that their argument is it doesn't matter if you have the field notes or not. If they just take the angles and then average them out, like they just do a raw average, then the raw average shouldn't equal right around the predicted spherical excess. Right, but they admit they don't have those field notes. I do think we should try to get them though. But anyway,
hold on. They admitted that on Blues.
Yeah, of course, that they don't have the field notes.
Blue was chastising me and saying, "Oh no, they do have them," and he posted all kind. So Blue admitted it. He accepted it that they don't have the original.
Yeah, well, yeah, because I pressed them, so they were pretending that they did. They even cited page 556. I sent a super chat saying 556 shows one angle that doesn't show all the recorded angles from that location. It shows one, so that isn't what that is. So then they end up like walking it back, you know. Well, they don't ever admit they're wrong though. They never admit they're wrong, dude. They act like they've been saying it the whole time. Yeah.
I got one for Jeremy, man. Jeremy, how about Austin or the guy who was in there with Austin, who did pretty good backing him up, you know, as much as he could. He didn't get that many chances, but Rumpus, Austin's like, ain't line of sight give you 180 degrees for triangles, and Rumpus denied it. Like after everything we went through. And I've even posted on a couple of my videos where it took us forever. He finally realized that, yeah, if you have line of sight, then it's got to be 180. It can't, no matter what we're on, if you have line of sight, it's 180. There's no getting around it. We don't see bent. I mean, not in that way anyway. And he just flat out denied it. No, we don't see, we don't get 180 degree triangles with line of sight. I couldn't believe it, dude. I wanted to jump through the screen.
Yeah, they're delusional for sure.
I'm gonna drop. I was looking through some of this last night, but I stayed up too late. But I'll drop some of the screenshots I ended up finding.
Dude, it was just a big. They were squirming, dude, just trying to come up with anything. And Blue kept saying, "It's so funny they contradict themselves." But Blue said, I started to make a video of them interrupting you, Austin. It was where just a bunch of them jumped in. The stronger your point, the more of them that jumped in. It was ridiculous. You only a couple times did you get a sentence out without being interrupted. But Blue did try to say a couple things, but you know he sat back and let it go, man. It was aggravating. But even you being limited, you still mushed them. But so they were contradicting themselves. They said like Blue was saying that it says here that he kept saying it over and over that the equal that the excess or the weighted mean is applied to all of them equal. And that was for like one example, and he was using it across the board, like they used the same weighted correction for every single measurement. And then MC Toon, like 5 minutes later, says, "You're acting like that applies to every single measurement. You know, that's just 1 point." And I was laughing, man. I was like, dude, he doesn't realize he just contradicted Blue's main point is that that point didn't apply to every measurement across the board, and that's how he's trying to apply it. Anyway, it was a lot of contradictions, man.
Yeah, this is a they have no legs to stand on here. Like, really, it's just sophistry.
Yeah, but they know I'm like obsessive about things. So like they know that when it's all said and done, whether it's a week or 3 weeks or whatever, like I'm gonna like fully get to the bottom of it, you know? Like fully get to the bottom of it. Not like, oh, they don't have the fill notes. Like, no. I'm gonna fully get to the bottom of how they did the whole thing. And they know that. MC2 knows that. That's why he's freaking out. That's why they're freaking out. That's why they don't want me talking. That's why they want to say, Austin can't do math. You're an idiot. You don't understand things. Don't let him talk. You know, like they know I'm not gonna stop till I figure it out.
Yep. They don't want their audience to hear it all. But I'm telling you, man, every single proof, this just falls right in line with all their other proofs, dude. It's all based on assumptions and there's holes in it, dude. Everything we look into, man, we pick it apart and there's holes in every single thing they try to use as proof. So at the very least, that bullshit does not prove a globe, along with all their other freaking claims.
Let me read
They tried with the gyro compass, destroyed. They tried with the pendulum, destroyed. Everything they tried, we look into. They tried with spectroscopy. Oh my God! Wait until you hear the stuff I found. I watched 2 lectures on it so far, bro. Forget about it. It's much worse than we thought. Much worse. The motion can affect it. The revolution, the pressure, the heat. Oh, it's incredible, bro. It's incredible.
Yeah, and just like I told that dude too, the density. So look, I'm gonna read this. So the text describes the process of determining the standard geodetic data, latitude, longitude, and azimuth of astronomical stations along the 39th parallel of latitude. This was done as part of a larger project called the Transcontinental Triangulation, which involved measuring the angles and lengths of sides of triangles connecting astronomical stations from the Atlantic to the Pacific Ocean. The first step in determining the geodetic data was to make a preliminary computation based on the adjusted angular measures from the triangulation, which were obtained by satisfying the internal geometric conditions of the triangle and making sure the lengths of the interspersed baselines agree. The computation was made using formula found in the Coast and Geodetic Survey Report for 1894, which were based on the Clark spheroid of 1866. The results of this preliminary computation were then compared to the astronomical values, latitudes, azimuths, and longitudes obtained in previous parts of the project. The table at the end of the text shows the comparison of astronomical and provisional geodetic measures for different stations along the 39th parallel. Almost done. And the report you posted, this is ChatGPT. The preliminary computation of the geodetic coordinates of the astronomical stations was based on the Clark spheroid of 1866 and was performed using the customarily employed formula on the survey. The spherical assumption was applied to the raw observed measurements in the form of the Clark spheroid, which is a mathematical representation of the Earth's shape, to obtain the preliminary geodetic coordinates. These preliminary geodetic coordinates were then compared with the astronomical values to determine the standard geodetic data, latitude, longitude, and azimuth. I know that was a lot, but they're using the reference spheroid model to actually convert the raw data prior to recording it in the observation column.
So they bake it in prior to putting it in the column. Huh.
Yeah, before even putting it in. Yeah.
Yeah, it's crazy. Once you look into their fantasies, it's all full of holes everywhere. It's like a spaghetti sifter. All you got to do is look.
This is a big one though.
Yeah, it's huge. That's their go-to for the measurements. So yeah.
Yeah, like a base level, it's like the idea that they.
Hey, wait, so when you get a chance, I had a question for you.
What'd you say? I connected to my Jeep. What's up?
I just had a question. In my son's school, they're teaching him at the moment. Hurricanes spin and rotate due to the rotation of the Earth. I was just wondering if you have any advice that I could that I can share with him, contradicting, what they're trying to feed him, or evidence contrary to what they're proposing to him.
I don't know. I haven't
Some-
fully looked into that. So.
Put something in a blender and throw it in. Throw different colors and show him it's impossible. The thing has to be spinning in order to affect what they're saying. And also tell them that they have counter spinning on either side of the so-called globe. So if one thing is spinning in one direction, how does it form two different rotations? You can start with that.
I think their claim is that hurricanes spin counterclockwise in the northern hemisphere and opposite in the southern, which is in correlation with the rotation of the Earth, right? It's moving in the same
Exactly.
direction. That's
Yep.
what they're claiming, right? And you're claiming it would have to be the opposite, right? Like,
Exactly. Yep.
okay.
They're no, hold on. They're claiming it's the opposite rotation.
Oh,
I'm
okay. They're
claiming
claiming
it's the same. Yeah, because there's only one rotation. So if you have one motion, how could that equal to two? To opposite rotation. It's impossible. That's an easy one to debunk.
Does everyone agree with that?
I agree with SC 100%.
Well, they got the shit on Jupiter where it's going opposite as Earth.
Hold on, did I hear Kosho say I agree with SC?
I agree.
That's what I thought I heard.
Yeah.
Oh, something's
And
wrong.
so, can you rephrase that, Kosho? What he said, just to be certain that you do agree.
Yeah, he said, tell your kid's teacher to fuck himself and put some colors in a blender and see if he learns anything, is what he said.
Okay. Are you willing to come help demonstrate that for the class, Kosho, and stick your hand in the blender?
So what I
My
do know
hand,
is
food
that
coloring.
they don't actually all go the opposite way, right? Like they say that, but they don't all go the opposite way. I do know that. I do know that if you Google it, all the mainstream articles will say they do. All the anti-flat earthers will say they do. They don't. They objectively don't all go the opposite.
I even had Bacon and Kosho agreeing with that the other day. They said along the equatorial pathway that it is possible for them to spin counter to what would intuitively
I don't think
be.
to agree on that, dude. I think I said that to you explicitly, unprovoked.
No,
yeah, they
even in
certainly
the South, they don't all go the opposite way.
Yeah, no, I said this to them the other day. It's the truth. That it's not that they all don't. It's that there are anomalous events where some have spun the reverse way of what they would be expected, but usually those, I think the one or two that I know of, they happen very close to the equator is one, and I think they had they were around like a landscape that allowed a greater influence than that of the rotation. But both those were very close to the equator.
Another thing I just thought of. If the rotation of the Earth,
you're roboting.
Look at the currents. I haven't fully done this, but if you look, just I have a feeling that you look to the ocean currents, right? Then you're going to your
I want to hear what you're saying, but you're roboting.
If you Google it, to say.
Gotta wait for the sequence. You were roboting, bro. We didn't get nothing.
Yeah, we want to hear what you're saying, but you're roboting, bro.
Can't do it, man. You're roboting too bad with it.
It's even worse than Jeremy.
Yeah, I know.
And that's saying a lot.
Yeah, well, they got Jupiter. They got Jupiter where it's doing the opposite rotation.
If there's a storm on Jupiter, it's doing the opposite. That's right.
Yeah, the opposite.
You know what
of
else
what
I
it
found
does
out
on-
about
so
Jupiter?
It's not the Earth, the rotation of the body you're on that causes the things to go either way.
That's why I love you Canadians, UNSC, because I swear you'll be told something 2 days ago and you'll forget it the next day. So
Yeah, no, tell me about how it's the pressure now. Tell me about how it's not the rotation.
not the pressure now. It's not that now it's the pressure. It's that both of those, the rotation and the pressure, are both what cause it to be moving in the first place. The pressure is what's causing the movement. This is the cause of the movement. Just like the pendulum, Foucault's pendulum, there's not a cause of it swinging. It has to be swinging. And then there's precession. The hurricane, there has to be movement because of the pressure.
And you've told us the cause of
that movement is dictated by the rotation, which is why it rotates.
Just like the pendulum, you told us the cause of the pendulum was Earth rotation. Just like the hurricane, you told us the direction cause was the rotation of the planet, the hemisphere.
Yeah.
Yep. And now we find out it's not the hemisphere because we have the opposite thing happening on Jupiter.
Oh, it's not the opposite. The pressure
It's the opposite.
the opposite. The pressure is going in.
It's spinning in opposite directions in the opposite hemispheres that it should be according to which way Earth spins.
Dude, it's a totally different event. So the fact that the pressure is going outward versus inward is what's causing it to go in the outward direction. Like it's like what do you call that? Like a
dude, you told us for years that the cause.
Yeah, you were talking about the Gravitron carnival ride. Remember, Kosho? That's what you were using to analogize this whole thing.
No, it wasn't. That was a different conversation. Nice try.
Oh, okay.
It was the ISS thing that he got roasted on.
Go ahead, Kosho. Tell your story, man. Let's hear it.
Story. See, if anybody's kids were here, I would tell their kids to look at this picture, and this is on the.
We don't want to see dick pics, Kosho.
On the top, you have a sink, and on the bottom, you have a source. Okay, the sink is where the pressure, the pressure is causing the atmosphere to be going towards that point, and the source is where the pressures of the atmosphere causing it to go outwards.
Why can't you just say centrifugal and centripetal, Kosho? Why do you got to be all
because there's no
spinning
yet. There's no spinning yet, Daislo. That's why. Nice addition. But yeah, so on the right of those pictures, you have what happens if they're spinning, or there's rotation in the northern hemisphere specifically, and what you'd end up with is you have them going towards the source, and then you have them deviating, which would cause a rotation counterclockwise. And then the other case of the source, you have them going outward, rotating and going clockwise. So it's not that it's a different. It's not a different answer just because it's on Jupiter. It's a different event completely because one is a source and one is a sink.
No, Kosho, I'm trying to make sense of it, man, but I'm struggling.
Maybe you should sit in on your kid's class with him and learn something.
Yeah.
Okay, so
this is what the teacher would be saying, huh?
Probably not. This picture is specifically in regards to explain the differences between a storm on Jupiter and storms on Earth.
Yeah, we know the storm isn't the direction of the rotation of the storm isn't caused by the Coriolis effect. We know
it is caused by the Coriolis effect.
It's not though, because it's doing the opposite thing. And if it was caused by that, it would be doing the same thing in Jupiter. It's not doing the same thing in Jupiter. It's doing the opposite thing.
Both of these pictures I posted are describing what the Coriolis effect would do. It's just two different cases.
And then we can see it doing the opposite thing on Jupiter. Yes.
No, it's not doing the
Oh,
opposite
not
thing
the
as this
cause. It can't
image.
be the cause because it's doing the opposite thing.
As long as it's doing one of these things on the right, then it's doing the Coriolis. And it's doing the thing on the bottom because it's a situation that applies to the one on the bottom, where the pressure is what is it? It's higher on the inside. So where the storm is, that's where the pressure is higher. And outside of it is where the pressure is lower. So that's why it's doing that. Pressure systems on Earth are far different, right? Pressure differences on Earth are mostly caused by temperature.
Yeah. So it's the pressure. It's not the direction of the hemisphere spin.
It's both.
It's not. Dude, you told us for years the reason why the hurricanes are spinning like that is because the Earth is rotating, and it depends on which hemisphere you're in for which way they're going to rotate. Now here we are, years later, we're on Jupiter, and we find out that's not the case. That's not the cause because it's doing the opposite.
That's
thing
what
you
he
said
told.
was
That's what he
happening.
told me a few days ago, Jeremy. That was his exact answer to me.
Dude, listen. I don't know how this is so hard to
Okay,
understand.
my bad, Dysel. Here we are, days later, and we have the opposite thing happening.
I don't get why this isn't clear. Hopefully it is to somebody. But these are two different situations. So in both cases, what you have on the left side of the image, this would be what would happen if nothing was rotating. In one example, things will go towards the lower pressure, and the other example, things will go outward from the higher pressure. Those are just two examples of what happens when it's not rotating. If those same scenarios are rotating, then the Coriolis will cause the top one to do counterclockwise and the bottom one to do clockwise. This is the reason why there's two different rotations. The expected rotation on Jupiter is because they have a different atmospheric system. They don't. It doesn't work the way it does here, where the temperatures are going to change the pressure, so you can expect the lower pressure systems to be, where things are going towards. That storm is a high pressure system, so it's going to be going outwards from that source. Coriolis would cause those two things to rotate in opposite directions. It's caused by both the Coriolis, and it's Coriolis affecting that pressure system.
How does Coriolis affect the pressure system?
Just like the picture shows.
Okay. So you're just saying like it's providing the direction of the spin, not the direction of the pressure.
That's right. Yeah, that's right.
Okay. And what's providing the direction of the pressure?
The fact that there's two different pressures.
The fact there's two different pressures. Can
Yeah,
you elaborate a little further?
Well, the second law of thermodynamics, the way that you guys understand them is that high pressure goes to low pressure. It's not really what it says, but that's one takeaway you can take from it. So if you have these two pressure systems in a medium that are adjacent to one another, the high pressure will go towards the low pressure, and they'll balance out. So I mean, it's just regular thermodynamics. So that will happen regardless. The left pictures are what would happen. The rotation causes those left pictures to turn into those right pictures in the northern hemisphere.
Jupiter is a low pressure system moving to a high pressure system.
That storm specifically.
So the storm is high pressure or low pressure?
High pressure.
High pressure. And you have high pressure contained by what?
What do you mean contained by what?
Is there an atmosphere?
Yeah, Jupiter is almost only an atmosphere.
What do you mean by almost only an atmosphere?
Well, I think there's a solid center, but they're not sure. They like metallic hydrogen or something. But most of Jupiter, is just gas.
Okay. Gas contained by
its own weight. The way that
Interesting.
Jupiter applies to it.
but it's rotating and that's not affecting it.
No, it is affecting it. The rotation is certainly affecting it, and that storm is one example.
And this storm, it's raining. This is the storm where it rains diamonds.
Yeah, you wish.
I thought that's what happened on Jupiter.
It's probably deeper. I forgot. I calculated it before, but it's a lot deeper than that. I think
Deeper.
The
Depth
pressure's so
wise,
strong. The pressure's so strong it rains diamonds. So you should know that, my bro.
Yeah, it does. In that storm, I'm not sure, but deeper than Jupiter, yeah, absolutely.
Like diamonds in the sky?
That's right.
It's raining straw men on Jupiter.
Lucy's in the sky with diamonds.
She's on Jupiter.
I was thinking more like the halftime Super Bowl show.
Now, there's some interesting things happening on Uranus, too. Don't forget about that.
That's what I hear.
Probes and shit, methane gas.
Is there golden showers on uranium or Uranus?
They could be. What color is methane when it's liquid?
You got golden showers in Uranus?
Very possible.
I don't know,
If
bro.
you can believe diamond rain, why not that?
Gold can't form in the atmosphere, can it?
If we send a probe there, can we scoop up some diamonds and bring them back? Wouldn't that pay for the mission? Huge chunks of diamonds?
Probably not.
That would drop the price of diamonds on the market, too.
Yo, are you ever going to get a spherical excess measurement, though? That's my question.
Never.
Yeah.
Can we ever see one actual measurement?
They have one
an actual measurement.
That document has a whole list of them.
It has 0 actual measurements.
Well, as you know, it has the measured like the average of the measurement. So you take
we just want an actual measurement, though. Just one actual measurement.
Would that be more valuable to you than the one that they took?
I could at least believe that there's an actual measurement. Yes. This thing with the averages, who knows? Did they make them up? Did the guy make an averaging mistake? Was it a mean weighted? Did they throw shit out?
You said, did he make an average?
Maybe a virtual measurement would be good, Jeremy. You'd be happy with that, wouldn't you? Virtual measurements. Good.
Something.
So to most people,
so did he make an averaging mistake? A mistake making the average?
Yeah, dude. If you have multiple numbers and then you take the average and the average ends up being something completely different, it's gonna kind of be apparent. So
maybe not. Who knows?
It
might be apparent. It might be not. Depends on how many numbers you have, how many numbers in the average there are, and what you're doing, what you're looking for, and how the mistake went. It might not be apparent, dude. What the fuck, bro?
Dude, it would be apparent. What are you talking about?
It might not be. It might be. It might not be.
So if I took an angle measurement with the theodolite of these two positions, and I get 5 angles, and they're all fucking wildly different, I'm gonna fucking get fired. And someone else is going to do my job. And then when he does the job,
we don't know if that
he's going to end up with 4 numbers that are closely related and one that is way far wrong. He's going to throw that number out. And then when they take the average of those 4 numbers, if it becomes some number that is unrecognizable and not even close to the 4 numbers that he had in the first place, he's going to get fired too. So what you're going to end up with is somebody who knows what they're doing about how to add numbers up and divide them. So I'm not sure what kind of insight you're going to find from finding the raw, original, unaveraged.
Right, let me explain it. I know you don't know. I know that's what I'm here for, to explain everything to you. All right. So if you have 10,000 pieces of wood in your backyard,
oh my god,
and I have you go do an average of them all, but you do the math wrong in a manner so that you're only off by 1/8 of an inch or something. You just did some wrong math, maybe forgot one or added one or whatever. You just put a number in a wrong place to where now you're off 1/8 of an inch somewhere. If I have your data, your actual measurements, I'll be able to run through, do my own average, be like, oh, look, you did the fucking average wrong. You're an idiot. Or I'll be able to see in the average if one of the 2x4s measured 5 feet and the same one you measured at 15 feet. I'd be like, do you know how the tape measure works? I don't know. Like, There's a lot of data we can glean from looking at the data.
Okay, well,
which you don't have, which are the measurements, the actual measurements you don't have.
So if we have 100 pieces of wood in the backyard, how many of those do you think I'm going to get the average wrong on? One?
I don't know. Maybe all of them. We don't
Maybe
know
all
because
of them.
I'll never see your measurements. You'll never show me the actual measurements, so I'll never know how many you got wrong
I
or
would
right.
never gotten the job in the first place, man. If I'm not going to be able to do one average, let alone 100.
Maybe not. Who knows? We don't know. We'll never see the numbers, the measurements.
Kosho, remember in school you had to show the work, Kosho, not just get the answer.
Yeah, I mean, 6th graders are showing more work than you guys.
I think what you guys are requesting is unreasonable, and I think that if it exists, you know, that'll be a miracle. But I think that the people who took these measurements, they probably recorded each measurement. They probably did it 10 times, 5 times, 4 times, 3 times, and it took the average to come out with the most accurate
all right.
value.
Okay, let me just get it clear.
Of that raw measurement. Yeah.
Let me just get it clear. You think this is unreasonable what we're asking for, and we're asking for the measurement. You guys are saying you have spherical excess measurements. We're asking for the measurements, and you think that's unreasonable.
I think that there's hundreds of, I don't remember how many sites there were, but I think there's like 150. Let's just call it 150 sites. There's 150 sites, and the contention is that somebody could have messed up when they took the average of each measurement. You're claiming that they fucked up when they took an average of.
I never said they made a mistake on each measurement. I never said they made a mistake on each measurement.
Okay, well then, if they only made a mistake on, let's say, 10% of the measurements, which would be a huge amount.
We don't know. We're just guessing now, bro. We're just guessing.
I don't know, but that's what I'm not. We're trying to see if there's any point to what you're asking for. Because if you're only claiming they messed up on 10% of the measurements, which would be fucking crazy that they messed up on averaging 10% of the sites. If that were the case, then you still wouldn't have ended up with the data. Like you seen that graph where the data matches the sphere perfectly.
Well, Kosho, we'll never know how many they did mess up on, how many they didn't. Maybe they didn't mess up on any of them. Maybe they took a weighted average instead of the regular average, like you're saying. We don't know because we didn't see the measurements they took. We don't have any measurements from this to even look at, to glean anything. It's all a guessing game now.
Not, man. I'm telling you, there's no reason for any of the things that's being suggested, and there's also
if
no
I told you I had
reason
a unicorn and won't show you the unicorn, is that reasonable? Would I say you're unreasonable for wanting to see my unicorn?
You're just fucking with me, dude. Because you know that
no, this is a perfect analogy.
Unicorns, man.
You said you have spherical excess measurements. I say I have a unicorn. I say, let me see your spherical excess measurements. You say that's unreasonable. You say, let me see your unicorn. I say that's unreasonable. You think that this whole conversation sounds reasonable now?
I said, let me see your unicorn. I said, fine, here's a picture. I took this picture with my cell phone. Like, no, whoa, dude. Use a Hasselblad camera and use a film that you can develop. I want to see it from an old-fashioned camera. Like, what?
Why'd you bring a Hasselblad into it?
Oh, he's looking for trouble already.
Yeah, go ahead.
Let's hear it, Kosho. Come on.
What? Why'd you interrupt me to say let's hear? I was finished. It's finished anyways, dude.
I think they would have failed.
Camera.
These people taking the measurements would have failed.
Sorry, cold welding.
These people taking the measurements would have failed in school because they wouldn't be able to show the work show. That's all we're saying.
Just remember, with that cold fusion thing, it's all about the temperature.
Welding.
Cold welding. Cold welding.
Either way, it's all about the temperature.
He's fucking fuckers now, dude. Dude, I was listening to that conversation, dude, and I was like fucking laughing my ass off, dude, because you guys all sound like assholes, all three of you, dude. You kept saying cold fusion the whole time.
Yeah, some dickhead said cold fusion instead of cold welding.
Data was the one that started it.
And then
all of you were saying it, dude. And then not only that, but he's like, I'm not an expert in it. I did a lot of research though, and I know what it's called. It's cold fusion.
He co-showed it yesterday.
That's like the only thing you know about it is wrong.
Data co-showed SE yesterday.
He did mess us up. We did. Everyone was saying cold fusion after, yeah. But anyways, I posted a thing of actual cold welding on the Galileo so-called spacecraft, which the antenna didn't deploy, partially deployed.
Oh, yeah.
Guess what? Because of cold welding.
Yeah, that's right. I remember that. Yeah, but what Data had said, I didn't even think of that. I don't know why I didn't think of that, but I totally forgot. Like if you have aluminum, for example, if you have pure aluminum, undisturbed and cleaned or whatever, it actually reacts with water very violently, and will immediately create like hydrogen gas, and there'll be a big reaction. And the reason it doesn't is because as soon as you have aluminum, like in the atmosphere, it becomes coated with oxygen. And
Yeah, that's what forms the oxide around the metal, which doesn't make a good bonding for cold welding.
right, yeah, because it has to be contact. It has to be contact the surface to surface, right? So, if the parts were made here on Earth and they were, subjected to the atmosphere, then they wouldn't have that problem. I think with that gal, if I remember correctly, you're talking about the shield, the foil shield or whatever. I think it was like
The antenna
the
did
antenna.
not fully deploy. Yeah.
Well, yeah, the
The
antenna was
most
like
important
a foil,
thing of the mission. Yeah.
yeah, it was like a foil shield thing that opened up whenever they when they got it out there. But yeah, it got stuck together. I think probably because it was probably too clean or whatever. It was like cleaned and then packaged probably without taking consideration for the oxidation.
No, actually, they
I mean,
give a different story on that.
Basically.
The story is that it was oiled, but during transport, there was movement and the oil dissipated and blah, blah, blah.
Okay.
and what you were saying, Kosha, would be a good point if the parts weren't moving. You got two metal parts moving across the surface of one another. You're going to be scratching those surfaces, wearing down to the actual metal itself, eliminating that oxide coating.
Yep, that's another thing they mentioned. The rubbing against the metal could eventually reduce the oxide. Yep, good point.
How long does that take?
Well, as long as you wear it out, it depends on how rough you do it. I guess how many times it rubs, but eventually, what Dicelo says is true. That can cause the wearing of the oxide.
Right. So if they were using those cameras on the moon for like years and years and years, that can happen. Okay. I mean, I don't think they were up there that long, so I don't think that really is concerned.
Yeah. Well, look, I'm just showing you stuff that I found, and yeah, it's even to my detriment. I could be wrong about this, but doesn't matter. I want to explore all avenues.
Sure. I mean, I think it was an interesting point when you brought it up. I when I heard Data give an argument, I wasn't even thinking about that.
No, he did bring up a good argument, and I did tell him that when he mentioned the surfaces being completely flat, and that I did tell him, well, if you watch the video, he shows two pieces that are not polished and completely flat. So
that's what I said.
One thing what's written in the literature, and another thing what actually happens.
That was the first
there's no surface that's completely flat unless like some new technology like graphene or something. But other than that, like down to the micro scale, you're going to have imperfections, peaks, valleys, and troughs across any surface. So, I mean, to what level are you actually standardizing this at? But furthermore, I just wanted to say, Dad is writing a book on cold fusion. You can buy it on Amazon.
He's full of shit, man. He's never going to bring that book out, ever. So let's not do that. He's not here to defend himself. Another thing I found out is that material, like, it doesn't have to be like, okay, cold fusion can happen when you press the material together, right?
Cold fusion.
But there's also another kind of fusion.
You keep saying that. You keep saying cold fusion.
Damn it. Sorry. Cold welding. I'm sorry, guys, man. Freaking data. So cold welding can happen in various different ways. You can touch the material together and press it, right? Squeeze it together. Also, if you twist it, they have a different name for it. Right. If you take two metals and put them together and you twist them, they all also stick together.
Yeah,
so there's more than one way it can fail.
That's friction.
Yeah.
That's more to do with
friction welding.
Yep, that's right. Yep.
And that's what I originally was thinking of when that's why I said it had to be smooth, is because and for that to work, it does have to be smooth. Like it does have to be.
You'll notice people that do a lot of bolts, that when you screw a bolt too fast, you notice that it jams. Sometimes it just becomes one. That's friction welding, what Left Lane just said.
Yeah.
So there are a lot of things that could go wrong here.
Yeah, the thing about the vacuum, like it's not about the pressures that cause the cold welding. It's just the fact that it's there's no atmosphere.
It's all about
the removal of the oxygen and the pressure both combined. Yeah. But the removal of the oxygen is very important.
What did you say
So
about the
there's
temperature?
various forms.
It has nothing to do with the temperature, man.
It's all about the temperature. Tell him, Messi.
Yeah, he's on it like yeah.
No, dude. You brought up unicorns, man, just to trigger me, dude.
Bro,
you guys brought up
listen to me.
Yeah.
You tell me you got something and then you won't show it to me.
I'm not sending you a picture of my cock, dude.
What? I mean, dude, you're telling me you got this thing, you won't show me. Like, what do you want me to do?
That's my ex-girlfriend. She's probably got pictures. When Napalm gets in here, dude, talk to him about it. Not about my dick pic. I'm saying about the about the data, dude, because he agreed that there's no point arguing that.
Like, yeah, there's no point in arguing this because we don't. You said you had spherical excess measurements. I don't have a single one. So.
Yeah, but what they're considering the measure data, the measurements, is simply just the measurement, taken several times and averaged out.
Maybe. If they ever even did it, we don't know because we don't have any single measurements to look at.
They probably just guessed the numbers. That's probably
yeah, probably. You know, your boy Maktoon says there are no measurements, right?
Yeah, I never.
Maktoon is Coach Ho's favorite. That's Coach Ho's favorite guy is Maktoon. In this whole thing.
He's not. His name's MC Tune, just so you're clear, but it's also not my boy. So he's a Glober. He believes the globe. I believe the globe.
That was funny. The other day, we're asking somebody to get something of spherical excess, and go have a look. We said, and who did they come back with out of the whole internet? Maktoon. Maktoon's webpage.
Yeah, if you Google like this survey, or you Google spherical access, or you Google what's the other one called? Reciprocal zenith angles. His website's one of the first ones that come up. Yeah.
Imagine that, huh? And our websites are in the 56th page, way at the bottom or something. And Maktoon is first. Imagine that.
What's it? How's your connection, man? Did you want to try to repeat what you were getting out earlier? All right, no worries.
Yeah, but yeah, I mean, like I said, we're probably the only people talking about this subject, so it kind of makes sense. Like at first, it seems surreal. Like who was I searching for the other day about the cameras, and on Quora, like Scott Veach was the dude that was answering the question, but he actually wasn't answering the question about cameras though. It was like a suggested question. I forgot what it was. It was funny though.
Yeah, the algorithms have you guys in there trying to mess things up. Like it's crazy.
Hey, can you guys hear me now?
Yeah.
Yep.
Hey, so why do you keep saying that they just take the averages? I don't understand why you people do that, bro. Like, I just dropped pages from the freaking document explaining that they literally transform it with an ellipsoid model before they put it in the observed column. They literally transform it. The way that you do it is you get the measurements and you have to transform them to azimuths using your latitude, using your spherical coordinates from latitude.
Yep, that's correct.
Okay, so then you do bake the spherical model into the observed column.
That's the measurement. I don't know why nobody else said anything when you said that, and I was curious because I know there's people in here who know that, but that's the measurement you're taking. You're taking the azimuth of that position to the other ones.
Right. So you have to assume the sphere before you even write something down. Now, what they want to talk about is they just went out there and they just looked through a theodolite and then they just wrote down an angle and then they added them up, and it just so happens that it's greater than 180. And the actual document says, no, you have a plane triangle and you transform it with the azimuth transform using the spherical model. What a joke. What a joke. And then, of course, yesterday, with it, you said you didn't have the raw data, but apparently on down at the bottom, they do have the actual measurements. Apparently they do have it, page 566. So 556, I just go look at 556, and it's, again, got one specific measurement. It doesn't have all of them. And why are people lying? Like, what's the purpose in lying about it?
Have you ever considered that nobody's lying to you and that possibly maybe you're learning new things about this all the time? Because the azimuth measurement is not some sort of shit where you have to consider the globe or anything. It's literally just the azimuth.
Well, that's funny that I just dropped the actual document. Either we'll read the document or we'll listen to Coach. Because the document says that for the azimuth, you have to use the Clark spheroid model and actually transform it. And yeah, they are objectively lying, because when we say, where's the actual measurements that you claim they used to get the average, they say, oh, it's down at the bottom. We actually do have it. And then you go to the bottom and it's just one measurement. It isn't all the measurements. So yeah, that's called lying. That's called lying.
So it's not lying. Like I said, if it's only lying if someone's making up a lie. But in this case, someone's telling something to somebody who is learning about it in real time. And that's what I'm saying to you, that
I'll just keep on ignoring what I just said. Over and over, you're going to ignore what I just said. Just gaslight me.
No, hold on, dude. You don't have to interrupt me to say that I'm gaslighting you, dude.
Fully understand. Left Lane tagged me and said, apparently, the measurements are in there, Austin.
Yeah, they are. Okay. They absolutely are.
Shut up.
You were interrupting me, dude. This isn't the Witsit show. We're not going to talk about your fucking paintings, dude.
All you do is lie. All you do is lie. That's all you do. All you do is lie. Now you're trying to backhand and gaslight me. Oh, you're just a little kid trying to understand. So you just don't understand. No,
they said that the liars, dude.
Yeah, you're lying.
If I tell you the truth that it's not people are lying, but you just don't know what's going on yet, that's not fucking gaslighting you. That's telling you what it is.
You don't know what's going on.
Do you understand that the corrections made are made after the measurements? And they're explicitly
I get that
stated.
You can repeat the script. Congratulations. You can do what a 5-year-old can do. You can repeat scripts. I'm so impressed. I actually read through the document. You haven't done shit. You haven't done anything.
What's this then that I'm posting?
Okay, those are just single measurements. Those are not
all measurements. These look like corrections to me.
Hey, is that 18 different measurements from one location, Kosho?
These look like corrections to me.
Hey, buddy, is that 18 measurements from one location? Yes or no?
These are corrections. Corrections.
He'll never answer. He'll never answer. Hey,
what are you talking about? I just posted corrections. Well, I didn't post 18
Are
anything.
the 18 original measurements in the document? Yes or no?
The 18 original measurements? There's more than 18 measurements in the document.
No,
yes.
there's 15 to 20 at each location, roughly 18. Answer the question.
Each location, and those are averaged.
Okay, so are those measurements in the document?
No, the average is.
Okay,
that's the only thing that's relevant.
Now listen carefully, okay? They were talking about how we don't have the raw data, but they keep saying raw data, but then Jeremy and SC are correcting them. We don't have the raw data. Listen carefully. Then they came to me yesterday and added me and said, turns out they do have all the raw measurements in the document. Oh, they were wrong.
They're considering raw measurements are the averages of each measurement.
No. They came and told me that they do have all the measurements from each location. That's what they said. That's what Left Lane said. That's how they were presenting it. So then I had to go to the live stream, go check the page they claimed, and sure enough, it is in no way the actual original measurements. So that's called
what they're considering original measurements are the averages.
No, they're literally offering a rebuttal, just like to SC. They're like, we do have those. Actually, it's not just in the field notes. We actually do have them. Turns out we do have them. We found them. So they were lying. They were claiming that all the original measurements from each location actually were listed in the document at the bottom. And then when we go look at it, they just say it for 20 minutes.
then we go look at it, and that's not what it is. That is not what it is. That's called lying.
Regardless, the page that I posted,
Regardless.
the corrections that are made from each position. There's several corrections that are made, and they're explicitly stated what they are. This is after the original data is. So this is separate from the observed data. The observed data, which is what's being referred to as the raw data, these are averages. That's true. But that goes without saying.
Because I just read it yesterday. So first of all, you want to make sure you skate past the fact that what happened was I pointed out that they were lying. You interrupted to just talk about how I just don't understand it yet. And you were wrong. And now that we've had to talk through it and prove that you were wrong, now you just, regardless, no, not regardless. You don't get to gaslight people because you're retarded.
Nobody was talking about them yesterday. I was talking to Jeremy about the raw data, right? So like you called somebody a liar in that conversation. It has nothing to do with anybody you talked to yesterday.
No one was talking about you. No one was talking about you.
We literally just were.
No, actually, I was explaining what they did. You jumped in to say that they weren't lying. I just don't understand it because you're a douchebag. So now you get checked because you jumped in and said they're not lying. You just don't understand it. But you're wrong. They were lying. And now that I've explained it and that you were wrong, now you're just saying regardless and changing the subject. That's what you did.
I'm not saying regardless. I'm saying you should check yourself, dude. We were literally just talking about how I was expressing to Jeremy that this was raw data. That's what we were talking about when you jumped in, right? So if you're talking about people from yesterday or whatever, that's great. I'm defending myself because we were talking about the data I was saying was raw. Yeah.
Dude, you heard me. Now listen carefully because you're getting exposed. I'm tired of you. I specifically brought them up. You jumped in and said, no, they are not lying. That's what you said. They're not. You didn't say me. You said they. In response to me saying they lied, you said they are not lying. You just don't understand. That's what happened. This is where you're going to double down the lie. This is where you're going to double down the lie.
I'm obviously talking in the context of the data I'm talking about is there. Okay? If somebody said something different to you yesterday, I'm not going to be able to refer to that because I wasn't there.
And your dumbass should have jumped in and said anything to me.
I'm not jumping in, dude. I was in the middle of a conversation with somebody else that you jumped in.
No, so what you started the entire thing that's going on right now because I explained that they were trying to claim that they did find the raw data yesterday, Blue Marble, and that Left Lane was telling me about it, right? I said they were claiming, but of course, when you look into it, it's actually not the original measurements, but they were claiming that they did have all the original measurements for each location listed. You jumped in and said, they're not lying. You just don't understand it. That's what happened. We all heard it. Yeah. Okay.
I'm not going to keep repeating myself to you, dude. I don't know why. I don't know what the point is. Like, I'm literally talking about something that I said to Jeremy. If you're talking about a different thing entirely, then what's the point? What's the point of fucking being in a conversation?
Well, maybe. So what you're saying is you didn't actually listen. Now you're saying you weren't listening. So it's my fault. It's my fault that you weren't listening. So you took what I said to try to use as opportunity to try to talk shit to me. So now you're the victim. What a joke. It's a joke. Okay. And what I did was actually drop the pages from the document explaining that they 100% do transforms before the observed column. Before the observed column, they use the transform from the astronomical position, the spherical coordinate systems. They transform them and they use geodetic coordinate systems using the reference spheroid model. Before they put them into the observed column, they run them through the reference spheroid model to use the spherical coordinates to get the azimuth. Like, I'm just so tired of people lying. It gets on my nerves.
Dude, what you're saying doesn't even make sense, dude. There's really no point. There's no point responding to any of this bullshit, dude. Like they have 180 degrees, not because they're using the azimuth of their position. Okay, they're using their azimuth in relationship to the other positions. They don't have to reference a model to do that.
Well, you're wrong again. You're wrong.
No, dude, why would they end up with 180 degrees if they were using the azimuth as opposed to or the azimuth to the north as opposed to the azimuth?
Yeah, this is so funny. It's going to be so embarrassing for you. So they have they specifically lay out that the relationship is 180, and they have to transform that over by taking my position relative to the other position and running that through spherical coordinate systems using the reference spheroid to take the plane triangle and then to make it a sphere triangle to get the relative angles based on our geographic positions run through the spherical coordinate system.
What you're talking about is what they did in the corrections. They didn't do that in the raw data measurement. They used the azimuth to the other positions in the raw data.
No, dude, before the observed column, they run it through the reference spheroid. I just dropped all the pages. I dropped all the pages for everyone to read. You haven't read it. 100% you haven't read it. You're listening to other anti-flat earth. You've read 900-page document.
No, I have. I've read where all the corrections, were explained and how they're supposed to be.
Oh, what about before the corrections, though?
Yeah, those are just the raw data measurements are just the horizontal component of the angles to each site. That's all.
Just because you keep saying that, because it says that they have to take the measurements and run them through the spherical coordinate transform before putting them in the observed column.
Which page is that says that?
Go read it. Go read it, dude. I know.
Earlier. So which one is it? The one that you posted up a bunch of pages. Which page is the one that says that?
I don't know. I'm driving. Go read it.
Okay, so you posted a bunch of pages, right? So which page? What else is on the page?
I don't know. So you said that you knew what it said, and then you admit you didn't read it, and now
let's find out if what you're saying is true. Just tell me what else is on that page. Like what's the context of that statement, so I can see which page it's on.
Explains that you have, and actually, what you need to do is go look at these pages and read the next couple pages. They have 180 degrees. They do not exceed 180 degrees. I forgot the terminology. It's called. I'm driving, man. Go read it. It's like stations. It's like it says stations differ 180 degrees. Right? Stations differ 180 degrees. Do you know what that means?
I have to look through your documents to see if what you're saying is true or accurate. So you have to give me a second. What's it? You posted 10 pages. You don't know what else is on the page. So I have to look through each page and see where it says exactly what you said. So
it explains that you have a geodetic line, you have a line of alignment, and then you have like an arc. Okay? And for intents and purposes on small scales, they're all the same. And it explains that they're fundamentally different. They're fundamentally different. Obviously, a geodetic line, an arc, a line of a segment, these are different things. Now, the actual stations differ 180 degrees. So they have to transform them over to the geodetic coordinate system to actually get the relative positioning of you and the position that you're observing. I think it's like section 7.
Yeah, you've been telling me, everyone's been saying for a while, these are just a regular average. The observed angle column is just a regular average of the actual measured angles. Right?
Sounds like he's talking about two different things now, dude. Because there's two angles. When you're doing spherical triangles, there's two sets of angles for that triangle. Like there's the angles along the surface, right? And then there's the ones that you just brought up, the arc angle. And that arc angle, you would need to reference the spheroid, the size of the sphere, because you have to have the radius to determine that. But that's not the measurements that they're taking to each site. That's a different angle. That's the angle that represents their difference. I mean, their distance. That's the arc length. And you can get that by you can convert that arc length into an angle.
What does it mean by the terminal stations differ 180 degrees?
I don't know.
Okay, so at every point of which the azimuths of the terminal stations differ 100, respecting the nature of the curve connecting two triangulation stations, we may regard it as a line of segment. Clark, in parentheses, because it's referencing the Clark method, at every point of which the azimuths of the terminal stations differ 180 degrees. It has the advantage over a geodetic line of having the direction of its first element at each station coincident with the direction of the light when pointed to the opposite station. Whereas in the case of the geodetic line, there's an abrupt angular deviation which calls for special computation since the line is not directly observable. Both curves are tortuous. I said tortuous, not tortuous. With respect to length between two fixed positions, there is no practically appreciable difference whether we conceive the connecting line to be an elliptical arc, a line of segment, or a geodetic line. The line of alignment, like the geodetic line, ordinarily lies between the two elliptical arcs, but the latter line may deviate widely from or be wholly outside them under certain conditions, depending upon near equality in the latitudes of the terminals. The geodetic positions of the astronomic stations, as derived from the provisional position computation and checked by a double computation, are given in the following table of comparisons of astronomic and geodetic values. The astronomic latitudes are taken from part 5, azimuths from part 4, azimuths from part 5, and longitudes from part 6. Then I have part 7 right underneath it. That explains that you have to base it upon the Clark spheroid of 1866. So it says specifically that the azimuths of the terminal stations differ 180 degrees.
I'm still trying to find this page that says this.
So it takes the plane triangle and transforms it, man.
Oh, so when it says 7 in Roman numerals?
Yeah.
Okay.
Show me a measurement that does never use the transform.
This is simple too. If you take a spherical geometry and you try to describe a ruler as being straight, it's impossible. You can't describe a straight ruler, even though it's objectively straight. If you use spherical geometry, you can't describe it as straight. It's spherical geometry. There are no straight lines.
The problem too is even in their own writings, a straight line in a geodesic is actually a longer path. That's according to their own theory.
And like you said, I openly admit I don't know all about this, but that's the problem. You guys, the anti-flat earthers, pretend they do know all about it. They're all in the chat. Witsa can't do math. Not one of the anti-flat earthers can do this math.
Okay,
this math is incredibly dense.
Did you understand?
None of them.
Did you understand? Hold on, Data. Hold on. Did you understand that spherical triangles have 2 sets of angular components?
Hey,
you understand that they could be talking about one versus the other?
Do spherical triangles equal 180?
Did you hear what I just asked you? It's a very important question because the angles on the surface represent the triangle that we're all thinking of, but there's another angular component of them, and it's the each of the sides. Each side of the triangle can be converted to an angle. This arc, the same as the arc.
What's the azimuth? What's the azimuth? How do you get the azimuth?
You can use the horizontal component of the measurement to the other positions. The other
and then you have to make it an azimuth, right?
Yeah, you can get that by taking the horizontal component.
Well, you take the actual measurement, then you make it an azimuth. You take the observation and make it an azimuth. Okay, so this is describing that the way you make it an azimuth is you use the Clark spheroid method. Yeah, this is the death blow, and I looked into it for 20 minutes.
You have to transform it.
Fucking 5 years, you guys been
always
talking
goes
about
from
this?
first order to third order.
I'm freaking launching 4 businesses. I'm super busy. I can look into the PDF for 20 minutes using Control F and figure out that you guys are baking in the radius value, and you've been in it for 5 years and you guys don't know. Just wait till I finish getting to the bottom of it. Dude's gonna have to hide from the internet.
There's always the first order, second, and third order, right? So it goes from first order, and these calculations for spheroid will usually use third order measurements for it. That's just, I took this to Bev's channel about 2 years ago, asking him how they use the logarithm, because a lot of these calculations end up using logarithms in their calculations. That's what I looked for the paperwork. He tried to explain it, failed. They don't really like wanting to explain these transforms or these logarithms in these angle measurements. So
what Data just said is full of shit about Bev. Full of shit.
I brought also the law of sines to Bev, and he was dishonest with it. It's all there, dude. He wasn't straight up, man. So Bev's not 100%.
It's all recorded. He's got a fetish. He hates Bev, and that's all he talks about. And it brushes off on me as well. All he said about Bev is a lie.
Anyway, let's get down to the bottom of this real quick. So the observed angle column, right? Is that a regular average of the measured angles? Like they've been saying yes, but we don't know because we don't have the measurements. And you said it says in the paper that it's weighted.
Okay, so this is the trick that they're doing. Okay, they're talking about azimuth angles, right? But what you do is you go out in the world, you make an observation, and then you have to transform it to an azimuth. Okay? So then they take the azimuth angles. They're like, look, we just averaged the azimuth angle. What they did was bake the sphere into the transform to the azimuth. So you see how they're like technically not lying, but they are lying, right? They go look at the stations, they get their measurement, and then they turn it into an azimuth. So they get their observation, turn it into an azimuth using the spheroid method, and then they record it, and they record that as an observed angle because it's based on the observed data, then transformed into an azimuth using the spheroid method, the Clark method specifically. And so then it doesn't actually specify how they take the average. It does at places say that they attribute equal weight on smaller triangles. So I haven't got to the bottom of that yet. None of them will answer. They say, "Oh no, it's just an average." It just doesn't say it. It doesn't also tell us. Blue Marble said it doesn't tell us the kind of binding that holds their book together either. You know, as if that was the same. So I don't know. I haven't got to the bottom of that. But what we have found the whole lie though, which is that when they turn it into an azimuth, they use the reference spheroid model. And I'm going to go more into detail when I fully get to the bottom of it, of explaining how they do that.
That's some weird fallacy right there. What Blue said about we don't know what kind of bindings that holds the book together. Like that's got to be a fallacy. I don't know the name of it though.
Yeah, like that's totally weird and not analogous at all.
So yeah, that's why we want to see this raw data, the actual measurements, the thing you say you have, so we can see what kind of average it was, if they know how to do it, may even do averages right, if they threw numbers, whatever. Like we just want to see the data. If I tell you to measure a 2x4 in a backyard, and you come back and say the average is 10, but you measured once 5 feet and another time's 15 feet, I'm like, yo, you don't know how fucking tape measure works. I'm gonna need to go redo this.
Sorry, I got worked up, man. I don't like when people like. I don't like that. You got one person that's trying to understand it.
I mean, take it easy on Kosho, bro, because if Kosho leaves, Xanix's gonna clock in.
Yeah, touche.
You mean Kosho hasn't trained his replacement yet? I mean, it's going on 5 years now.
Well, if this is true, if your own book says that the observed data has the original adjustments caked in, if your own manual says that, I mean, what are you guys arguing about? It's game over.
It doesn't say that.
Wasn't it?
Like I said, it's important to understand that they're talking about two different angles. They're talking about two different angles.
Are you looking at first order measurements, Kosho?
Yeah, so the azimuths, the azimuths,
first order and third order measurements.
The azimuths are just the angles they get from measuring the horizontal component of measuring each position to each other. The angle that they're talking about and the part he's talking about is a totally different angle. Like I said, there's two sets of angles when you're talking about spherical triangles. One is the angles along the surface, and one is the angle that corresponds to the arc length. Okay, and that they're talking about that.
They're talking about actually getting the azimuth to put it in the observed column, and that you have to run it through the reference spheroid model. That's what they're actually talking about.
It doesn't say that.
It does say that.
It says whenever they want to. So it says, let's see, it's what they're talking about is getting the actual distance, like the actual arc length, the actual arc that corresponds to the distance, which they can't just use the distance to do that.
Hey, what does it mean when it says, respecting the nature of the curve connecting two triangulation stations, we may regard it as a line of segment at every point of which the azimuths of the terminal stations differ 180 degrees?
They're talking about they're talking about two angles in the same sentence. It's important to be clear about that. They're talking about two separate angles in that sentence. They're talking about the angle that represents the arc length, the segment as you just described, and they're saying they're talking specifically about the segment that connects two stations where they're measuring these spherical triangles.
At every point of which the azimuths of the terminal stations differ 180 degrees. What does that mean?
That's the spherical triangle on the surface.
180 degrees is the spherical triangle?
The ones that differ 180 degrees. That's right.
Differ 180 degrees means it's 180 degrees, dude.
No, they said they differ from 180 degrees.
No, you don't even know what the words mean. Go look it up. Go look it up. You don't. This is what you got. This is why I get frustrated, because you guys act like you know stuff you don't know. I'm admitting I don't know. I'm trying to figure it out. You guys are
you
using that
understand
against
that
me.
they're talking about a
it's
different
not. They
angle.
don't differ from 180 degrees. The difference is 180. They differ 180 degrees. You just took that, completely bastardized it, and said it differs from 180. No,
Okay, no,
it doesn't say that.
no, yeah, now I understand. So yeah, they're talking about the segments along the line, 2 points along the same segment, or multiple points along the same segment.
Yeah, to connect the two stations.
Well, to connect multiple stations, yeah. It says at every point. So they're connecting they're connecting a long segment so that it can be the same arc, and they want to measure the entirety of the arc.
The azimuth of the terminal stations, which means the end of the line at the station, terminal station. The azimuths of the terminal stations differ 180 degrees.
Right. Okay.
Right. Okay. So then it's explaining that, like, in certain cases, you can basically treat them all like the same, but they're fundamentally different. Obviously, the line from one to the next is fundamentally different on a globe and on a plane. And other screenshots I have there explain where they get a plane triangle and then transform it into the spherical triangle.
No, but this they're not talking about triangles at this point, though. They're talking about measuring.
That's why I said in another page.
Yeah, I know, but this page specifically is talking about measuring an arc.
All right, let's see. Tell me what's wrong with this then. We'll just read it. The text describes the process of determining the standard geodetic data, latitude, longitude, and azimuth of astronomical stations along the 39th parallel of latitude. This was done as part of a larger project called the Transcontinental Triangulation, which involved measuring the angles and lengths of sides of triangles connecting astronomical stations from Atlantic to the Pacific Ocean. The first step in determining the geodetic data was to make a preliminary computation based on the adjusted angular measures from the triangulation, which were obtained by satisfying the internal geometric conditions of the triangles and making sure the lengths of the interspersed baselines agreed. The computation was made using formula found in the Coast Geodetic Survey Report for 1894, which were based on the Clark spheroid of 1866. The results of preliminary computation were then compared to the astronomic values, latitudes, azimuths, and longitudes obtained in previous parts of the project. The table at the end of the text shows the comparison of astronomic and provisional geodetic measures for differing stations along the 39th parallel. The preliminary computation of the geodetic coordinates of the astronomic stations were based on the Clark spheroid of 1866 and was performed using the customarily employed formula on the survey. The spherical assumption was applied to the raw observed measurements in the form of the Clark spheroid, which is a mathematical representation of the Earth's shape, to obtain the preliminary geodetic coordinates. These preliminary geodetic coordinates were then compared with the astronomic values to determine the standard geodetic data, latitude, longitude, and azimuth. What's wrong with that?
Well, in the data, it shows you where they put those corrections in. So I'm not sure how they can have both the corrections that you're describing, and also that be different from the measured values. Like the measured values are in there. Those corrections you just described are in there, and then the corrections that you obtain are also in there. So
okay, this is what the anti-flat earther does. Okay, so there's a whole bunch of different corrections laid out in here. Some of which actually transform the actual observation to the azimuth before it's recorded. And then there's a spherical excess formula and weighted equations applied to them, okay? You have the correction column that applies the spherical excess formula based on the model to see what the difference is. To see the difference in what they get when they make the transform for the azimuth and the observed angle, then they correct it in the correction angle using the spherical excess formula. Now, every time that we point out that they're fudging the data, they want to claim just baselessly because they're literally making all this up. That's why MC Toon says the observed column is actually just taking averages because they can just lie. Okay, so you have every single time, and I asked them this yesterday. I asked Larry, who obviously I think you would admit knows more than you. Larry, that's the guy you were talking about the other day that knows tons about it, right? That's what I was talking to yesterday. And I asked him specifically, wait, you guys, of course, understand that the weighted equations are different than the spherical excess formula. So are you claiming that they're both applied? They're both applied in the correction table? Cricket. I don't know. I have to look into it. Oh, I don't know. Crickets. Go on mute. Dropped out of the. This is Larry, your guys' hero.
Well, Larry, that's Larry GPS that's that dude from Gems. I actually went over this with him a while ago, and he said, yeah, we should see the actual measurements. I'm gonna email him or just try to get the field notes for this. So I ain't heard from him since. That was like 8 months ago, maybe.
Well, yeah, they've now moved to it doesn't matter. That doesn't matter to them. But they're basically claiming it's just a raw average. I asked them all to cite it, and then their response is, "Oh, they don't tell you what kind of pencils they used either." What? What are you talking about? So, anyway, the point is, every time we bring up these different stuff that they say they reference the spheroid model, they use the Clark method, and Clark specifically says that before you write anything down, you have to run it through my method, assuming the Earth's a sphere. And then he writes in depth as to why he thinks that assumption is justified, because if you go to the bottom and top of a mountain, the way the boats look is different. Okay, that's literally what is in Clark's paperwork, and that is what they're referencing, saying they use the Clark method. The Clark's method says you do assume a sphere from the first second that you start to do anything, and you have to run what you see through the spherical model. That's what Clark's method is. That's what they claim that they're using. And every time you point out, well, look, it said they're using the Clark spheroid for this and this and this. They're transforming the azimuths using the astronomical geodetic positioning based on the spherical coordinate system from the Clark method. They're like, oh, no, that's just a correction column. They just say it. They just say everything's a correction column.
Question for you: Are they using third order then? How to do it? In other words, as they make the measurement, they're assuming that their order is by assumption rather than first order was his actual measurement. Is that right?
That's what we're trying to get to the bottom of, yeah.
Yeah, so usually what I find is it's third order calculations for the spherical model. That is what they use. In other words, it's a formulation before measurement. And that's what the
why don't you look through this PDF, bro? You're one of the people that we need to look through it.
Well, I brought this shit already to Bev, and this is what I did.
But Bev's Bev's a flat earther, man. I'm talking about the Globers.
Yeah. Well, I asked him about first and second, third order measurements and how we could break down these, because they like to use logarithms, right? In the early geodesic survey.
They use the logarithm equation for this, yep.
Yeah, so that's what I tried to get him to answer, and he had a hard time struggling. So there is, even the people at the top, because I don't know exactly everything when it comes to first, second, third order. I do know that when you do measurements, you have first order measurements, and then if you're going to do third order, you have a calculation that you start first. You use first, and then you take your measurements under that third order premise. But I haven't applied any of this stuff, so I've been asking, and there is very little. Kosho doesn't know about it. I think Rumpus knew a little bit about first, second, third order measurements, but again, he doesn't show up these days. So yeah,
Rumpus doesn't know anything about this stuff. Like, we don't need to talk to flat earthers. This is the Glober's #1 proof the Earth's a ball. Physical measurement of Earth curvature. It was done in this triangulation. Oh, they went across the United States, proved the Earth's a ball. Okay, so they're claiming they went out, they just wrote down the raw data. They just made up measurements, wrote it down, added them up. Oh, look, everything's greater than 180 Earth's a ball. That's what they're claiming. Okay, but when you actually look into it, it's 900 pages of explaining how they completely fudge the data, and they reference other surveys that also fudge the data. They take those surveys, then they put them together, built upon that, they do additional surveys. Okay, so you could go through each survey and find out it's all spherical assumption. And they're literally, to say that there's no spherical assumption baked in when they're using other surveys whose final product had to use a spheroid model is retarded. And the point is that we want to get to the bottom of what the spherical assumption is. There's 900 pages. I'm like, I have a 2-month-old baby. I'm trying to make children's book. I'm trying to launch NASA audits. I have a summit. There's no way that I can look through every square inch of the 900-page document by myself. I think that a bunch of flat earthers should be helping. The Globers are not going to help. The Globers are just going to repeat MC Tune until they're forced to say otherwise.
I think the secret is in the logarithm and how they apply it to the first order measurements. And that's what I think it is. And I haven't seen any videos on how to do it. I haven't seen any. I'm searching this stuff for a couple of years. You give up as you go along, but you don't find exactly what you need. But that was my issue is getting the first order measurements, the transition to transpose it to third order. But then while you're doing that, you have this logarithm calculation that you're applying to these distances, right? And what's the logarithm
Dude,
about?
Left Lane, why are you saying that we ignore the survey? I sat there and talked to them, and 4 anti-fire zealots wouldn't even let me respond to him for 30 straight minutes. And I asked him, I only got like 4 questions out, and 3 of the 4 questions he couldn't answer and said, let me get back to you. So what do you, it's just a talking point. Oh, there's a geodetic surveyor and you guys won't talk. No, I asked him 3 questions. He said, I don't know. I'll have to get back to you. He didn't even know the basic questions that I've come up with looking at it for a few minutes. So can you guys stop lying?
Yeah, and notice how
over
Data, once again, whenever he speaks about geometry or anything, he brings out Bev, because Bev smoked him so badly, he has dreams about him. Don't believe anything he says.
Yeah,
honestly,
hey,
hold on, let me finish. I'm almost done. You can wreck me after. Hold on.
My God.
Yo,
Just
everyone
hold on.
As this fucking baby shit.
Let me
dude.
just say something here. And with it, I suggest if maybe you should pay a visit over to Bev's. I don't think you've ever came over once, bro. I suggest you come over for a chat.
Now, is Bev going to help me look through this 900-page document? Because that's
Bev
what I need help
doesn't know how to apply.
Bev
doesn't know how to apply logarithms to first order measurements. Give me a break.
No, he's gonna.
Bev actually helped me look through this document, so he might give you a shot. He might give you a hand with it, because I brought this to Bev 2 years ago when Bev took a look at it for me.
Okay.
Yeah, seriously, with it, don't listen to what Data says. It's all.
I don't care about any of the drama, man. We need to figure out a specific answer. Okay, what are they doing to the measurements before they record them in the observed angle column? That's what we need to find out. Okay, that's what we need to find out. I think this is very important. Okay, to a normal person, they hear, oh, they did a huge elaborate measurement for many years and they measured spherical excess everywhere and it matches the globe prediction. They hear this lie and it's like, oh, wow, that's going to, and then they look through it, they get overwhelmed with the math, they get overwhelmed with how extensive it appears. They're like, wow, this is crazy. And the earth must be a ball. And then they just get caught up in the simplistic understanding that spherical triangles have more than 180 degrees. So this is a big deal. This is the only thing the Globers have for physical measurement. If you can't physically measure the curve of the earth, you don't have anything, game over. This is like important. I think that, in my opinion, flat earthers should all get together and help sift through it, because their heroes, Larry, he doesn't know how to answer any of my basic questions. He couldn't. He's like, oh, I don't know. I said, did they have a window of acceptance? I don't know. So what? So they just accepted all model? You're claiming they just wrote every measurement down and put it in a raw average? Oh, I don't know. I'm like, oh, so if they have a window of acceptance, what determines their window of acceptance? The spheroid. So, I don't know if that's in there.
Yeah, I had Larry looking for this raw data, the actual measurements for the past fucking 8 months or so. So yeah, I mean, there's nothing. I mean, you could play around with this, but there's really nothing to do because we don't even have the measurements. So, like, I went over this.
This is what I brought. This is what I brought.
There's nowhere to go.
I disagree.
Yeah, so this
there
is
is
an
somewhere
example.
to go. We need to figure out what they're doing.
Well, this is what I'm trying to tell you. The law of signs. I did this at Bev's show, so I brought this example up. This
Here it goes again.
This very thing we're talking about, I brought it up. So the idea was I would take a law of signs formulation and I would calculate the distance to mountaintops to find out if I can get the height to my angle, knowing, for instance, the law of signs, if I know the distance between 2 points and I know those 2 angles to that 1 point, I can use the law of signs to determine the height of the mountain. And if this is the case, then I should be able to do all these surveys from point to point in distance of, let's say, 100 miles in between, 60 miles. 60 miles in between all of these mountains using the law of signs.
How the hell are you going to measure anything?
Let me finish. Let me finish. It's mountaintop to mountaintop. Okay? Mountaintop to mountaintop from where I'm at. I live around mountains. I brought this example to him using the law of signs to do mountaintop to mountaintop. He fucking
60 miles. That's where you were laughed at.
Again, it's from point to point. It's a total mass of 60 miles. It's a distance of traveling in total 60 miles from point to point. So you're doing segments of 60 miles distance of total segments using the law of signs, which has been done before. So when I brought this fucking example, it's already been done before. Bev tried to fucking champion it like he's some smart motherfucker. Oh, you can't use this. You can't use this.
You
It's
see how
been
hurt
done
he is? You see how
fucking
hurt he
for.
is?
No, because you're lying. You're
He's a
lying.
wounded. He's like a
You're
wounded
lying
animal.
again. There you go. Again, you're lying and then trying to attack my character when I actually brought a real life example, real math, and a real presentation. And Bev shat on it. That was disingenuous. He had no reason to shit
So
on it. It
go
was
talk to Bev. Why
shut
are
the
you
fuck
crying
up. It
about
was
it here?
all
Go
again.
talk
I'm
to
not crying
Bev.
about it. I'm stating fact.
Guys,
Every time you
honestly,
said you opened your mouth, you said I went on Bev's. Every time you opened your mouth today.
Because Bev doesn't have the answers is my point.
Oh, okay,
And
well,
when I
guess
brought
what?
him a
Bev,
real life
Well,
example, when
don't
I
bring
brought
your
him a
fucking
real life
drama here.
example,
Oh my
when
god,
I
I'm about
brought
to
him
mute
a
you
real
guys.
when I
Listen,
brought him a
Dada,
real
Dada,
life example.
Dada. Listen for a second. You're here now.
Guys.
You got people here willing to listen to the information. You got Witsit on it, stuff like that. So move on from the past and let's move forward and talk about your points and see if anybody has anything to add to them or not. Like, my God, move on.
Yeah, like we get it. You guys got beef. You and SC got beef. Whatever. Okay, I'm trying to get to the bottom of it. So you talk about math all the time. That you should be cool to help us look through this. I've already sifted it down to certain portions of the document. I've sent the screenshots. Most of them have. Someone can drop the PDF. That'd be great. But I dropped the pages that I screenshot, and that's just me looking into it. I think I sat there for about an hour trying to look through it. It's 900 pages. Half the mathematical variables are not even, you can't even make them out, right? So it's like a whole thing. So if someone can help me get to the bottom of what they
The way I
get,
see the logarithm, the way I deduce the logarithm is that it breaks down to 8 inches. Okay. So somehow they're using the logarithm and adding the 8 inches to the angle every time they make an adjustment. That's the best I can surmise. Maybe it's not fully 8 inches. It varies. But that's what I see in the logarithm as being applied. There's a Encyclopedia Britannica 1911. In there are geodesic surveys or land surveys applying the logarithm. This is what I presented to Bev. I gave him the PDF. I gave him the thing, and
Here he goes again.
I asked him to explain it. So he couldn't explain it. And I can't entirely figure out exactly how to do it because probably most likely I have to do the actual physical observation measurement and see the conclusion of it, the practicality of it to fully understand how it's implied or implemented. What I decided to do is because I live around an area that's got several peaks of mountains and I've got all the topography data. Can I find a Mercator, or can I find a point like a radio tower or something and measure my position to it and use the law of sines, which was knowing the distance between 2 points and the angles of those 2 points. And then I can gather a height distance. Through the process of doing this over a distance using the law of sines.
Oh my God, you're saying the same
listen to
shit
this
over and
nonsense,
over again,
man.
bro.
And
See,
then
that's
you
what I
wonder
mean.
why we
So
laugh
long,
at you,
just
bro.
be
What
concise,
you guys
please.
don't
Hold
understand?
on.
You guys don't understand the experiment or the observation, then, right? So
Concise,
you're
man.
literally driving around an area.
Understand.
You're making two angle measurements with.
Fuck that. Saying the same shit. You're clogging up the chat VC, just saying the same shit over and over and over again. Okay, anyways. Witsit. They said they had spherical excess measurements. They gave me this 900-page document. I went over it 2 years ago. Come to find out, there's no measurements. Where do you go from there?
okay, this is the point. What they're claiming is that the field notes would show the measurements and that the observed angle is the averages. If what they're saying is true, fair enough. You can't actually verify that it's true, but that is typically how surveying works. If what they're saying is true, you just go out there and you just make raw measurements with no assumptions. You just take a raw average, right, accounting for all the different measurements, and then it always shows you that the Earth's a sphere, and it gets more and more as you get bigger. Then that's evidence for them. Okay, it needs to be exposed. It needs to be exposed specifically as to the process, because I already know when you read through Clark's paperwork, he says, you have to assume the sphere and take plane triangles and transform them. They're never going to say that. They're going to lie about it until you force them to admit it. That's my point. I think that, yes, I agree with you. The field notes would be ideal, especially if you could find them. It'd be hilarious if we could find them because they'll probably show a bunch of flat Earth triangles. Okay, but it doesn't just stop there. That's not That's not going to explain it to a person that's new to it. That goes
How
and looks
about
into
if we
flat Earth
write
and
to
comes
them?
across
How about if
MCT.
we email them and ask for the info?
Yeah, we should. That's what I want. I think we should do that. Yeah.
Somebody should do that. I think that's where we should start.
That's what Larry said he was going to do. That's what Larry said he was going to do 8 months ago. Now, maybe they never got back to him. Maybe they don't have him. Maybe they did get back to him and Larry didn't like what he sees. Who knows? Yeah, but maybe one of us should do it. That's a good point.
Yeah, why wait on Larry? Like,
yeah,
exactly. I agree. But even with or without this, that like, okay. If you don't want to help, it's fine. But whoever wants to help, I need help to figure out what they're doing to the data before they put it in the observed angle column. And what happens is, if you just go to the Globers to ask them, if you're like, "Hey, so what are they doing here?" You're not going to get the right answer. I know nothing about it, and I've had to call them out and expose them and make them change their story 10 times.
Well, the
MC
Globers
Toon
will
and Larry.
The best I can do is,
that's
like I
just a
said,
raw average. The Globers will say that that's just a raw average. They took the amount of measurements they made and added up all the measurements and then divided it in just a regular average, and there's nothing happened there.
Yeah, but
That's
according to Blue, he told me and he sent me. That's how all this started, right? He sent me that observation, the observed angles, and he told me that those are the original angles. But now Whitsitt said he went yesterday on the show while they were doing it live, and they admitted that they're not. So what the hell?
Okay, yeah, that's right. They tried to come back and say they tried to come back and say, oh, all the actual measurements are in the document, just at the bottom. Okay, and then so the point is, why be dishonest like that? Like, why say, oh, SE and Whitsitt are saying that we don't have these, but look, they are right here, page 556, and they just show the page real quick, and the audience is just so caught up in saying Whitsitt's an idiot, they don't know. And then when you go to the actual page, it isn't that, right? So yeah, of course, they ended up admitting, oh, well, no, we don't mean like the raw data like that. I called them out. I held their feet to the fire. I'm like, stop saying raw data. Stop saying it's raw data. The raw data would be everything that you saw written down. Boom. That would be the raw data, right? And that's not what this is.
So
I'm
they're
like, stop
already
saying
exposed. They're
yeah,
already
sure,
exposed. Yeah.
Sure, but I want to bury this, and then I want to pull MC Toon on camera, go through the math, and show how stupid he is and how he's been lying this whole time. He's already freaking out. That's why he called me a bitch 20 times, because he's literally freaking out, because I've already exposed that what he says happens is a lie, right?
Good,
what he
good.
says
Nicely
happens
done.
is a lie. Yeah, but we need to go further. I want to find out, look, dude, okay, this is the truth. The Earth is a stationary topographical plane, okay? That's why I'm walking right into this boldly. I'm not afraid. I want to know what the truth is. I want to get to the bottom. I'm not afraid. The Globers are afraid. They're not going to look into this. They're afraid that that when we get to the bottom of it, there could be a spherical assumption somewhere. They don't know. They just know to repeat the script. They're afraid to look into it. They're not going to do it. We have to do it. I'm not afraid. And if you truly, understand the Earth's flat, you shouldn't be afraid either. So we should go.
Well, here's the
answer.
thing. Here's the thing with that example of the law signs from top to top, mountain top to top over the terrain. You can also apparently go a certain set distance, make a 90-degree right angle turn, go a set distance, make a 90 right angle turn, and then you will end up at the point where you started. So that's one example of the difference of non-Euclidean and Euclidean as far as distance goes, because really the argument is locally planar.
What do you mean non-Euclidean, Euclidean? What does that mean?
That's what comes down. It comes down to the whole entire basis of the argument is Euclidean and non-Euclidean environment where we live. So
what?
We
live in a Euclidean environment. We don't live in a non-Euclidean environment.
Yeah. So here's the example. At short distances, it's easy to make a box on a planar Earth, but over a distance, if you keep making 90-degree right turns, if the surface is a sphere, well, you'll end up back at the point where you started, right? But on a flat Earth, you would have a box. Does that follow?
Okay, that means what exactly?
So that's
if you have a box, you still start back where you started.
Yeah, exactly.
That's
you're
making more than
it's called a square.
Two. Exactly. But you're making more than two right angles, triangles, right? Or more than two right turns. The point is that that's their argument as far as distance goes.
Wait a minute. What are you saying? You can make two 90-degree turns on a sphere and end up back where you started? Is that what you're saying?
Basically create a triangle, right?
No, if you end
What?
up back where you started, that you'd have.
So imagine going North Pole and you're going one direction, you make a 90 turn, and then you make a 90 turn, you'll end up where you are. You'll make a spherical triangle, right? That's what happens on a sphere surface. But anyway, the point is that's their argument, is that Euclidean at small distances, you won't have that effect. But over a larger distance, you would. And that's what it comes down to. The first measurement in the 1500s was 13 measurements, and they got 60 miles or whatever, 60, 70 miles. It was 1 degree they'd measured off between all of the angles. That's what the first measurement was. And this is what apparently was to confirm Eratosthenes. I'm just giving you the raw data of what they claim. And then that measurement, the 13 angles that they measured, was used by Cavendish because he needed the size to get the density, right? So this
You see
is
what
their
he's
argument.
doing here? You see what
This
he's
is
doing?
their
He comes
argument.
into Bev, he talks
There's
like
their
that,
argument. There's
and
the
Bev tells
position.
him, dude, what in the fuck are
I
you
see.
talking
He
about?
never brought up Bev right now.
Sorry, but I'm just giving you a
yeah,
point.
we
Like,
get it. You
just
guys are
listen.
butting heads.
He's very
We get it.
emotional. He's very emotional towards me. Yeah.
No, honestly, you bring up Bev's name lots, but you didn't bring it up this time. And so, like, my God, can we have a
My bad. I'll back
conversation
off.
without
My
bringing
bad.
up Bev's name right now? And
I
Witsit,
apologize.
I got a
I just
question.
wanted to
I got a
show.
question. I got a question for Witsit, if I could, right quick.
What's up?
Witsit, what exactly, like, precisely do you want for help?
I want to get to the bottom of what they're doing to the observed data before they put it down in the observed column. They claim they just go out there, they see something, they write it down, they take a raw average, and then it ends up showing spherical excess. Okay, but I want to find out exactly what they're doing.
Yeah,
Ideally,
data.
you need 13
Could I
angles.
talk to Witsit just for 2 seconds without you interrupting, please? Please, thanks. So, Witsit, I understand what you're saying, but like, let's say if I were to say, okay, I'll give you a hand, Witsit, what exactly, like, would you want from a person to help you? Like, I get your goal, but where do you want a person? Like, where do you want the help? Do you know what I'm saying?
There's a 900-page PDF, and I'm trying to sift through it to find exactly where it explains.
Yeah,
Okay.
send it to me. Send it to me too, please.
Right, I'm on my phone in Best Buy right now, so I'll have to send it.
Whenever you get a chance.
Yeah, we want to know. What happened in the observed angles column, because that is what they're saying is just a regular average, but it could be weighted. Maybe, who knows? But we want to know what happened with that column, which is reasonable. But I mean, we'll never really know because we don't have the measurements. But
Jeremy, do you have the document, Jeremy?
I got it somewhere. Hold on.
If you do, can you just send it to me? Just because I know it's busy.
Yeah, same here.
It's also like what. So I've been focusing on that. Like, are they using a weighted equation or just a raw average? Because if you use a weighted equation, well, you obviously distribute weights to specific measurements, right? So you have to have some standard of comparison. You have to have a model or something, right? So say the model predicts 8, and then you measure 6 and 7, where you're going to apply more weight to 7 because it's closer to the predicted 8, right? Simple. Okay,
Right.
So that would be using the spheroid model, and they're basically cooking the books to make the data average out closer to their model by weighting the average. But so that's what I thought. That's what, because it looks like that might be what they're doing. But it's even more than that. It looks like before they even take the data and put it into either the raw average or the weighted equation, they're actually running it through a spherical transform. When they go to take the observation and make it an azimuth, they're actually baking in spherical coordinates to make it an azimuth. So I had to sift through and figure out what all they're doing, where they're sneaking in the spheroid model and making changes, computations, preliminary computations, all kinds of different functions that they're applying to it spherically, right? That's what I'm trying to get to the bottom of.
That's very important for people to understand. The weighted mean, right? That means they have to have something to compare against. This is very important distinction between averages and the weighted mean.
Correct.
I hope everybody gets that, right? They have
What
to.
do they say in the way they're going to do it? Because you could
That's
hold
what I'm
that up to
saying. So
scrutiny.
this is the part that's tricky. Okay, so these people aren't like, hey, there's a flat Earth globe Earth debate. Let's get to it. These people aren't doing anything like that. They are looking at it like Earth's a sphere. We're really out here on the cutting edge of surveying, trying to map out the Earth because it is a sphere, it is an ellipsoid. We're trying to take our current models and refine it and make it better. Okay. So when they do all these transforms and whenever they switch the data, they don't think that they're being shisty. They don't think they're being deceptive. They think that they're just doing what they have to do to map out the Earth. Okay. So a lot of it, it's just, this isn't like a training manual, this is like the most advanced surveyors at the time. So a lot of it is kind of assumed, or they reference things before the survey as to the methods, like the Clark method, which is a whole other document. You know what I'm saying? They reference this other stuff with these spherical assumptions baked in. That's the point. And one of the major things that they're never going to,
the sauce, man.
they're lost in the sauce, but I want to drain the sauce bowl, dude. And what is also interesting is if you read it, it explains that a lot of the measurements used for their angles, they didn't take them. They used other surveys.
Exactly.
They used other survey data before this. Now, the final product from all these surveys have already been run through spherical correction. So if you're adding like small portions of spherically corrected angles together, assuming them, and then making additional measurements a little bit longer and trying to make all that data work together, that's even more spherical assumption that's baked. So there's no doubt there's tons of stuff here, but I think
a lot of reverse
it's
engineering
very
you have to
important. I normally wouldn't like chase them around in their bullshit. Okay, but I think this is very important because every time I talk to a normal person or something, if they've just began to look into flat Earth, one of the first things they hear is there are triangles greater than 180 that were measured on the Earth, and that can only happen on a globe. And so all they do is try to understand that concept of a spherical triangle and how that wouldn't work on a globe, on a flat Earth, and then they get tricked. And I think it's important to remove the one claimed measurement of curve they have, right? So I think it is worth the time.
Yeah.
You know what it sounds
The other
like?
thing is, it has to be. The question has to be asked: when and how was this done, and when and how can one replicate it so that we can confirm this for ourselves? Hence, science, right? The whole point of the scientific method, to be able to go and confirm this and blah 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 blah, right? Because if you point that out, and then you get what actually needs to be done to do this, right? All the steps, blah blah blah. Then you just go and recreate it and go, hold on a minute, we have different results. What's up here?
Correct.
One of the
they're
problems
claiming to use the autolites for like 180-mile observations. Go ahead.
Yeah, sorry. I was just going to say one of the problems I hear that you're saying with it, if I heard you right, is basically it sounds like a shell company game. Like if they're using multiple other resources for measurements and angles and whatnot from other documents, then we also have to go start researching all these other documents and how did they come up with those numbers? Do you know what I mean? It's like layer after layer after layer.
So the best way to do it is so what happens when you point out, well, this all started because we found out that some of these actually add up to less than 180. Okay. And we're like, what in their own document, there's like over 20, 30 different ones that add up to less than 180 or right at 180, right? We're like, how does this help you guys? And they're like, oh, margin of error, blah, blah, blah. So then they just scoot all the way down to the bottom. They show the bigger triangles. And then of course, a bigger triangle has a bigger spherical excess. So they show the bigger spherical excess and they're like, look, this is way beyond the margin of error. This can only happen on a globe. So what we would need to do is say we go pick out like their best one, okay? Their biggest one, their biggest spherical excess. And then we go sift through that one. Instead of just like being overwhelmed by the document and like all the different measurements, we should all pick their best one or a couple of them. And then we should track through, well, what different surveys did they piece together for this measurement? What's the exact locations, blah, 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 blah. That's definitely the only way because I was looking through it last night and dude, you'll just get completely overwhelmed.
Yeah, that's what I was thinking by what you were saying too. You just start chasing your tail, right?
Yeah, so when I get back to the house, I'll try and pick out like their best one. I think that we should all just focus on that and then the general methodology.
So
yeah,
I just want
to expose them.
I just want to say right quick, Witsit, I'm willing to try and help on my spare time, but what I would say is like the reason why I was asking you specifically what you want, because I understand your goal. I'm going to put it this way. Like the goal is I want to get the house clean, but I need you to sweep the floor, right? And I need you to wash the walls. You know what I mean? Like put it down into a smaller package of what you need a guy to do, and then I can, if you want, try and get that task done for you or whatever.
Gotcha.
Because I almost left this Discord, like when I say Discord, I mean Discord entirely, because it just seems like there is always spinning of wheels. It's kind of, yeah, the conversations do, expand over time, but ultimately it's kind of the same shit year after year, and I've been around for a lot of fucking years. And if there's something we can do that actually will make a difference, and I'm willing to be involved. Other than that, like, it just seems like it's the same drama and bullshit, right? Like, no offense to SC and data, but that's kind of what I'm talking about. It's like, who cares? If we got a goal, let's try and work towards the goal and do something constructive. Otherwise, I'm not overly interested.
Yeah, well, don't put me in there because I just react.
No, well,
I'm on
listen,
board.
I'm not trying to create more drama. I'm just saying, it's not necessary. If we got a goal, we can work towards it. But other than that, I'm not interested.
So I brought up the law signs as an example that anybody can do in their local area to measure distance and elevation between them and the object. You can create a quadrant. You can use a protractor. You can use a theodolite if you want. But the whole point is that between 2 points, there's a known distance. There's also 2 known angles. If you do that over 60 miles and you get 13 angles, then there should be a degree off of your total measurements. Now, however that's applied, that's the segments that you have to now transform into an arc. And the way that I see that they transform those line segments is by adding a logarithm. And oddly enough, that logarithm is the same squared function as the 8 inches per mile squared. So there's a very good correlation there.
Yeah, but none of these, the thing is like, one thing I feel Bev's right about is, like, none of these instruments, like, your triangle has to equal 180 degrees. It's impossible to have a triangle equal more than or less than that, because all these instruments, no matter what you use, even if you're at different elevations, your lines are straight. So I don't understand how you could possibly transfer over to.
They're making 3 different triangles. That's why they're not measuring just one triangle. They're actually measuring one angle from 3 different triangles.
Yeah, but they're all straight lines. Like, when you use a theodolite or an auto leveler, it doesn't really matter what the instrument is. It's measuring not measuring, but it's viewing in a straight line of sight, right? Like, it's not when you start talking.
They're not going point to point. They're not doing point to point. That would obviously be 180, despite what some people think.
Well, Jeremy,
that's why they're doing 3 different. They're doing 3 different triangles.
If you're
measuring, each triangle has to measure 180 degrees, right, Jeremy?
And it
each
does.
Individual.
So here's a question for you guys. Here's a question for you guys. If you have 2 city buildings and they're 3 miles apart, and you know the height of each city building, and you use the law signs to measure the height, a distance between the 2 of them. You've got a lot of information, height, distance, all that stuff. It'd be very easy to use the law signs to see that if a building is at a certain height, is it actually an extra 3 miles, an extra 6 feet lower between the angle. So a 6 feet drop, if you know the data, you could measure that angle drop. You could measure a 6-foot angle drop in height elevation between 2 buildings 3 miles apart using the law of sines. I can just tell you it's already been done, and there's no 6-foot compensation for earth curve between those 2 points. I'm just saying that's an easy example. Go to a city, 2 city buildings, use the law of sines to get angles and measurements. You have all the information of their height. If they're going to be parallel to each other, then they're going to maintain the angles that consist with parallel. But if it's drop due to curve, then the angle would be that measured 6 feet, which would be a measurable angle at 3 miles if you go do it.
And it's funny, Gods, what you said before about me and data. And granted, yeah, it doesn't look good, but it's funny that you said you want to help and this and that. You were gone for 6 months, but I remember when you first came in, the first thing you said was, "SC, stupid. The stupidest thing I ever heard is the flat Earth." That's how you came back in.
Yeah,
So
once
yeah,
again, I wasn't attacking you. I was attacking what you were saying. Like, my God, don't you get it? This argument to say, and like I said before, I don't know why we got to go down this road again, but whatever. I guess we do. I said to say that the Earth isn't flat like a fucking piece of paper is a ridiculous thing to say, because there's not one person in the entire world that thinks that the Earth is flat like a piece of paper. I still stand by what I said, Essie. It's still
and
a
I still
ridiculous
stand by.
thing to say. And I
No,
said
it's
it to
not.
your face.
Yeah,
Well,
I'm not saying anything, but I
I'm
stand by
not
what
going
I
around
said, because
Discord.
what I was talking about is we were talking about the label flat earther, and I was talking about how really I don't want that label because it's a derogatory term. It's a psyop, president's speeches, and then you came in saying psyop, like all triggered.
That's actually that's actually not the way the conversation went. The conversation started by you saying, "I'm not a flat earther. The Earth is not flat. It has cartography." Then eventually the conversation evolved to you saying the things you just said now, but it's not the way it started.
Guys, what are you
Okay, it may
guys?
have started
Can
differently,
we
but
not
yeah.
be? Can we just not talk about drama or
Right.
something? Like,
Yeah, like, and this is the shit I'm talking about. What's it? If you want help, I'll do my best to give you help. I'm not really interested about like the fucking drama shit.
yeah,
Neither am
like
I,
I'm
bro.
gonna
Neither
try
am
to
I.
get the PDF and I'm gonna try to download it on my phone. I'll drop it. One of the very interesting things to do is I haven't done this yet, but if you control F plain triangle, that's the next thing I'm going to search through the document. You obviously have to keyword search the document because it's insane. I dropped certain screenshots. I also gave different summaries underneath the screenshots if you scroll up to my last post. And it helps kind of explain what they're doing. I have some more summaries I can give you in a second I'll be back at the house in like half an hour. But yeah, so they say that the azimuth from terminal station to terminal station is they differ 180 degrees. That means that they're exactly 180 degrees, and of course they are, right? And then in the document it explains that you have a plane triangle and that you basically transform it. Okay, you transform a plane triangle. That means, dude, this whole narrative that they go out there, they just write down measurements and they're greater than 180 is retarded. It specifically says that they have plane triangles. And I think that would be the best way to hone in on all this. So yeah, that's what I suggest is like just keyword searching it. I'll download it right now on my phone and just drop it in.
So, what do you think about that actual example in a city with a 3-mile stretch of towers, let's say, give or take between positions, and you were to measure using the law of sines, and if there is a drop, I mean, the buildings are built to spec, you got the heights between them, so you would know that there would be if they're not exactly the same height, you would have, obviously a distance between their heights to compensate, but there would be an added compensation, right? There would be an added compensation over a distance. This is what you would have, it would dictate. So you literally could go into a city and use the law of sines and measure over a distance of 3, 4, 5 miles easily, make like a line segment across it, measure all the tops around it, and you would compare the data that you have. It's a very simple, easy thing to do. But what's already been done, I'm just plain as sight, is the photogrammetry. You do the same thing. And ideally, I asked ChatGPT, apparently through photogrammetry, you'll be able to detect diverging verticals with it. That's what's claimed. So there are modern methodologies than measuring 60 miles worth of angles to
How are
get.
you gonna detect? How did it say you detect diverging verticals?
So here's the thing. I don't believe so. I think that's a false statement. It lied to me because I use photogrammetry, and what it will detect diverging verticals if you set up 2 poles and one is diverging from it. It's claiming that it can itself detect physical curvature due to the diverging verticals that you would have on a sphere over a distance. See, the idea would be to use photogrammetry to prove there is no curve. That's why I was inquiring to do it before, because it doesn't work. It's irrelevant on how it works. Is irrelevant to any shape of anything. That's why it captures the shape of everything. It doesn't care what the shape is. So if you do it over a longer distance, you actually have physical data that matches Google Earth, that matches
How long?
reality. Well, like you said, you only need a mile to 2 miles worth of stuff. If there's a physical diverging vertical, you would be able to detect it because photogrammetry is precise. It's 100% accurate, right? So
No, but what intervals are you going to do it in one shot? The mild observation.
Well, that's how photogrammetry works, right? You do it in sections and then it's stitched together. So it's stitched together.
What I'm saying, what's the distance? How?
Well, you'd have to do an accumulated distance of over more than a mile, right? For sure, and that's already been done, right? You can go look
over a mile observation. Well, I just want to be clear, man. Over a mile observation.
Listen. Just for the average person, they're most likely never going to get that much data to do it. But essentially, you could do it with that much data, compile the evidence, have it structured in a 3D setting after you've collected all the stills, because you'd have to collect a lot of stills over the distance of 2-3 miles, right? You'd have to go up and down.
You didn't answer my question, bro.
What? So they basically imagine scanning a section of Earth, a few hundred meters wide and 1,000 meters, just very, very big surface of Earth, and you're taking strips of it, and then you compile it together. It's photogrammetry. That's essentially what you're doing, and it takes exactly what it sees. So if there is a vertical at one location, then the image will show up as a diverging vertical at the end of that start, because that's what would be required over a 3-mile distance. You would start to see that, and it would be exponential after that, right? Well, this is what ChatGPT says you can do, but the conflict is it's already been done. You can go look at cityscapes right now, and they don't match that data. You can go observe high altitude over New York and see all the shoreline for way over 3 miles. And there's none of that, right? So it's already there. The information's already there. It's not stressed out. I don't know why it's so stressing. It's just look at the new technology and see what they're showing you. It's right there.
There's nothing stressing about it. It's that I think I asked you 3 times and I don't think you gave me a distance, bro.
Oh,
hey,
I said 2 to 3 miles. But it's been done before, way larger distance than
What's
that.
that?
Right?
What's it?
What's your username?
God Scalpel. I was actually just starting to send you a DM. I'll just say hi so it comes up.
I'm trying to drop it. Like also what you can do is you can go to mctoon.net, type in the search, go to spherical excess, EXCESS, and then click read more or whatever on the phone. I don't know, on the computer just pops up. And you're going to go down and you're going to find the transcontinental triangulation arc of the parallel. And you can download the PDF. But I'm going to try to send it to you right now. For some reason, it's not sending to the text, but I'll see if I can send a DM.
Hold on. McToon what?
McToon.net.
I can get it myself. I just didn't know even have a clue what document you guys were talking about, right? That's
yeah, yeah. If you go to McToon.net and type in the search bar on his website, Spherical Excess.
Okay.
And it's called the Transcontinental Triangulation Arc of the Parallel.
Nothing found. Did I spell something wrong here?
Spherical E and then space EXCESS.
Oh, I got excesses. Sorry, hold on a second. Spell check. Okay, here we go. So spherical excess.
Yeah, scroll down to the bottom. You'll see like 5 links of PDFs.
Yeah, flat. Let's have a look. No. Radius of Earth measurements?
No, I don't know. Like on the spherical excess portion, if you go down to the bottom, there'll be like a bunch of different blue link
that's
PDFs.
where he wants to have his. Oh wait, no, hold on. No, I see flat. Let's have a look. Is the last thing the $10,000 flat Earth sextant challenge, and then radius of the Earth measurements. I'm on my phone. I don't know if that matters. What does level mean? Spherical access.
Okay, if you're on your phone, then the spherical excess portion, you need to press read more. You see that?
Hold on.
There's a paragraph labeled.
Continue reading. Yeah.
Yeah, so continue reading and then go all the way down, and you're gonna see like a list of links,
Yeah,
blue.
starting.
Yeah,
So it talks about starting on page 68, primary triangle, and that would be the
yeah,
last
yeah.
link.
The one that says transcontinental triangulation. I think it says like page 68. Yeah. Just
No, this one's. Hold on. Transcontinental triangle. Oh, it's the second last one. This one here, transcontinental triangulation and the American arc of the parallel.
Yes.
That one.
Yes. Yeah. There's the next to last one. Yep.
Okay. So that's the one you're talking about.
Yeah, because that's their like
902
go-to,
pages
yeah.
long.
Yeah. It's yeah.
Just short little read. I'll read that in 5
Yeah, it
minutes.
sucks. You see why I'm not asking for help, right? I mean, it's like.
And what you're trying to find is the raw data. That's what you want to know.
I'm specifically trying to find what do they do to the raw data.
Okay.
The raw data is not in here. It's in the field notes, right? Like it says they take about 18 measurements or so. So they go from one location to the next. They do it over the course of weeks, or really this whole thing's done every year. But they just make like 18 different measurements from one location to the next throughout different time periods. And then that's in the field notes, right? They're notebooks in the field. We don't have access to that. That's not in this document anywhere, which is what Jeremy keeps talking about, because how can we possibly know what it really said if we don't see the field notes? But then they allegedly average those out and they put them in there as the observed angle. So I'm trying to figure out what do they do in that process of taking the measurements and then putting it onto this document. And they're claiming they just take raw averages, which is retarded. If they even understood anything, they would know that they're plain triangles at the beginning. But yeah, I'm trying to get to where we can detail the specific process where it actually just says what happens, so we can shut them up. I have thousands of anti-flat earthers right now, right? Like taking their victory laps, talking about how stupid I am, talking about this proves the globe, and blah 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 blah. And I just want to destroy them. I want to shut them up. I want Mattoon to have to get off the internet. I obviously won't, he'll just keep doing it. But
I feel like I've seen this before. There's a friend of mine on here. His name's Buster. I don't know if you ever heard of him or not. He's often over at Bev's. I think that's mostly where he stays. But I think him and I have gone through some of this in the past. But I'm going to talk to him and see, because if it's the document, if this is the document, I think it might be. I think we did notice a bunch of shit in this document that was wrong.
Yeah, let me summarize this. Okay, so what most of the flat earthers do is they find the spherical corrections that are in there. They're like, oh, look, they're just assuming a sphere, taking a model, and then correcting. That's true. But the anti-flat earthers' argument is that before they do that the raw data, now they don't have the actual raw data, again, they just say that. It's a script. But that before they apply the spherical excess formula, before they apply the reference spheroid model, the ellipsoid model, before they apply the assumed sphere, the raw data, the data before they alter it, shows spherical excess. That's their argument. Their argument is that before they even take the spherical assumption and correct it, it showed spherical excess. Right? That's their argument.
But why would you need to correct it if it already shows it?
Well, there's all kinds, because it wasn't exactly perfect and they're trying to refine the ellipsoid to a more accurate model, blah, 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 blah.
Yeah.
Yeah.
That translates to before we lied, we already lied, so it doesn't matter that we lied.
And basically what the conclusion was that a lot of so certain directions matched the Bessel model, certain directions matched the Clark model, a lot of them were in the middle, that they needed a new model, blah, blah, blah. That's
the definition of moving the goalpost, man. They're just picking whichever candy tastes the best to them at the time.
But you have to understand their argument, though, man. I think that it's best that we attack their argument specifically. Like, they're saying that before they apply the spherical assumption, that it showed spherical excess. That's their argument. And if what they're saying is true, it's not a bad argument. What they're saying is not true, and we need to prove it. The reason I know it's not true is because the Earth's not a ball. Okay?
The question would be...
it appears that we only have the, in quotation marks, corrected numbers that have spherical axis. We don't have the ones before that.
Well, that's right. So we are, like Jeremy keeps saying, that we are limited because we can't just see the actual field notes, the actual raw measurements. But we can get to the bottom of what they did with them. Do you see what I'm saying? We can figure out what they actually did with those measurements, because they're claiming they just took a raw average. They just took all the numbers, threw them in there, averaged it out, and then put that number down as the observed angle column. They did not do that. They 100% did not do that. Okay, just for sure. They don't even do that nowadays. So I know they didn't do it, but we still need to like show exactly how they did it, in my opinion, because then when I go into a debate in front of thousands of people and this is brought up, I can immediately and concisely show what they did and just destroy it. Just cut it off, embarrass it right there.
More importantly, why does it take at least 13 measurements, if not more, to get the information? And they're claiming a distance of 1.5 miles. They can get that information.
Well, I don't think that's a good argument. Like, if you're going to go out and make measurements, you would take a lot of them. Also, if they throw certain measurements out, that's not necessarily cooking the books. If I go make like 10 measurements and 9 of them show me around the same, but then the 10th one's way off, it's reasonable for me to assume I made an error there and to go redo that measurement, right? So, yeah, they're just trying to ensure accuracy by doing lots of measurements. But one of the things it does say is that
I understand that. That's what you want. You want to actually get a noticeable difference, and that's why over 13 measurements, 60 nautical miles or 60 miles or whatever, 69 miles, you're going to end up with a 1 degree in total error, if you will. And that's what I assume to be at that level, at least getting that information. While at this level, what we're debating, these people don't do that kind of effort to get. At least I haven't. Do they do more than 13 angles, 14 angles? No, I've seen like maybe 2, 3, 5. I don't know.
They combine 3 angles to make a triangle, right? But
yeah, so there you
they
go.
do like 18 measurements. So, but like this, just to give whoever is wanting to help, here's some advice, right? So, you have to pay attention to exactly what it's talking about. There's obviously the zenith and there's the azimuth. There's the vertical deviation from plumb. They do all kinds of spherical nonsense to that, right? The Globers would never even invoke that. Now, some of them do invoke, like, you guys know that they invoke, like, oh, it's not parallel, the reciprocal zenith angles are blah, blah, blah. Okay? But that's not what this is about. This is specifically about azimuth, horizontal. They claim that refraction doesn't move things left to right. Now, of course, they're also wrong about that. In this document, it says that that there is lateral refraction, and it also explains that it's basically impossible. It's impossible for the observer to look at these distances and not have deviation off of vertical, like deviation laterally. It says it's impossible. That's what it says in the document. But anyway, long story short, just like this is about the azimuth. It's about the horizontal angles, and then they transform those into azimuths. And so this is what we're talking about. So when you see where all the spherical corrections are done to the zenith or to the vertical plumb and stuff, that's stupid, of course, and they're assuming the sphere, but that's not what this is about. But it's not unrelated because they're actually getting deviation from that. But some of these spherical excess is like 18 arc seconds, or there's a lot. So we need to figure out, you're not going into the world and actually doing this without assuming a sphere, okay? Because I live on the Earth and I know that it's not a spinning ball. So you're not just going to go out, make raw measurements with no assumptions, and then find out the Earth's a sphere. That is not how the world works at all, right? So we need to figure out what they're doing precisely. In my opinion,
It's more like they have to look at the angles. So the way I look at it is forming a space in 3D space that is equal in both coordinates. And so the idea is they're taking that one 3D space and then correcting for it as if that's what their model dictates. Okay, so this is what it would be like on a sphere in 3D space, but yet my information says I'm getting the information from a planar surface. So that's what I see it as fundamentally is obviously a language to communicate what you see in 3D space to be on both a planar surface and a sphere.
Yeah, this is true, right? They do run it through the spherical coordinates to get the 3D. Go ahead.
No. Finish your sentence.
To get the 3D coordinate system, right? So they run it through. They use what's called like astronomical coordinates. You have the astronomical meridian, They compare the astronomical coordinates to the geodetic coordinates. So it's all based upon the sky. Okay? So they're looking at the sky to do all of it at the beginning. And I just want to boil it down to like precise refutation.
That kind of answers half my question that I was going to ask. My question was going to be exactly what is their procedure? Because to some degree, yes, I see the value in scrutinizing their paper and getting down to what exactly their,
stereographic projection.
Okay, is that what they're saying?
That's what you would want to do, is take the spherical nature of what you see and transpose it to a 2D plane. So if you look at stereographic projection,
I've heard what you've said. I'm asking specifically because I'm coming in here without some context, right?
They have circular plates. They're making measurements around 360 degrees. They're trying to measure the azimuth reading, and they're claiming that when you add up the internal angle, so you take, obviously, what the funniest part is that to get an angle, you need two straight lines to meet. Okay, so you have two straight lines meeting to get the angle, and if you do that with line of sight and make a triangle, it has to equal 180 degrees. That's what these people don't seem to understand. But anyway, what they're doing is they're actually taking that and they're transforming it into a spherical coordinate, and then they are adding up the internal angles to get over 180 degrees. To get over 180 degrees after they transform it to spherical coordinates to try to match the sphere model and further refine it.
The transformation is not necessary then, which is part of the point. They have no justification. Sorry, that's a better way of saying it. For what they're trying to do, the justification for transforming, at least from what I've heard, seems completely useless.
Well, they just believe that the Earth's a sphere, right? So, like,
yeah, no, obviously that much is true. But in terms of what they're presenting, they need to make that clear from the get-go in their brief or in whatever the pre-note write-up is. Because if they're just affirming what they've already come to have under consensus, that's fine. But they're using it as if they're doing something from first principle. But if they're going to do something from first principle, then the transformation is completely arbitrary and quite obviously deceptive.
Well, see, yeah, but okay, so like I said, they're not technically being deceptive in the sense that they're not trying to hide it. In fact, they're so like openly assuming the sphere that they don't even concisely state how they do it because it's just a thing that they assume. You know what I'm saying? So
yeah,
since
it
they
takes
aren't
more effort to
specific
understand what they've done to themselves than they have done.
And since it's such a bold assumption, they're not hyper specific about it. So the Glovers, the anti-flatters, take that and claim they didn't assume the sphere. You see what I'm saying? They take that gray area and they just make up a story. They make up a story. They all repeat MC Tune, and that's it. That's what they do. And it needs to be exposed because, the reason I think it needs to be exposed is I know people new to the conversation that have run across this as the claimed measurement of Earth curvature, and they don't know how to rebut it. Then they go open this document and they're like, "Whoa," So then they just go listen to MC Tune explain it, and that's the problem. We don't have a flat earther explaining it. Okay, we need flat earthers to explain it, and then they literally have no physical measurement of curvature to even claim.
Dude, the way you rebut it is when they say, "Hey, we got spherical excess measurements." It's like, all right, show me one of the measurements. They can't show you a measurement. I mean, where do you?
Yeah, I do think that's automatically the first step is to be like,
I'm not hating that you're going deeper into it. It's good that you're getting deeper into it. Yeah, let's see what they did with the observed angles.
See, well, like in left lane doesn't get it either, man. Like, it's a valiant effort, but it's a waste of time. There's no way to erase spherical excess. Do the math. Yeah, the reason there's no way to erase the spherical excess is because it was baked into the data. If I give you a ruler and it's straight, and I say you can only mathematically describe this ruler with spherical geometry, there's no way that we'll be able to look at your data and make it straight. It's spherical geometry. Even though the ruler is straight, you're describing it with spherical geometry. So there's no way I can look through your data and prove the ruler straight. Because you used a sphere assumption. Okay, it's not so that the spherical axis is automatically there. Yeah, you assumed a sphere. You changed all the data to be run through the lens of a sphere. You can't describe a straight ruler as being straight with spherical geometry. I can't think of a simpler analogy. The ruler's straight. We all know the ruler's straight, right? Well, you could make a 5,000 page document describing the ruler with spherical geometry, and it's never going to say that the ruler's straight.
Yeah, dude, listen, straight doesn't mean straight anymore. It means everything but straight, okay? Get with it, flatties. Jesus.
Wow, you're homophobic. I'm just kidding.
Oh, dear.
Oh, that actually happened in the conversation with McTunes here, not to change the subject, but...
Dude, I'm sorry, I just got that. I was like, wait, what's he oh, shit.
Wait, so have they specified the manner in which they're doing the transform?
That's what I'm trying to get to the bottom of, bro.
Okay.
So yeah, they explain that they apply the spherical excess formula and stuff like that. There is a portion that talks about how they take a plane triangle and change it. So that's what I'm trying to. I'm almost back to the house, and so I'm gonna go look at it right now. But I also have to finish my newsletter and stuff. But yeah, man, I don't know. I'm trying to get to the bottom of it, and like I'm honestly, I've just put so much on my plate. Like I can't, all the anti-flaggers are so diluted. They're like, do the math. Well, haven't you done the math yet? Have you brought back McToon to math yet? Like they act like I work for them, and like whatever they say to do, I should work around the clock and just do that. You know what I'm saying? And if I don't do it fast enough, then I'm actually scared. I'm running away. I'm lying. I'm a grifter. Blah 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 blah.
Do they know what the math is? You could just send them a bunch of equations and they wouldn't know.
No, that's the funniest part is they all say Witsit can't do the math. He doesn't understand the math. And none of them can do the math, have ever done the math, can even understand the document, never read the document, right? None of them. 95% of them don't know anything about the document, but they all, 100% of them say, Witsit can't do the math. When's he going to do the math? But they can't do it. But they know that they can hide behind McToon, pretending he can do it. And McToon is a math teacher, right? So he can do a lot of the math. Yeah.
Wait a sec, McToon's a math teacher?
That's what he told me last night.
What does he teach? Like preschoolers?
Those poor kids, those poor students.
I just dropped something in the text. What's it? Have a look.
Yeah, I saw that page. Yeah. That's a big part of the page. That's one of the ones I screenshot. It's very interesting. Dude, I want to
now look at the bottom. What's it? Look at the bottom of that page when you get home.
Okay. I just want to tell this story real fast. So McToon, I can't remember. He was like pissing me off, interrupting me and stuff like that. And I was like, I remember I cussed. I said something like, I don't remember what I said, like, holy shit or something. And he's like, I don't even cuss, bro, And I'm like, because he made a video where he chopped me up and it's like a song about I don't even cuss, bro. And it's looped over and over. It's looped over and over because I said that in one of my streams. And I'm like, dude, you're so dishonest, McToon. Like, in that stream, what I'm explaining is I'm being censored on my channel, even though I don't break terms of service. I'm not even talking about certain things. And dude, I don't even cuss in my streams. And I was like, I don't even cuss, bro. I said that like to explain like how insane is it that I'm getting censored with all this degenerate stuff on YouTube allowed. I don't even cuss on my channel. So I was like, I don't even cuss, bro. He took it out as if I'm claiming I never cuss ever, And then he looped it. I'm like, so you see how dishonest and like lame that is? I'm like, dude, like everything you do is gay, bro. Like that's just lame. That's so gay. And he got so offended I used the word gay as a derogatory term. And then just ranted and went on and on and on and on. And it was pretty funny. He like virtue signaled and I'm like, he's like, you're hatred. You have such hatred. I'm like, no, dude. Like, sometimes love is to tell people certain things, like calm down, man. I'm like, do they have a shorter life expectancy? And he just got super mad and was virtue signaling, screaming and stuff like that. So I thought it was pretty funny. You'd have to hear it to know. But anyway, I'll check this page.
Go to page 315. I think I found what we're looking for.
You found the
Has anyone Control F plane triangle yet? Control F plane triangle. That's definitely. I want to see how many times that's.
I need the file first.
Yo, Witsit, have you ever talked to a troubling triune before or whatever?
Yeah, Troubling Tribune. Yeah, I'm supposed to go on his channel sometime.
Bro, he fucking wiped the floor with FTFE yesterday. He fucking bulldozed him, dude. It was fucking ridiculous.
Which part was that?
He said 315.
Page 315. It says it. Yeah. It's funny. This is the first page. When I opened the thing, I just scrolled my finger, and wham! That's the first page I went onto.
Wham bam, thank you, man.
Yep, I think I found it.
He found the Holy Grail.
What does it say though?
Doctor, you've done it.
Go on it yet, but it says. Hold on. It says, see Wright's Treatise on Adjustment of Observations, New York, 1844.
Say again?
See Wright's Treatise on Adjustment of Observations, New York, 1884, page 315 to 320.
So that's the alterations they do that are kind of baked in.
Maybe so. We need to find that document that.
Yeah.
If that's
Yeah, we
applied
got to
to
read
the
everything. Yeah.
Yeah.
Man, because this is the thing, we're dealing with a tertiary source, really. They're providing, they're acting as if they're doing something independent, but it's all third hand, second hand. We have to go back to what they're relying on and get all those.
Yeah, I mean they did some stuff. Yeah, exactly. They did some stuff themselves, but it's built upon all that stuff.
Yeah, we have to basically build a document of documents and have just do their work for them and go, are you sure you even know how this works?
Look, even the drawing that it's in here, right? O is where they begin, right? Look at all the lines. They're all straight lines. Every single one of them.
Well, that's another part that's super funny is this is the Glober's claim, right? They're making a positive claim. This shows curvature of the Earth, and they're all just trying to shift the burden over to us. As we challenge it, they're like, do the math, prove it. What is it? Show that they did that. Like, dude, this is your claim. Like, you show what you're saying is true. Show that they took a raw average with no spherical assumption. That's what you're saying happened.
Yeah, we can't do the math because the numbers aren't there to do the math with. Yeah, tell them, how am I supposed to do the fucking math? Give me the numbers that you don't have.
I think you need to treat them like children, not in a disrespectful way, but in such that when you went through, I think you'll remember this, Witsit, right? When you went through probably calculus or whatever, they taught you about the first principles, right?
Yep.
So before they get you to use all the formulas, calculators, whatever, there's like, here's how you do it, first principle. Here's how all these historical mathematicians got to where you don't have to spend your life filling out this chart, right? Understand that this is how things are done first fundamentally before you move on to doing the rest of it. So I think we need to hold them up to that kind of level of expectation of, hold on, you're claiming something, but do you understand how to get there from first principles? Because if you don't, then you're not going to get the mark in the context of like an exam, right? And you're not going to pass the coursework or whatever. Same thing, like, why are we going to take your paper seriously if you don't even understand how to do this from first principles on the things that you're citing in the first place? So,
and they think
you could probably take that and make that more succinct, but the first principle approach is important, because if they can't demonstrate any deviation of what we know to be straight from a first principle approach, then the rest of it is just a waste of time.
Yeah, I mean, they think that they do know how to do it, right? They think, this is the funniest part too, is they act like they have to teach you, but their script is very low IQ. It's like, oh, they took azimuth angles, and then they averaged them, and then they get spherical excess once they average them, and then they correct them. It's like, yeah, please pretend you're teaching me that for years at a time. I can't remember your script. Please tell me more.
it makes so little sense though, because if you all you're trying to do is establish that there is a deviation on, I don't know, well, how does Democ put it? Basically, you're looking for a pivot. What we assume and what we see as a straight line, there's supposed to be some kind of I can't remember what the word is, but anyway, it's supposed to have a deviation from the norm. You don't need to do all the things that you just described. You don't need to do any of that. All you need to do is provide like, what, 1, 2, 3 different measurements, correlation between the two, between the three of them, and then go, oh, here's the deviation here, here's the deviation there, and here are the 3 repeats that we've done in different locations. Horror. Sorry, I have to take this. Bye.
I got a question. Do we know if they averaged the weighted measurements or the actual measurements?
Yeah, we don't know. I don't know.
That's what we're trying to figure out.
Because if they're an average of the weighted measurements, of course, it's gonna get where they want to go.
Yeah, if they use a weighted equation to take the average, then the whole conversation's over right there. And that's why I've been pressing them on that. And they're spinning it like I have been saying it pretty assertive, right? Because they lie so much, you have to, you know. But like, I don't actually know. I've explained I don't know. I'm just like, can you show me site where they say they just take a raw average? Because I see a whole bunch of stuff about weighted equations. No, that's just for the adjustment. That's just the correction column. Okay, cite where it's just the correction column. Like, why do you cite where it says take a raw average? And what I've found, this is why you guys have probably heard me. Another thing I do now is I tell them to bet me. You know, like when Bob researched Flat Moon or whatever, right? He jumped in yesterday. He's like, McToon didn't say that. I'm like, yes, he did. He's like, no, he didn't say that. I'm like, okay, you want to bet $5,000? That's what he said. $5,000 right now. Let's bet $5,000. Because then all of a sudden they shut up, and it's like that's kind of how you have to treat these people, right? You have to be super assertive.
Talks about refraction as well. Page 315. It doesn't say what it's supposed to say, but listen to this. For strictly simultaneous observations and the change in refraction going from the Pacific Coast Island was especially noticed. It was evident, however, that the local conditions had a powerful effect upon refraction, and it seemed best as usual to trust to the adjustment to correct for the assumption of equal refractions, where in reality they were unequal. So it seems that they're just adding stuff up. Refraction, another thing to look into.
Yeah, well, for years, what they would say is that this is left to right, and there's no refraction. Refraction doesn't move things left to right. They said that for years, and then the last week or so, we looked through this, and it specifically says there is lateral refraction accounted for. So they breeze right past the fact that they lied for 5 years, and it's not much. So
Yeah, listen. Goes on. The same plan has been followed here, except for the 3 lines: Pine Hill to Mount Lola, Pine Hill to Round Top, and Jackson Butte to Round Top. So what is this? Sometimes they do it, sometimes they don't. I mean, assuming refraction
massive, some external show, but yeah, it has to end. It has to end.
Would you
maybe?
It doesn't end. It doesn't end in the way that you like. I don't know what you mean by end as an over. I mean, because independent thought can never be over.
Well, I mean it like this: reference to REM. It's the end of the world as we know it. It's the end of the world as we know it. It's the end of the world as we know it. Here we go. And I feel fine. Go look up the rest of the lyrics.
It's not the end of the world in the sense that, Pete, like it's all chaos. What it would be is it would be a change in order, a change in system.
Exactly.
Right.
Exactly.
Yeah,
it's the end of the illusion, the end of the lie. That's the point. That's why he feels fine. Michael Stipes and REM.
And it's the end of the globe narrative. Hold on.
Yes.
Hold on, please. It's the end of the world as we know it, not the end of the whole quote unquote known. Since like four generations ago, I guess our great grandparents were starting to get fooled by this, and then of course our grandparents and our parents, and then us. We're the last generation to be fooled by the globe.
Yeah, that's it, bud, and that's why he feels fine. That's why he feels fine. Can I just say another thing, just regarding, go look at the lyrics on that now, and decode it for as a flat earther point of view. And remember, everything's fake, greatest story emerging, and it's not a bad ending, right? It's a great ending if you want, a great new beginning. But also, REM, remember this now. Presented to the greater public for consumption, Man on the Moon, the song Man on the Moon, about Andy Kaufman. So fakery is central. How many of you have gone and looked through of course you like the song, and yeah, we all agree, if you believe they put a man on the moon, then nothing is cool. But have you looked at the rest of Newton is mentioned in there, Darwin is mentioned in there, Moses is mentioned in there, Andy Kaufman. It's all about fakery. All of it is about fakery and its details. So the moon landings is sort of the first superficial level of fakery, and then there's many different layers to it. You know what I mean? So I think we shouldn't discredit.
Is Moses a fakery?
Yeah.
Is Moses a fakery then?
Of course he was. Of course he was, Isis.
Fair enough.
That's Isis. Is it? Of course he was. Of course he was. What are you talking? Is that Isis?
No, it's Pazza.
Sorry, Pazza.
That's right, mate. No worries. No, don't. No offense taken, mate. It's a shitty line.
Well. Was I know you don't believe in the literal Bible, or I mean, you don't. I suppose the miraculous level of it. Maybe there's some historicity to it. But do you think Moses was real? Do you think Moses was real, Pazza? Really?
I think it might have been an amalgam of several historic people and events. I mean, I don't know about the parting of the Red Seas is a bit is likely to be parable, isn't it, more than anything else? If you're honest.
Okay, let me just sing the because you sing here in Geos, but just briefly, just sing the verse I'm talking about, right? And see what you make of it if you've never heard the lyrics. Moses went walking with the staff of wood. Yeah. Here's a great one. Newton got beamed by the apple good, right? Yeah. Egypt was troubled by the turtle asp. Yeah. Here we go. Mr. Charles Darwin had the balls to ask. Yeah. So anyway, go on. Andy, did you hear about this one? So he's telling Andy, did you hear about this one? And Andy Kaufman is a faker, so he's pointing out other fakes. Okay, that's the idea.
You went with Flat Earth now, but like you're talking shit about it.
Yeah, it's so good.
Dude, stop bashing Andrew Kaufman, man. Don't make it weird, man.
He's saying, okay, let me read the verse. So, Andy,
I don't want to hear that.
Andy, did you hear about this one? Tell me, are you locked in the punch? Hey, Andy, are you goofing on Elvis? Hey, baby, are you having fun? Another reference to fakery. And here we go. If you believe that they put a man on the moon, if you believe there's nothing up their sleeve, then nothing is cool, Pazza. Do you believe they put a man on the moon, Pazza?
I believe they put a man on the moon. But I'll tell you what, Pete, you should put that and your discourse now into a YouTube video and put it on your channel, mate.
Why?
Just what you did just then. I reckon you get quite a few hits on that, just discussing with the lyrics in that.
Oh,
if I'm honest.
I could do so.
Yeah, I mean, REM's been trying to tell us some shit for a long time, and if you got ears to hear, boy, then you've heard it. And if not, you still think it's a globe, and you still believe people put man on the moon. God.
Yeah, I mean, it's worth putting up for people to evaluate, isn't it? Do you reckon?
I guess if you consider REM the arbiter of truth, maybe. I don't know.
No. I never said that. So don't try to misrepresent just for the audience sake.
But don't
you were saying that REM told us that REM told us, and you still believe it.
REM, along with all kinds of other artists, musicians, politicians, actors, have been trying to wake y'all up from your globe belief slumber.
Yeah, but Left Lane, don't technically you think that like the government is the arbiter of truth in this conversation? Because like
no.
You can say no, I knew you would, but they're the only ones that claim to be able to go to space. It's actually specifically prohibited that you even attempt to do it. To even get the fuel to be able to send a rocket up requires the government to approve it. Costs hundreds of thousands of dollars. They deny 99% of the applications. Yeah, at that point, you can still only go so high. They claim to do things that no one else can do. In order for us to allegedly know what's going on when they go to space and what goes on out there, we have to believe what the government says. There is no other option. It's illegal to even try to go test it yourself. So you do believe, every story you believe of when they go out into space and the information they know about what's out in space, you believe the government's the arbiter of truth.
Yeah, I go with NASA. I don't that the government funds NASA and the government regulates things. And space travel, I mean, launching shit up in the air amongst all the planes should be regulated. People shouldn't be allowed to just build massive rockets and just shoot them willy-nilly up in the air, you know?
What's NASA's website called? What's NASA's website? If I want to go to NASA's website, what do I type in?
Oh, I don't know.
NASA.gov. Yeah, it's a government entity. You actually have to swear an oath to the Constitution to work in certain parts of NASA.
Yeah,
but NASA does not regulate the country at all. Then NASA has nothing to do with regulatory or laws or anything.
Dude, do you think the only parts of the government make laws? Technically speaking, only the Congress is supposed to make laws. Okay, so what does that have to do with anything? That the government has all kinds of different agencies and entities that don't make laws. That doesn't mean that it's not the government. Does the military make laws?
Yeah.
No, is the military part of the government? You know what I'm saying? Like, what I'm trying to say, bro, is that we have to trust the authority figure to make these claims about what goes on in space. You know what I'm saying? And like, I just went and talked to a NASA astronaut, and I can't give it away, but they're lying, okay? They can't even keep their story straight. All right? And you'll see soon enough. So, yeah, I'm just saying, that's my point, is like, the arbiter of truth in this paradigm of a glober is, in fact, NASA, which is the government. We have to believe them.
And 22 countries that make up the European Space Agency
That
and
are
5
all
other
subservient
countries.
to NASA.
Are you sure about that?
Positive.
Okay.
That just shows how easy it is to lie to groups in mass. That's how easy it is to convince people of something. There's all kinds of quote unquote space agencies. Yeah, of course
there are. There are lots of space agencies, yes.
Yeah, and they all work with NASA.
On the moon. REM told you nothing is cool if you believe man landed on the moon, Pazza.
Yeah, man landed on the moon. Satellites are definitely there anyway. Things at that height they suggest are definitely there.
If you go into chat, I took a screenshot from Man on the Moon. And during the video, there's these 2 slides that they show you, and take a look at one of the slides.
Very good, man. Excellent. Excellent. I told you there's so much more to that song and the video than obvious. Very good.
Wait, what am I looking at? I don't see what I'm looking at. What am I looking at?
Oh, Arma is here.
What do you mean?
No,
just go to the live stream text. Pardon me.
Yeah, I see
and,
it. I see it, but like, what am I looking at though?
So little squares, right? The little squares make up the globe Earth. Those little squares of data put together.
Yeah, probably. Yeah, like
multiple pictures.
Napalm, you understand that also. Remember the context of everything within the song. Andy Kaufman did a great impression of Elvis. Elvis never died as well. Andy Kaufman he faked his wrestling match and he faked his death, possibly. He said he was going to fake his death. So my point is that, okay, the moon landing fakery is obvious, but what's beyond that? Pazza, Left Lane, all the rest, Arma are going to say, well, no, moon landing is real. And they're going to miss the rest of it. But the rest of it is for us, I would say.
Oh, shit.
Yeah, Kosho. So if that's the chart, is a description of what observations are used to determine the triangle, what are all these subtractions and additions? Because if you do the math, you end up getting like positive 12, positive 20. So what's up with that? Why are the observation equations adding?
Those numbers aren't the numbers that you're adding.
What?
You're subtracting. Those numbers are referring to the observation number. Like the page you just posted. You just posted a page that says Mahone, and then below that it says objects observed. So Mahone, and then the reference station is Stone, and then all the other angles below that are in reference to from Mahone to Stone being 0. And so if in the document later on when they have the triangle and then the measured angles, they have the triangle is the thing that you posted, like the one like you posted the meme of where it has a triangle and you see if it's below or above 180. That number on the other chart that corresponds to that triangle, so number 1 through 31 or whatever, the triangle of 1 to 31, and then to determine that triangle, it's showing you which observations you have to reference to get those, because there's not always a direct line from two angles. So for instance, in like I said, the last one you posted from Mahone to Stone, it has these other locations, but you might have to look at it might be asking, like the triangle might be an angle where it's not referencing Stone first, so you might have to subtract 2 other locations from each other. That makes sense. That's all it's saying is that it's adding subtracting observations to determine the triangle. I have to maybe draw it out. I don't know.
So you're saying that the observations are that different?
No, it's not that they're different. It's if you look here, there's another page that has the. Somebody else posted it recently, but it's got the different layout. There, say there, SE Montreal just posted it. So if you look like, some of these stations, I can't really read it so well, but it says at the very bottom there's like an organ sink, and the angle to the other positions are going to be in reference to a single station, and then you're going to determine the angles to the other stations. And so, for instance, if you were determining the angle from Organ Sink to, I don't know, Turbidohe or whatever that says, and then Mountain Greener or something, and if both those were in reference to Mount Golahan or something, you would have to subtract. To determine that angle, you would basically have to subtract, what would you have to do? Let's see, you'd have to subtract both of those angles from the Mount Gohan thing to see what the angle between those two were. So that's all it's describing is what equations you have to do to determine the angle in question, the triangle in question.
Okay, I don't even know what you're saying, but I'm trying to deal with my chickens right now. Sorry.
All right, well, I would say if you're
Everyone
curious
is
about that chart,
interested in the conversation. Very good. And
if you're
Kosho's
curious
not
about that
interested at
chart,
all.
I'd say
He just on repeat.
hold on, Pete. If you're curious about that chart, if you just look at that chart and then you look later at these, like the graphic that SE posted, and then you look at the the original one that you posted, or the second one that you posted. Look at all three of those together, and it'll make sense.
He's not. He can't pay attention, Kusho. He's tending his chickens. But fair enough. I think the point itself stands. Can you show SE Montreal Kusho a triangle? What did he say? A spherical triangle or a triangle with more than 180 degrees? In that.
Well, actually, yeah. Okay, look, I'm dropping this picture and I'll listen because I have to like feed them real fast. But like, what is it talking about here when it's talking about you have plane triangles and that you then change the plane triangle into a spherical triangle? What does that mean? It says surface of the corresponding plane triangle. The spherical excess is given where A, B, and C refer to the sides and included angle of a plane triangle. Why do we have plane triangles? And why are we transforming them into spherical triangles?
Yeah, there should only be spherical triangles, right, Coach?
Aren't plane triangles are always 180 degrees, right? I mean,
yeah.
So what's up with this? What's this part talking about?
No straight lines on a globe Earth. There can't be. I guess you got to give him time to read it. Whitson, I didn't know you had chickens.
Coach was
When did you get chickens?
They came with the house.
Oh, nice.
They're not
one,
mine.
bro.
I have to watch them as part of the rent. It's not going too good though. The neighbor's dog keeps trying to kill them.
You'll be grand. You have to settle. Everything will settle in its natural course. But excellent idea. Excellent. Chickens are great.
Oh yeah. Well, when our lease ends up, we're gonna end up just getting our own land and fruit trees and chickens and stuff. So this is like a training procedure.
In potential, anyway, you a wonderful life you're setting up for your new arrival. Wonderful.
Yo, Pete, you'll think this is cool. So Aaliyah's like 2 months old, and for like the last month, she tries to talk back to you. So like when you talk to her, she tries to talk back and forth. And when Kai sings, she'll sing and like try to get her to sing. She'll literally sing, like she'll try to sing. And then when you say like say I love you, she'll say I love you. Or she'll do like the syllables. And you say mama, she'll say So she literally is trying. She never tells her to talk, and she's repeating the syllables. It's pretty crazy.
Oh my goodness, you're crazy. And actually, the way she says "I love you," it's almost like her name itself, isn't it? Isn't it? But hey, Austin, you might appreciate this more than when I tell it to most people. They scoff and mock, I guess. But I think, of just my own experience, because I clarified this with my mother. I remember I was in the house and I was in a setting. I knew I was in a pram. I knew I was sort of in some sort of surround, and I just sort of snapped into being. That's the way I reckon it and the way I related. And I looked at the corner of the room, and I looked across the corner of the room, and I had the distinct thought. It's still with me right now. Where am I? What's going on? Honestly, it's with me right now. You believe me if you like, but I've come now to think, I just brushed that aside, coming back to flat or stationary. Now I think I understand what's going on in the sense that we are born into a foreign land, you're going to make the change there, but we're taught a foreign language and we're fed a foreign food. We're always in awareness, but then we just have to sort of relearn how to communicate, even though we're aware from the very outset. So that's a wonderful sign. That's a one. Maybe make up your own language with your beautiful daughter. That'd be wonderful. That's amazing, man. But
that's really smart.
Yeah, that's what.
Did he cut out or? Did I cut out? Did he cut out?
No, you're good.
Yeah, I'm really trying to figure this out here. It's saying right here, it refers to sides included angle of a plane triangle, whose angles are those of corresponding small spherical triangles after each has diminished by 1/3. And that's Legendre's theorem. And when greater precision is required as for the larger triangles, which stretch across the peaks and ridges of the Allegheny range, we introduce the radius of an oscillating sphere referring to the center of the triangle. I thought that they 100% did not bake the R value in. They just took, but it's saying they have plane triangles, and then they introduce the radius of an oscillating sphere and transform it from a plane triangle to a spherical triangle. Now, obviously, if we make line of sight observations to get a plane triangle, they equal 180 degrees. So if the observed angle column adds up to more than 180 degrees, then they already had to change it from a plane triangle. Now, this starts to make a lot more sense why the smaller ones don't show it, but the bigger ones show a greater spherical excess, because it says right here, for the larger triangles, which stretch across the peaks and ridges of the range, we introduce the radius of an oscillating sphere. And this is the computation of the spherical excess of the triangles. I already know what the answer is always going to be, no matter what. It's going to always be, oh, this is after, this is after, this is after. This is just the corrections, the adjustments, this is after. But no, it's not. It says that you have plane triangles, and you have to transform them into spherical triangles. So if the measurements themselves are adding up to over 180, but you have line of sight, then that means you're having to take the plane triangle and make it a sphere. If I have line of sight between 3 points, it's a 180 degree triangle, right? Like you have an angle, so you have two straight lines meeting and giving you an angle. You're using line of sight, which is horizontal. So then you have 180 degrees, a plane triangle. So you're going to have to transform that into a spherical triangle. And again, I'm not claiming to be an expert about this paper, but I do know that every time I have basic questions while I'm just trying to figure it out, the story keeps changing. Just in the last week, the story about this document has grossly changed.
I wish someone would do a brief outline of that entire process, showing, number one, observation, and then everything that's involved, subcategories under that step by step, and then next, Roman numeral 2, and so that person like myself could follow along with this a little better, so that we understand what's going on. Because it's so scattered out, I have no freaking idea. I'm just listening.
It is a bit technical, Howard. It's a bit technical, and well, Kosher is your man there. But I think you're asked to consider two possibilities here, Howard. Is one, you're on the stationary surface, and one, you're not on the stationary surface, which is contoured. The stationary surface is flat by our experience of water. And of course, you drove many miles across America. Did you experience flatness and stationariness? The state of being stationary as a general experience or otherwise? I think that's the question.
Well, as we always talk about, other than seeing the sun, moon, and stars moving, you're not going to experience the ground moving. And I've drawn across some, vast flat deserts, but I see mountains on the horizon that I know are 5,000 feet taller than I am, but they're actually on the horizon at eye level. And I don't see how that could happen on a flat plane. Things like that. I see it every day.
Hey, why does the horizon rise towards eye level on a globe?
Perspective.
Oh.
Yep.
Because the sphere is so huge and gigantic that you're actually at a mathematical limit, which makes it look like a plane. Is the actual explanation.
I want to know where we see the curvature. Then why can't we see curvature if it's out there? Where's it at?
Wait, if the horizon moves up to our eye level based on perspective, then how are we claiming that that's curvature?
It's definitely not.
Well, I don't think we're claiming it's curvature based off of that, but I don't know.
No, you literally do. You claim the horizon is curvature. You do it every day.
Yeah, well,
But not
we
physical.
wouldn't be here if there were Earth curvature. We
Well, no, I
wouldn't
mean,
even be talking if there were Earth curvature.
no, but the way you formed that question, though, you said, how do we know like it's curvature if it's rising to eye level or something? Like the way you said that was a little worded.
No, what I actually said was, if you claim that it rises towards eye level because of perspective, then how can you then claim it's physical curvature? That's what I said. Not what you said, not what you stuttered through. Hey, let's see if Arma, see if you can answer this for me. Okay. So we have something called ground wave and sky wave propagation. Okay. So radio waves propagate, you have sky wave, ground wave. They claim the sky waves propagate and then bounce off the ionosphere. Okay. Now ground waves cannot do that. So according to a military document I found, they have a certain type of ground wave propagation
Bro,
where
I
they
don't know this.
shoot from it.
I don't know any of this.
Listen.
But I don't know
I
any
know,
of this
but
though. So why are you asking me this for?
because I'm exposing you. So if
Expose
we
me
have a
for what?
3 meter,
How are you exposing me? I don't know this.
well, you always just try to act like you have like this intellectual high ground of the sphere, and we just make nonsensical arguments. But the truth is, you don't even understand the sphere. So
No,
if we have,
I make
can I
arguments to
finish
the
what
stuff
I'm
that I know
saying,
how to make
please?
argument.
Yeah, but
Can I finish
Arma,
what I'm
don't
saying,
interrupt
please?
him. Then you might
All right,
learn
fair enough.
something, man. Don't interrupt him.
All right, but I
Come
can't
on.
answer
Okay.
it though. But he can
So
ask me.
how about you just listen, man? Okay, so we have a 3 meter tall antenna. So it's like just under 10 feet. Okay. And according to this military document, you can shoot the ground wave propagation horizontally using line of sight from that 3 meter tall antenna. And a few percent of the time, it can be picked up from over 800 kilometers away, which is like 497 miles. So doing the math, 10 feet, 497 miles, 3 kilometers, 800 kilometers, then there should be just over 30 miles, like 31 miles of vertical earth curvature obstructing the transmission. So how can the military
I don't
shoot
know.
a radio horizontal transmission 500 miles from 10 feet up?
I don't know. I don't know about this topic. I already told you. Like I literally spoiled.
Does that
the
even
learning
like
for-
do you even like use your brain and think maybe I should try to
give it a-
consider what's
yeah.
going on here? You like, and is there even a possibility in your mind to actually look at information and try to figure out what's going on? Or if it goes against what you believe, do you just ignore it?
It's not that I ignore it. I just never looked into it. I only like argue the stuff that I'm actually good at, like the math and all that. I don't know about this, and nor
We
do I
want you
care.
to argue, though. We want you to cooperate with us. Don't argue with
Hey,
us.
so wait, does this just right now though? I'm asking you right now to use your brain. Okay.
Yeah.
Does that make sense to you? Does that make
I guess,
sense to you?
I guess not, but I would have to look into it for it to make sense. There you go.
So you agree that you agree that now do you agree that would make sense on a flat Earth though, right?
I guess, sure.
If I shoot, what do you mean you guess? If I shoot line of sight horizontal propagation over a plane Earth, then it would make sense that you can receive it 800 kilometers away. On a globe Earth, the physical Earth is going to block the transmission, right?
Okay. I know we just like totally, derailed. Like we were on something else, and then we. Went to
No,
this.
it's not.
Well, because I'm making a point. Because what'll happen is you won't look into it, you'll never address it, you'll pretend it doesn't exist, and you'll only jump in the conversation about something else. And you'll say, "Well, what do you mean? But what
That's
do
not
you
my
mean?"
interest. I do like the geometry and shit. That's what I normally do.
Okay, well, geometry says that the curvature should block the radio transmission.
But like that's I guess kind of vague and kind of broad when I say geometry. I mean like the specific just me running the numbers on like whatever it is. I mean like that.
Okay, here, run the numbers on this. Okay, 3 meters, 800 kilometers.
Okay. Yeah, it would seem it doesn't work, but I've heard some arguments where it balances or some shit. I don't know, but yeah, strictly geometrically speaking, yeah, I guess it wouldn't work. But if there's some kind of like balancing off the ionosphere or whatever the fuck,
these don't bounce off the ionosphere. These are ground waves.
I don't know.
Okay.
Yeah.
He doesn't know what's
Okay.
it.
Cool. Yeah. Sorry. Mourn your globe in silence.
Yeah, but Arma, the point is, why can't you think on your feet? It's not as if, are you here to defend the ball come hell or high water? Are you here as a truther? Arma, let me ask you a question. Are you a ball earther, a flat earther, or a truther? Go ahead.
I'm definitely. I guess I'm a ball earther. Technically, I mean, sure, but
so you're not a truther. The truther doesn't care whether it's
no.
a ball earth or a flat earth.
I do. I mean, I also a truther, but I mean, like, not in the way that a lot of people, like, like I'm not like so much actively potentially. I don't know. It depends. Like maybe philosophically I am, but like in terms of like the
Now,
shape,
can
don't
I
really
just say
consider it
this?
too much.
This is just ever inspiring me. And maybe someone has come up with this before. Maybe not. Maybe not. But you know the train tracks, Arma, right? So you see the train tracks as they're extended into the distance, they seem to converge, right? So you have a point. Now imagine taking the same train tracks and turning them 90 degrees. So one is on the floor, one is what do we say, about 4 feet above it. They would still seem to converge. How far up do you have to separate the rails when they won't converge into the great distance? And what sort of determinations can you make then regarding, I don't know, casting a horizontal?
I'm pretty sure mathematically it doesn't matter how far you separate them, unless you separate them like infinitely or some shit. I'm pretty sure they're always going to converge no matter what. I think.
Okay.
Yeah, they would.
That's interesting.
If we're assuming infinitely long, train tracks, whatever, then yeah, they're always going to converge no matter what. Because
Right, but that means though, remember, is I've turned them 90 degrees, right? So one is above the other. So that means though, when you cast an absolute horizontal for all of your measurement purposes and say that this is the reference point, then it can't be relied upon because these train tracks now, as after they're being, and you just said it doesn't matter what distance, they will always converge. So that will mean that there will be a drop in the horizontality from your perspective. Right?
What was that part about 90 degrees? I'm not quite sure what you mean.
Oh, you take train tracks, they're 4 feet separated on the ground. You just take the whole structure and turn it 90 degrees on its side. So one rail is above the other. Right?
Wait, so is it pointing upwards, or shooting upwards?
Yes.
Well, then those wouldn't converge.
Well, those wouldn't, but why would they not?
I'm confused. Okay, maybe you should draw this out or something. So, are you saying we're
Shouldn't draw it out?
Are we getting like an L shape?
And the
Are we getting
train
an
on
L
the
shape?
train track, and the whole thing being turned 90 degrees, so the train is driving along the ground parallel to the ground. Yeah, just imagine that. What's so difficult here?
I'm not. You're saying okay. You're making it sound like parallel, and then you're saying no. It's 90 degrees like tilted. That doesn't make any sense. It can't be parallel and also 90 degrees. Like where does the 90 degrees come into this? I'm fucking
Take
confused
the train
right now.
tracks, right? Take the train tracks and just lift the whole thing up and turn it not by 90 degrees, facing upwards. So one track now is directly above the other, right? 90 degrees.
Why are we turning it though?
The train's running sideways.
Yes. So why are we turning it? This is my point. You said that. Okay.
It was like
now
a
that you
V then,
understand
kind of
the
like a
real
V.
scenario. We already understand that the tracks will converge as they're laid as normal, right? Now, as we turn them 90 degrees, as we look at the same thing, will they converge in the distance? I thought you said they would, and it doesn't matter what distance was between the tracks. You could just extend the sleepers to whatever length you like, the distance between the tracks, which would still be running parallel. But that's what you said the first time. That doesn't matter what distance.
If they
they
were
will always
parallel,
converge.
but you're saying I'm seriously like I don't even know. Hold on, let me just real fast maybe draw a picture because you're saying parallel, and I know the other guy said like going sideways, whatever. But I feel like I don't know. I feel like I'm not quite getting this. Let me just
I feel like I'm asking myself, why am I even talking to you?
Because you're saying parallel at fucking 90 degrees. What the fuck does that mean?
Take the side. Hey, bud.
Arma, man. Why are you screaming cuss words in my ear, man?
Because I don't know, but he's not making any sense though.
Did I make sense there, left lane or Witsit? Did I make sense?
I don't know. I wasn't listening, but hey, Arma, since you're so good at math, I have a math for you to do. Will you help me out and figure out what this math is saying? Since you like to do math.
Is it related to the wave, the bouncy thing, whatever the fuck?
No.
Okay, what the fuck is it then? Oh, sorry.
It's about a survey. This is about a supposed spherical excess survey that the Globers keep bringing up.
Okay, I don't know about that kind of math. That's a bit complicated for me.
So what math do you know about?
The math that I'm good at. What the fuck? Why are you coming at me?
You said you're good at geometry, but you're not good at trigonometry.
Well, no, I'm good. I'm good at low trigonometry. Like there's some trigonometry. Not all of it. Just the stuff that I'm good at.
Trigonometry.
I jump in whenever I'm like, oh, I can solve that. If I can't solve it, I'm not going to jump in.
Why don't you try to solve it? Why don't you try to solve it then?
I don't know of that
But
math.
to be clear,
I haven't touched it.
This is referring to turning the measured triangles into planar triangles, not vice versa.
Really?
Yeah.
Uh-oh.
So why did it say we introduced the radius of an oscillating sphere then?
Yeah, that's to determine the radius in that equation.
We introduce the radius.
Hmm?
Okay, so if we have a plane triangle and we introduce a radius of an oscillating sphere, it actually means that it's a spherical triangle and we're turning it into a plane triangle by introducing the radius of a sphere.
Well, that's part of the equation, but yeah.
It says, when greater precision is required, as for the larger triangles which stretch across the peaks and ridges of the range, we introduce the radius of an oscillating sphere.
Oh, right. Yeah, exactly. Because so in the first case, you don't use an oscillating sphere. You use a regular one because the differences in the geoid are not going to be apparent. And when they do the greater distances, they can't just use a perfect sphere to do that. They have to use this oscillating one, as they said.
It specifically says that you have a plane triangle. Just like I told you and you never answered this either, when it says that the terminal ends of the stations equal 180 degrees. I said differ 180 degrees. You said, yeah, they differ from 180 degrees. I said, no, it says differ 180 degrees, which means they are 180 degrees.
Yeah,
so if they're 180 degrees and they're plane triangles, how is it that they're not plane triangles that are 180 degrees?
Well, that equation is specific to converting a spherical triangle into a planar triangle.
Where does it say that?
They use Legendre's theorem, and
yeah, that's not about plane triangles. That doesn't turn something into a plane triangle. That does the opposite. So
no,
Lagrange, Cococho, you dickhead, Lagrange, you fucking idiot.
It does. It's not Lagrange, fuckface.
Sorry about that.
But regardless, yeah, dude. But regardless, no, it's not, dude. First of all,
okay,
I'll tell you like this. It doesn't. I'll tell it to you like this. It doesn't make sense to do that because in the equation,
I think
Peter, hold on, Peter. Peter, hold on, Peter.
Pete, please don't interrupt, man.
Okay,
in the
sorry,
equation,
man.
the variable that in this case are solving for, but in the original case you would use is the excess. So that planar triangles don't have excess, so you wouldn't be able to do the equation that way. You know what I mean?
Yeah, they're transforming it from a plane triangle.
If you were doing that, you would need the excess as well.
Okay, so you don't know how things work, I guess. Hey, if I take line of sight and I get a measurement, and then I take another line of sight to meet that same object, and I get an angle, and I do that to 3 points to get a triangle, what do the internal angles add up to?
180 degrees.
Okay. Are they using line of sight for these observations?
They are.
Okay. So we're getting line of sight measurements to get triangles. So what do they equal?
Yeah, they don't do that though. They take the azimuthal angle, as it's been stated. Take the azimuthal angle from a base. So they have one station. They have one, station they're using as a 0, and they take the azimuth to the other stations.
Okay. So are they using line of sight to get their initial direct observation?
Yes, they are.
Okay. How do they transform it to azimuth?
You just take the horizontal component of that angle.
Can you cite where it says that? Because what I see is that it actually uses spherical coordinates and it uses direction. And the way that they determine the direction is based on the spherical coordinates.
Well, the direction is what is referred to there as that angle. But where does it say that specifically? Let me see.
I'll have to find it.
No, I was repeating what you said. You said, where does it say? It says what explicitly? It says.
It says that to transform it into the azimuth, they use directions that come from the reference spheroid, the spherical coordinates. Right. So if you're talking about angles relative to certain directions, it's going to be different on a plane and on a sphere. Right. So, like, say you're using true north from your position at a great distance, right? If you're on a sphere, you're going to have to use spherical coordinates. It's not going to be the same as on a plane. This is why it says they use the Bessel and the Clark method. And when you go to Clark's method, it specifically outlines this.
Yeah, but okay, so for instance, in the hold on, let me find it. Like in the measurements, Give me 1 second.
Busy beaver, kosher.
Also,
go to
something
kosher.
also something else that but Kosho's, that's good. We need someone to work through it with us instead of just repeating the same nonsense. Like something else that they do, it says for the larger triangles that they actually break the base nets up. So they actually take smaller increments, usually built upon other surveys, then they add them together, and then they take that data added together with a spherical correction.
Yeah, that's the whole measurement, like the transcontinental. That's the measurement of the entire parallel. But each of those base nets, those are the actual measurements in those base. Like those base nets, like the picture that Essie posted, like those are actual measurements. Like those are the base nets that they're combining.
It says for like the bigger triangles, they have to break the base up.
Have you ever thought of asking your questions to an expert on this? See what they'd say.
Yeah, I was
Rather
talking to
than
one
Kosho.
yesterday, and every time I asked asked like 4 of my main questions, he said, "I'll have to get back to you on that."
Which expert was this then?
Larry GPS, the one that all the flat earthers say is like the expert, the 30-year geodetic surveyor.
What questions were you asking that were flummoxing him then?
I asked him, I said, you guys, every time I bring up what the document says about the different corrections that they have to make to the observed angles, you guys claim that those are just the correction column and not the observed angles. So
I'm not a guy. I don't know anything
I'm
about
just explaining what my
geodesics.
question was to him. I'm explaining what I asked him. So, and then I said, okay, so you have the spherical excess formula, which is applied to create a corrected column according to the document. So then what about the weighted equation? Because the weighted equation and the spherical excess formula are different things. So are you claiming that they're both applied to get to the correction column? And he said he'd have to get back. Then I asked him, so is there like a window of acceptance? Because in surveying, you have a window of acceptance, and if something falls outside of that, you throw it out. So what's the window of acceptance in this document? He said, I don't know. I'll have to get back to you on that. I don't know. There were like 3 or 4 more.
That may not be apparent in that portion of the document. Have you? You should come over to Gems. There's a couple of guys there who are really into geodetics and actually do it every day. I've never heard them be flummoxed by anything. They run it by them, see what they think.
I deleted Jim Panda's server over a year ago, dude. I don't go into Jim Panda's server. As soon as I go in there, I get bombarded with insults. I get doxxed. I have people talking about my daughter, my wife.
All right. So if I was to get you into a conversation, not in the main bit, but talking to these guys, would that be any use to you at all?
Maybe.
Oh yeah.
I could sort something out. I mean, it wouldn't be. No, I mean, I could get
Bring
Jim
him in
to
here if you want him. If you want him,
Doofus is a member of this
if
forum.
you want, bring him in here. If you want, bring him in here, and we'll go over it with him. I've been over this with Larry Witz. It went over. There's nobody bigger than Larry you're going to get for this. So I don't know who you think Witz is going to talk to.
I doubt that. I doubt that.
He's a 30-year geodetic surveyor. That's what they say.
Yeah. That's an academic paper though, so it might have. But there might be something that needs to be interpreted slightly differently as a context of how it's written. But yeah, I agree. Yeah.
This is just the truth is that the Globers have been lying about this document for 7 years, and now we're calling them out on it. And now they're shifting their feed, they're changing their story. McTune told me that the corrected column is just the average. Now it's not the average. It's just what they made up a script about how they interpreted it. They listened to MC Toon and Larry. They all repeat it. Now that we're asking specifics and we're looking through the document ourselves, they're all changing their subject, their answers, and avoiding the questions.
So you're talking to at tops 20 people about this, yeah? In all honesty, aren't you?
Yeah.
Yeah. And you understand this is a worldwide massive scientific pursuit that doesn't seem to be in any turmoil.
I don't even know what that's supposed to mean. I don't even.
No, I know. But no, I'm just saying. Maybe that we just got the wrong people in the conversation.
Well, these are the people. If you look up spherical excess in Google, you get McToon's website. See, this is just an anti-flat earther narrative where they claim it has nothing to do with spherical assumption. Everyone in the normal world knows that you have to determine what geometry you're going to use at the outset. That's what everyone in the normal world knows. And that you assume the sphere, you assume the Earth's a sphere, so you go and try and refine the measurements on the Earth to fit within your sphere, to refine your sphere model. You have to assume spherical geometry. That's what normal people know. But the anti-flat earthers, no. There's no spherical assumption. There's no R value. This is all just what the Earth showed us. That's why when you Google it, you get Mattoon. You get Mattoon and anti-flat earther as your first Google result.
Yeah. I worked in aerial photography ground surveying for like 5-6 years, making analytical plotters using computers, and I have to say the resolution in which I was surveying on the ground, we didn't have any component of R in the equations. Didn't need to. But I would on a higher resolution scale, that's when, if it was there, that's where it would be. We definitely propagate in over like a sub 5 or sub 3. Like we used to do 5-6 mile domain regions where we used to do surveying for aerial photography using stereoscopic superposition from aerial photography, and the equations that I put into the computer that allowed a pair of someone to look through optics to look at the two photos simultaneously and get contour information down to about 10 centimeters accuracy on the ground. None of that had any radial coefficient in it because it didn't really need it. Didn't really need it on the resolution. But I do know that there are those of higher photography where I think it does come into play, but I've never checked that. I've never worked with that technology.
Right here is saying, for a fair estimate of the precision of the adjusted triangulation, we have in the first place the mean error of an observed angle of unit weight as derived from 75 corrections to directions contained in the series and involving 33 conditions to get the probable error of the side Still Pond to Hope. We start from the line Finley to Linstead and reach the Still Pond to Hope via Clough by 3 triangles. For this part, we have blah, 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 probable error of side 0.3 meters. Similarly for blah, blah, blah. So to the above probable errors, we have yet to add the part depending on the probable error of the initial side. So it's like the triangulation, which extends from blah, 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 blah. It's every single one of them is saying that they have to make multiple corrections before they even run the math for spherical excess. Every single part of the paper. They're claiming they don't do that.
That's your interpretation of what's written there. I don't necessarily agree with that. I'd have to have a look at it. I can't see it at the moment on the phone. But if you make observations, as far as I'm aware, if you make observations from vast distances, you do get the angles don't start diverging from 180 degrees sum. That's what I've been told.
Yeah, which to answer your question from before, it says explicitly in the title of the data what the observations are, that they're horizontal directions.
Yeah. Abstract of resulting horizontal directions. Okay. What page is that?
This is the title for. This is the very first set of data, but this is the title in every set of measurements.
Yeah, okay. But I read it yesterday where it specifically explains that to get your adjusted directions, right, for your observations, you use a spherical coordinate system.
Yeah, they use the spherical coordinate system. You mean longitude and latitude?
Yeah, so is your angle going to be different for direction in a spherical coordinate system and a plane coordinate system?
Well, what plane coordinate system would you use? We only have a spherical coordinate system.
Okay, so then how is it not baking in a sphere? That's what I'm trying to figure out here. How, if we have to use the direction, how is it, if we're using direction for the azimuth before we write down anything, right? How is that not assuming a sphere?
All they're doing is they're comparing, like for this first one, they're just comparing that from that Linstead station. They're comparing all these other stations to Finlay. That's all they're doing. So that Finlay
I'm about to walk into
is the 0, and all these other angles are in reference to Finlay as a 0.
I'm about to go to my computer. We're going to get to the bottom of this. Because one thing that is frequently left out is what it says in this document is that a huge portion of the measurements are actually taken from other surveys. which means they're taking the final product from other surveys, adding them together as their base foundation to build the rest of their calculations on, right? And that for the larger triangles, they actually have to break them up. And they use these other surveys. Most of the data comes from other surveys. And the other surveys obviously did the spherical correction, the spherical excess formula correction. So
What spherical excess correction? What's that?
What? Yeah, just that's what it even says in this formula. You have a spherical excess formula, you apply it, and then you get a correction. That's how they get their correction.
No, there's not a spherical excess formula where you get a correction. The only thing you posted before was a formula where you can determine a planar triangle to its spherical triangle. But that's just a conversion. But there's no correction that is specific for spherical triangles, just to change it to a spherical triangle.
No, okay. First of all, what I'm saying is they use a spherical excess formula. Okay, how about this? What are they doing to go from the observed column to the correction column? What specifically are they doing to make the correction?
Well, there's a whole area of corrections right before that where they take all those corrections into consideration. Like there's hold on. Like there's the one that says, I gotta pull it up now. Hold on.
Yeah, it uses the spherical reference spheroid.
So one of the corrections is the figure adjustment, and then they have the
Yeah, give me a second. I'm carrying stuff inside. It's just so funny, the stuff they said. They don't seem to understand that corrections are added to increase precision. Actually, they use the reference spheroid model, dude. So you can say whatever you want to say about it. That's what they do. I don't understand. What's the purpose of lying about it?
There's no purpose in lying about it, which there's a purpose
Well,
in
I can think
explaining
of a
it.
purpose.
So every time you say that someone's lying to you, after I speak
Chucky's
to you, I'm
lying.
going to assume you're
Chucky's
talking about
lying.
me,
Chucky.
and I'm going to
No,
go ahead and respond to you and just tell
I'm
you.
literally
understand
not. I'm literally not talking about you, though. So
I'm the last person to talk. That's what I'm saying, dude.
I just now read off what Chucky said in the chat and then responded to it.
Joshua, it does say that the spherical excess is calculated with a formula. The formula has R in it. And then it says at the bottom that the computed spherical excess is to be unequally distributed over the angles. So how is that not adding sphericity to what they're measuring?
Which page are you seeing that in? Because if you're talking about
51.
the say what?
51.
Okay. If you're talking about the just hold on, I'll get there.
The heading of the section is titled "The Computation of the Spherical Excess of the Triangles."
Kojo was trying to say that they're turning it into a plane triangle.
That page that you had posted?
Yeah, that's right. Yeah, that's the same heading.
Oh, I already have that page up then. Hold on. Okay, then yeah.
if they're introducing radius of spheres, why? Like, how could that? They wouldn't have to introduce a radius if they were converting a spherical triangle to a plane one.
So to get their azimuth, they're looking at stars as well, right?
The astronomical observations, yeah.
And then we're having to use the spherical coordinate system, the astronomical spherical coordinate system.
It's at the end, though. That's when they compare those two.
This is results for azimuth from observations.
Section 7?
I don't know. This is all the way in 750. I don't know what section it is. I just sat down. This is what I had pulled up. I don't know. Like, Doofus, speak up in the chat, okay? We know it says observed angles, dude. Okay? But that isn't all the raw data. That's not the raw data. That isn't like, oh, here's the list of everything they saw, and each time they did it, now we can go fact check the math. This is the product that they put down as the single observed angle.
It tells you where they
That's
are.
after field computations.
It tells you where they are, and it tells you what directions they saw the other thing.
Yeah, but they said they took like 18
The final-
measurements.
Yeah, this is a final average of the internal angles between those azimuths.
Oh, so when you say we can just go fact check the math, we can't actually fact check the actual physical measurements. We can only go look at their average for starters, right?
That's why they tell you where they are. The reason why they tell you where they are is so you can know that the corrections that they're doing ahead of time are based on that location.
Completely didn't answer my question.
It is. It's a fucking answer, Witsit. If they tell you where they
You guys
are,
are always so
and
like
if
miserable.
they tell you, Witsit, if they tell you where they are, and they tell you what direction they're looking, they're telling you enough information for you to go back to pages the pages relevant to the station correction. They're telling you enough information to figure out what those formulas have for variables.
Tell you what the original measurements were.
They tell you the
My
average
God.
of the measurements that they
If
made.
we get an average and my final answer is 5, I can give you many different ways that I could get 5.
Right.
You'd probably be fired as a surveyor.
As he
Then.
normally says, they're not giving measurements like 3, 7, and 5.
Oh my God, I just made a simple point.
It's not like there's a range that is that variable, because the instruments that they use and the methods that they employ give you less than definitely less than 2 arc seconds in variability. There's no way to get more than 2 arc seconds of variability there.
Look, Chucky's saying when we did chain surveying, the measurement before we corrected for temperature wasn't the measurement. The measurement includes the correction. That's our point. That's our point.
You got anything without the correction?
That's literally our point, dude.
Yeah, well, in this data, the average measurement is recorded, and then the corrections made after are also in the document. But the one on the page that has the stations, that has like the one station and then the 0 degrees at the top and then the rest of the degrees at the other stations. It says that's the that's taken up from 6 measurements that are averaged.
Yeah, it says that they have a direct observation, and then they do things to the direct observation before putting it in the observed angle column. So they specifically say this is called a direct observation, right? There's a distinction between direct observation and then the observed angle column.
The one that I'm talking about doesn't have observed angle column. It just has that's the measured angle. There's a section later on that has the observed angle and the corrected and all that kind of stuff. But the one I'm talking about is the one where it just shows the station. It shows the other, so it'll say like web, and then the first one will say Linstead, 0 degrees, and then like 5 or 6 other stations with degrees in reference to that first station.
What you keep saying is that when they look at the sky, that's just for the later corrections. But that's not what it says. It says that's how they get the actual azimuth to begin with. That's what it says. It says 75 centimeter direction. The Theodolite number 1 was mounted over the triangulation station. The azimuth mark was on a hill back of Knoxville, about 3.5 miles distant. Observer, whatever, computer, James, whatever. A single result for azimuth is derived from a set of observations consisting of a pointing on the mark, pointings on the star, and its image reflected from Mercury, reversal of instrument, pointings on the star, and its reflected image pointing on the mark.
Are you in section 7 of the
No,
document?
no, this is page 752.
752?
Yeah, but all of them are saying that, right?
Yeah,
Like
section
71
7.
says this. They all explain that they're using the sky. Results for azimuth from observations of Polaris at various hour angles. This is literally describing how they get the azimuth. A single result, that's what we get, right? We get the single result, right? That's why there's only one single result in the observed angle column, right? A single result for azimuth is derived from a set of observations consisting of a pointing on the mark. Okay, now you guys are claiming that's all it is. That it's just a pointing on the mark and that they're taking the average. This says a single result for azimuth is derived from a set of observations consisting of a pointing on the mark,
Yes.
pointings on the star, and its image reflected from Mercury,
That's
reversal
fantastic.
of instrument.
You
What's
said
up?
this part already, dude. Okay, you're reading from the section that says the results of the astronomical determinations of azimuth. The part
Right.
that we're talking about is the part that says the triangulation. So the section 3 is the section that we're talking about where the measurements come in. This is something different. It's the results of the astronomical determinations of azimuth.
Right. Obviously, we can use references in the sky to figure out which direction we're facing, right?
There you go. So to actually get the azimuth, we have to determine direction, correct?
That azimuth is a direction. Yes, we have to use a direction to find a direction.
Okay, so we get an observation and then we turn it into an azimuth, right?
No, we turn it into a reference for our azimuth that we need to measure from then forward. It's a
Okay,
reference.
so is the observed angle an azimuth?
The observed angle, well, the observed angles that are going into that observed angles column, those are internal angles. That's 2 azimuths. That's difference between the two.
Okay, so obviously we have to get to azimuth and then we have to get the difference of the azimuths.
Okay.
So what are we doing to get the azimuth? What are we using to determine direction?
You can use, okay. You're aware that Polaris is a good way to sort of guess where true north is, right?
Okay. And then to coordinate that to where you are on the ground, you have to have a coordinate system, right?
No.
Yes.
Wherever you are on Earth, if you can see Polaris, that direction is pretty much true north. Doesn't matter where you are.
Dude, yeah, but you're comparing it to something on the ground.
No, you're looking at fucking Polaris. What the fuck?
Oh my God.
If you're looking at Polaris, that's a direction.
What are you doing with that?
Right? From that, any other direction that I look, I can derive an angle between that and Polaris, and that gives me my azimuth, roughly. They say
Okay. Is the angle going to be different on a
multiple-
plane and on
They
a
say
curve?
that they look at Polaris over multiple hour angles in order to get a good average for where true north actually is.
Okay, so I'm looking at Polaris. I'm getting true north. Now I'm comparing the angle between that and a position on the Earth. Correct?
Yeah, now you're looking at something else. Yes.
On our reference of true north,
Okay.
Is that position on the Earth relative to the reference of true north, is it going to be different on a plane and on a sphere?
I mean, we'll have to go over the whole concept of true north on a plane anyway, but
yeah, oh my God.
There's the question doesn't really even make any sense.
Yeah,
You
it does.
have a direction you're looking, and you have another direction, true north, and you're just getting an angle between those two. That's it. The
Okay.
shape of the ground really doesn't matter at that point.
Okay. So we don't need to use the spherical coordinate system or the reference spheroid.
No. You have true north, which is a direction. You have an object you're looking at, another direction. You're measuring an angle between the two. The shape of the ground has nothing to do with that.
Okay, but why does it say that we use the Clark's method using the reference spheroid at the beginning?
Or what specifically?
At the offset to get the azimuth.
The offset of what?
The measurement to get the azimuth.
What are they referencing that for? Are they doing a correction?
That's what I'm trying to figure out. I'm not claiming to be an expert on this. I'm claiming to know that you guys have been caught lying about it. So now we have to get to the bottom of it.
Yeah, somebody's caught lying, sure.
Well, MC Toon was caught lying specifically. That doesn't mean that you're lying. That doesn't mean every baller's lying. But yes, the main spokesperson for this survey was blatantly misrepresenting it. And once he was called out, he doubled down. Now, most other ballers are saying he's wrong. Okay, so fair enough. But the point is, the fact that it's been misrepresented by like the lead spokesperson on the internet of the survey for this conversation requires further investigation.
That's all a fun story. What I'm asking is, what are they doing with those methods, those geoids? What are they doing with that?
That's what I'm trying to figure out, doofus. I just said that.
Okay. So
I don't claim to be an expert of the 900-page document. That's not what I said. I'm trying to figure it out. All I know is the script that everyone's repeating isn't true. So first, what all the anti-flat earthers were telling me is what MC Toon was saying. Now, when I say all, there are exceptions. And they were saying that correction column is just taking the observed angles and averaging it out, and the average gives you the correction. That's what MC Toon said.
No, he did not.
He literally did. I said, what is the correction column? What happens to the correction column? Then he went on this big, long explanation of intersection points, taking a point, picking a point. He said, and I quote, they either just pick up, it's on his channel recorded, they either just pick out a point or they average them. Typically, they average them. He just makes up what they do, right? It's not in the, so I said, so wait, you're saying that the correction is the average? He's like, yes. Okay. Now, he came into Blue Marble Science's server yesterday, which is also streamed and recorded. And this was after I talked to Larry GPS. And I asked him point blank, I'm like, so can you just admit that you misspoke? That the correction is not just averaging the observations. And he refused. He doubled down on it. They're both recorded. I'm like, dude, even Larry was saying that you're just wrong about it. I'm like, it doesn't even make sense because we're only given one observed angle. How can we then average one angle to get a correction? That doesn't even make sense. He just doubled down, then called me names, then interrupted me and told me to shut up, bitch, shut up, bitch, shut up, bitch. Okay, it's all recorded. My point is that is the reason that I'm now looking further into it, is that a lot of people are repeating the script they've heard MC Toon say, because they saw that he made an Excel and get a final radius value, and that he says he looked all through it and it's on his website. Okay, so everyone just repeats what he said. They're like, oh, we can trust him. He's a math teacher. He did it. And he's wrong. Like, fundamentally. But doofus, you would agree, like, okay, so right now you think what they do is they take a bunch of measurements and then they get a raw average. And then they put that raw average in the observed angle column, right?
There's a station correction.
Okay, and what is that?
Well, that was pointed out to you earlier. Let's go back to it.
Yeah, because there are multiple variables in the station correction. And someone said, go read 10 pages. So do you know, I'm just, what's the station correction? What does that mean? What I remember reading, but it was like 4 a.m, was that they use astronomical coordinate system to determine their geographic location for the base station adjustment. So I'm just honestly trying to figure out what's going on. I'm trying to figure out, are they referencing a sphere, like when they actually take their original data? That seems to be a fair, honest inquiry. So I know obviously they make all kinds of vertical corrections, all kinds of zenith corrections, and that all assumes a sphere, and they're very open about that.
They have to be assuming a sphere because they're not measuring all the distances, bro. And if they did it flat, then they'd have flat distance. I mean, they'd be pretty similar. It's not that much of a difference, but still, they're trying to get it spot on for the ellipsoid. And yeah, they have to add in R, or they're going to get different distances. They're not measuring all them sides. They're measuring like one side to and then they ain't measuring any sides on most of them. And they hit certain places where they'll measure one side like meticulously. And then they had, so if they don't add the radius in their fucking measurements, then their shit's going to be all fucked up. So they have to do it. They have to use spherical trigonometry.
Let me jump out ahead of this, okay? So there's now a conversation with me, Brian, and Doofus. Everyone stay calm, okay? We're just going to stay calm. And I'm trying to have a hyper-specific conversation about the document. Stay calm and respectful, please. Okay. So I'm trying to figure out what the station adjustment is.
Would Doofus, would you agree with that? If they didn't assume the sphere, then they wouldn't be able to, they'd get all fucked up distances.
You said stay calm, man. And the first thing you did was call Witch a doofus.
The abstract of resulting directions from theodolite measures and the adjustment of the triangles composing the base nets, together with the computation of the probable errors of resulting sides, demand further exposition of the methods employed. So, that's a packed sentence, right? So, the abstract of resulting directions from theodolite measures and the adjustment of the triangles composing the base nets, together with the computation of the probable errors of resulting sides, demand further exposition of the methods employed.
It's because they're referring to the triangles were all individually, like the errors are all applied to the base nets individually. So when they combine them all together, the corrections are already baked in at that point.
What? Okay. So like the adjustment of the triangles composing the base net, and then it's saying together with the computation of the probable errors of resulting sides. So what does that mean?
That's what I was saying. Like that means they're already including the computations when they're combining them together, combining the base nets together.
Okay. The great majority of the angular measures were made in series with different positions of the circle. These are called direction observations. At 3 only of the base nets do we find some angular measures by means of repeating theodolites. That they're breaking up the measurement with repeaters. Correct? So I don't say, like, if this whole narrative is they're just looking out to the other observation position and they're like, oh, look, it's this much over 180. No, they're breaking it up. They're breaking up with the repeating theodolites.
what I was trying to tell you before about that chart you posted that describes how the triangles, where the measurements from the triangles come from.
Okay, it says we find some angular measures by means of repeating the autolites. In the latter case, the weights introduced will depend on the number of repetitions. Okay. The least square adjustment to satisfy the conditions among the measured angles generally proceeds by the method employing correlate equations. Does anyone know what any of this means?
I mean, the least squares, anytime you see that, to me, that means wiggle room. That means averages, throwing out the outliers and pretty much averaging shit.
Specifically, though, that's not necessarily bad. Like, if you're making measurements, you don't just, if you make 10 measurements and 9 of them are close and the 10th one is way off, it's logical that you don't factor that in. You redo it. Right. That's logically what you would do. So we need to determine how are they distributing the weights. Distributing the weights and exactly what is the least square adjustment in this situation. What's like the standard?
To me, least square adjustment means pencil whip out in the field. But here's the thing. So think about what they mean by taking multiple measurements. So what do? They set up a theodolite and they look through it and then they get a reading that's off. And then what do? Blink and then look back through it. And they're like, oh, yeah, that's more like it. I mean, what the fuck are they even talking about as far as taking so many? Are they waiting a couple hours, just leaving the instrument just sitting there? Are they waiting 10 minutes? I mean, the whole thing seems shoddy.
Don't they have like a thing later on when they're talking about the refraction and they talk about making these measurements, once an hour, different times and stuff like that.
I mean, for years, I was told that there's no refraction whatsoever in these.
Yeah. This is a left to right measurement, no refraction left to right, remember?
Yeah. But then we look into it.
Still considered
But if you look at the paper, it says like a point, and some of the spots, it's like almost arc second of a refraction. Like,
that's why they considered it.
So how do they determine? How do they know that it refracted an arc second?
They observed it every hour for like, I don't know, a couple of days or whatever. It's in the data, the differences and stuff.
How do they know which position was the accurate one?
everything they told us, Jeremy, was false.
The actual position. I've been going over all this shit for years.
Yeah, Zanuck has a way, a method. He describes a method where you can do that. It's pretty easy, actually. What he
but it's not the method they use. He's talking about doing 3 different elevations.
Regardless, you could just look at any given reading and then compare every other reading to the first one.
What he's talking about doing is doing 3 different elevations and then combining one side off each one. So if they all equal 180 because they're line of sight, what's going to be the damn difference adding one line at each elevation? It's going to be 180 no matter what. Line of sight's 180. Our vision doesn't bend in that, and not that way anyway.
Adjusted angles are referred to an initial direction, and the results given in the abstracts are in the order in which azimuths are counted, just clockwise. So I just want to figure out I want to know exactly what they're doing to adjust the angles.
That adjusted angles, that's just talking about, because like there'll be a list of locations from each location, and the first one's going to say 0, and the other ones are adjusted from that 0. So the reference as that first location is a 0, and then whatever angle it says for the next one is referencing that first station. So that's what that adjusted one means.
Oh. It says for some of the base nets, the station abstracts include a column giving rough values of probable errors of the respective directions, which were not in all cases computed and had heretofore been made use of only in one instance, that of the YOLO base net, as will be explained further on. They weren't computed. It says, I don't know.
I don't know what he's talking about when McToon says like that they're basing it off 360. That'd be the case either way. If you're basing it off 360, I'm wondering like how are they basing it off 360, zeroing it at 360? Like how are they over 180? If
Dude, they told me for years. They told me for years there's no refraction involved with this. It's a left to right measurement. There's no refraction left to right. It's unbelievable.
Yeah, but like if the maximum amount of refraction accounted for is an arc second, and they're claiming to have way more than that, does anyone know what the maximum arc seconds of spherical excess in this document? Anyone have an idea?
The average is like in the fifth decimal place, like a little like 0.6, 0.00000 or no 0.00006. I think that matches up with the radius at that.
No,
at that
I've seen
39th latitude.
I've seen one that was over 11 arc seconds.
Okay. So what we need to do, in my opinion, is to pick out like what the Globers think the best one is. Right. Because what we found out is for one, McToon ran around the internet talking about every single one of them is measured 180, every single one of them. And that's not true. And so now what we found out, like, oh, you have to make a spherical assumption to do the corrections. They're like, he's like, when Shane asked him about that, he literally just scrolled down and said, okay, let's just look at these. Didn't even defend it, didn't do anything. He just said, okay, let's come down here and look at these. So now,
Then he
of course,
also said, here's his fallback. A couple of them. They say if it doesn't add up to exactly 180, then it can't be a plane. And then they say that yeah, every triangle added to more than 180, and so they make it sound like it could vary all over the place. So if it's a globe, it could be less than 180 and then more than 180. But if it ain't exactly 180, then it can't be flat. Like how dishonest are they, dude?
but then they go on to say that the margin of error is their cop out. So they're admitting that there's a fluctuation window of error.
I'll just go to part of the document where there's not an issue on the West Coast. All the original observed angles and all the corrections and all that, none of them are below 180. They're all above 180.
Yeah, so you have to be in the mountains. That's what I get. So you have to be in the mountains to be consistent.
Nope, you just have to have a greater distance and a greater area triangle.
You're right, nope, because none of it was consistent, bro. Don't just watch what you say, because you're gonna be on this list of just saying bullshit.
Okay, well, what you said was incorrect a second ago. That doesn't matter if you're in the mountains. It matters if your triangle's bigger and the area is greater, then the error is going to be much lower than the actual measure value.
So would you agree that without the spherical trigonometry or geometry, that then they're going to be getting incorrect distances? So you would agree that they are calculating the distances in all these triangles based on R at that latitude?
No.
Okay, then so they're doing flat. So they're using flat geometry then, right? So they're using planar geometry.
No. They actually measured the base of the triangles. Yeah, I read a document. It's not this one, but it's one that is a part of this one. It's like the Ohio State one, but it's part of the surveyors that was collected for this document, and it says that for each of the triangles, they have to actually measure the base of the triangle
through the mountains.
Well, I said Ohio, so.
Do the math. Okay, yeah. Well, find out if they did that in the mountains, and find out how many sides. In fact, go find out just how many sides they measured. It's going to shock you. It's nothing like you think.
So, Witsit, you don't disagree with the conclusion of the geodetic surveying of the United States, do you? Just the method?
Oh man, I
think
can turn
that-
my. Sorry, go ahead.
Oh, sorry. What's it?
Well, if I disagree with the method, then I would automatically disagree with the conclusion, huh?
Okay, so is the United States bigger than we think it is, or smaller?
Oh my God! See, I'm not doing this. This is so stupid.
Oh, I see.
I'd say it's pretty close, man.
You think
Pretty
they
damn
really
close
did
either way.
geodetic surveying to determine the distances, dude?
Yes.
Okay, well, you don't understand this at all. Then you should just go back.
Really?
Home. Yeah,
So
really.
they don't know the size of the United States because of geodetic survey.
That's correct.
Okay.
Okay.
You think they know the exact distance through all the mountains and shit, bro?
Dude, he thinks they did it with
Yeah.
geodetic surveying. He thinks they got the distance of the United States with geodetic surveying.
Not the distance of the United States. I never said that. That would be stupid. I said the size. The distance of the United States. What the fuck does that even mean?
What, do you not know what words mean?
Yeah, what does the distance of the United States mean?
It's across the United States. What does size mean?
Well, that's all the dimensions.
Dimensions of what?
That's length and width.
Oh, is that length a distance?
Yes, length is.
Oh,
but
wow, that's
length
crazy.
and width to get
that was easy.
area of the United States.
Why do y'all
Not
fight?
length.
Why do y'all fight things so hard because other people say them? You make yourself sound. No. Can you listen? You almost let me finish.
Ask the question and then you interrupted.
I wasn't done. Smart people know I go on mute. Now you know, right? So why do you try so hard to refute what other people are saying just because you know they're on the other side of the argument? It makes you sound and look like a weirdo.
Well, it's just like a tactic to divert.
No, we're talking about something that's precise here, and you're using.
You don't understand it though. You don't even know. You came in here
I'm
the other
sorry.
day.
I'm sorry. I was answering a question, but you finished it for me.
So you came in here the other day after talking really big in the chat. Came in the VC, and it took less than 2 minutes to expose you, and then you left.
No, it took less than 2 minutes for me to get home, and then I left.
Hey, what's the Clark method that they use?
Don't know, but if you noticed in the chat today, I did mention that they do correct for vertical based
What
on
about
the ellipsoid.
We know
What's the
that.
Bessel function?
Sorry, now what was Brian's question?
What's the Bessel function?
I don't know.
Dude, I can't even take screenshots right now.
Dude, I say that the flat and curved, the arc line and the flat line over 69 miles, let's just say 70 miles, like a little less than 10 feet, dude. So if you have a bunch of them combined, I mean, the difference across the country, I mean, I don't think they even have, I don't even think they could measure that accuracy on a plane, in my opinion.
The United States is about 2,500 kilometers wide, is it not? Over 2.
2.5 kilometers. Say that again.
2,500 kilometers.
You sure they just rounded up or down? Did they round up or down for accuracy?
You talking about across the country, Chucky?
Yeah.
And you think it's
3,000,
2,400
4,000?
kilometers?
No.
Wow.
Keep talking.
Good luck with your math.
Oh yeah, right. You're right. It's 2,000 kilometers from me to Florida. So yeah, it's more like 4,000, 45.
Yeah. That's why I said, did they round up or down for accuracy? Sure is a round number.
You know what? I can miss. I can make a mistake, and yes, thank you for correcting it. But you know what? I'm not going to cry about it for a bit like you guys do.
Oh, you're welcome, Chucky. I'm here to correct you. That's my sole purpose.
You didn't disagree with me because I was on the other side. You disagreed because I was incorrect, and thank you for correcting me. I like being right.
You're welcome. But you weren't
So is
right.
it about,
I had to
is it
correct
about
you.
4,500, 5,000? What is it? I've never been across. I've only been out of this time zone once.
Who cares about kilometers?
I don't know. It's around 4,200. What's the point?
What's that?
What's the
Do you
point you're
disagree?
making by bringing it up?
So we know the size of the United States or not? That's the question to you guys. Do we know the
Hey,
accurate
the
size
guy who
of
just
that?
the guy who was just talking, was you in there? Was that you with in there with Austin yesterday on Blue Marbles channel?
Me?
No.
Yeah, it was me.
What's your name? What do you go by again? I'm sorry.
Call me Register Slow. We're Register Slow Bear.
What?
Register Slow.
I can't hear you, but I guess I'll figure it out by seeing when you light up. But you did good,
Register
man.
Slow
You did
Bear.
good, man. You kept everything down to earth, and you didn't get very many chances to intervene, but when you did, it was right to the point and backed up with citation. I enjoyed.
Thanks, man. Appreciate it.
Yeah, make sure you brush your teeth.
Yeah, all right. Nah, man. I mean, if you heard it, he used every little tiny bit of time he had wisely. I think you'd agree if you listen to it.
No, did he put it on YouTube? So, nice diversion, but did you guys answer my question?
What was the question?
Do we know the size of the United States?
So we got a pretty good idea, man. But as far as that exact shit, I don't buy that.
So how
Yeah.
do we know? Was
Yeah,
it because
Chucky,
of the program, or did we guess?
We know really damn close to the size of it. Pretty close
Yeah,
to exactly.
I mean, you drive it all the time, right? And you're not surprised when you.
Yeah, but
always right on the money.
Check your odometer to the mile markers, and about every 100 or about say about every 85 to 90 miles, you're going to be off by about and then it'll reset like at an exit. But pay attention. Now that I've said that, pay attention. I'm telling you, none of them line up. It could be my odometer, but they'd line up for a while, and then it just start deviating, and I got off by like a couple miles heading down I-10 East.
Did I not hear in the past American odometers, and that's North American, including Canadians, were set higher than reality so that we would get stopped less by police? Is that not accurate?
That's possible, but I'm just saying it lined up for many a mile, and it wasn't like a gradual deviation. It just all of a sudden would happen like within about a 20-mile span. It worked perfect for like 40, 50 miles, and then all of a sudden it just like slowly start deviating. Like I'm just asking Left Lane to pay attention to that now that I've mentioned it, to see what he comes up with, because he's always out on the road, and he could give me a better report, because I only did it on I-10 East, and then half of the way back I was looking at it.
Where's I-10? I've only done the big major highways, 60, 75, and 95. And it's all right. I think we would be east.
Kind of breaking up there.
Okay, Whitsett, the section that was
Where's I-10, Brian? Is that Texas?
To be honest with you, I don't think anyone understands it. You're kind of breaking up.
Austin, what was that guy's name, so I could send him a friend request?
Regis.
Registers software.
Thank you.
Yeah, I'm here, Brian. My bad. I don't know why I wasn't coming through earlier. Thanks for your words.
I've already got you down. Thank you, man.
Hey,
Yeah, man.
Whitsett.
Hey.
Yeah, that section that was being pointed out to you earlier, I just read through that. They work through an example there, and at the end, at page 46, they give you the conclusion of that worked example. But through the whole process, you'll notice that there's no mention of the Earth being spherical in any of that. It's just about the measurements themselves. The station correction only has to deal with the signals that you're picking up, the measurements between those azimuths, and the sums between the various values, the differences between each of the runs of the measurement. And you come up with this very small correction at the end. In this particular example, 0.09 arc seconds A very, very tiny correction.
But necessary over the size of the United States.
I don't know what you're talking about. I'm trying to load my stuff up.
Yeah,
that was well put.
All these different measurements have an average them. So, what's going on? If it must be some kind of refraction, then, right?
Well, are the azimuth angles established from celestial objects? Is that how that's determined?
I mean, that's how most people figure
For
out.
everything they're doing, they're basing off the calculations of the distances. I mean, the distance calculations, and then averaging it out. It's a big fucking pencil whip, and the whole thing is it was a challenge, I imagine. But
Well,
I imagine it took forever, dude. And they have to have all these different corrections to fucking make it all work. There's some outlandish fucking numbers in there.
I got it.
Right.
So the azimuth angles are determined based on celestial objects, right?
Yeah, that's how most people figure out where true north is.
So is that a yes without the snide remark? Is that just a yes, that is correct?
Yeah.
I think they did it 2 ways.
Okay, cool. So are the celestial objects based on a celestial sphere? Is that how we view the celestial objects when it comes to determining azimuth angles?
We don't need to use it as a sphere. You're looking in a direction to see which way Polaris is. That's a direction. That's not a sphere.
Do the stars present themselves in a celestial sphere to us when in regards
And
to
regardless of
determining
how they present
a
themselves,
azimuth?
the direction that you're looking
Sorry,
is
I
a
wasn't finished.
direction.
So the stars present themselves to an observer in what we determine or what we call a celestial sphere. Is that correct?
The celestial. Am I muted now? Okay. Is it the celestial sphere? We all agree is something we can observe. What they're doing in order to find the azimuth reference is to look in a direction. That does not imply that they used a sphere to do any of that. They looked in a direction.
Well, hold on though. Back in 1890, if this survey took 30 or 40 years, Polaris must have been off by about a degree and a half back then. It's off almost by a half a degree now, and so it had to have been off by it had to vary like over a third of a degree if it took them like 35, 40 years. Were they accounting for any of this shit? I mean,
Irregardless of that, like this comes back to my same kind of conclusion when it comes to celestial navigation, that the assumption is a celestial sphere based on how we view the celestial objects, right? We view them in perspective. We view them through the eyes of an observer, which does skew the world in a particular way. And then we make determinations off of that, and we can only do that solely based off of a single observation, right? Meaning the stars
Make a
adjust.
single.
All right,
Don't make a single observation. Are you?
Can I read?
No, I'm saying each observation is solely based on where you're taking that, meaning the world presents itself to a single observer. I didn't say that you only take one measurement. There's a difference.
So what? So
Hold
what?
on. Hold on. Listen very carefully. No assumption of a sphere is used in order to find a direction. There's no requirement for anybody to say, this
I didn't
is
say
a
that.
sphere. There's yes. You did say something about a section of a sphere. And a celestial sphere is used. You did mention that several times. But here, in this particular example, in order to have an azimuth reference, no mention or assumption of a sphere is required in order to figure out what that direction is.
Okay, cool. So respecting the nature of the curve connecting two triangulation stations, we may regard it as a line of alignment, in parentheses Clark, which is referencing the Clark spheroid and the method, at every point of which the azimuths of the terminal stations differ 180 degrees. Right?
Yeah, you're off into the section past the station correction.
What page you on?
I don't actually know. It's just a screenshot. I'm trying to find it.
The problem with a lot of
Doofus, were you here when Whitsitt said geodetic surveying doesn't determine the size and shape of the United States?
I was probably reading something at the time.
Actually, you added shape so you don't sound as retarded.
All right. The size of the United States, then. Did you know that geodetic surveying doesn't determine the size of land?
That's right. That's right. It doesn't determine.
You know that, Doofus?
That's right. Geodetic
News
surveying
to me.
didn't determine the size of the United States. That's right.
Uh-oh, Chucky.
Yeah, just because you said so?
Oh, it did just because you say so?
No, it did because that's...
What does it do? What's the purpose of it exactly?
It's to actually map out the specific terrain and then it refine the ellipsoid model.
Does it, when it maps out the terrain, does it put the borders and the edges on where it meets the oceans?
We didn't already know the borders of the United States?
We didn't know exactly how far it was, no.
Oh, we had to use geodetic surveying to know where the borders of the United States was.
Well, the
Holy
accurate measurements.
Dude, we already had plane survey of majority of the United States. What they did was they went out, they took other smaller geodetic surveys, they assumed them to be accurate, they used them as their foundation, and they went and concentrated on the areas that we didn't have mapped out to try to compare what the best they could come up with as close as they could get to the geoid model, or more specifically the reference spheroid model, right, of Bessel and of Clark. And then they tried to refine it specific to the mountain ranges, etc. They did not go do geodetic surveying to map out the size of the United States.
The problem with this PDF is there's a lot of different adjustments for the different areas. So, like in the the station adjustments, there's so many different things and different approximations that were used in different areas. It's crazy. Like for the big triangles, it says horizontal angles, if the stations are extremely elevated, are sensibly different from what they would be at the level of the sea. The ordinary formula for spherical excess must be extended to meet the demands of the Great Triangles from Pikes Peak to the Sierra Nevada. The laws of refraction applicable at lower and equal elevations require modification, with great inequalities exist in the heights of the stations. The calculation of geographical positions enters a new phase when lines of sight 182 miles long are to be dealt with. The adjustment of the triangulation, that refined operation by means which incongruous observations are made to blend harmoniously according to the mathematical theory of probabilities. It's
These
just
are adjustments after station correction, by the way.
What?
These are after station correction. This is not done during station correction.
No, they are. Absolutely.
From reduction
Absolutely.
to sea level, correct?
What's that?
You're reading from the section titled Reduction of Horizontal Directions to Sea Level, correct?
No, I'm in the introduction of the paper, and it's talking about the actual different things that they have to adjust for in the field with the station adjustments.
Not it. Okay, I'll get back to it. Hold on.
Hey, also, this is what this is one thing I also understand. So it's like right in the station adjustment section, it says that the number of observation equations is equal to the number of readings or signal sightings at the station and is designated by N. The subscript in each case indicates the number of the series, while the superscript indicates the signal sighted. The unknowns are X1, X2, X3.
And they could be discarded.
Yeah, so what is that?
Yes. Crazy.
When they get those measurements for all those directions, for all those points they're looking at, there's going to be some extra signal in between those points because there's variation there. When they make all those coefficients for the correction afterwards, all of those need to sum up to 0.
I asked you what the unknowns are.
Yeah, and this is before that. This is field computations.
This is literally this is in the station adjustment section. You keep ranting on about. This is like right under the.
I just told you exactly what was in the section that you're reading from, Witsit. All those coefficients for the corrections, they need to sum up to 0. It's in the section you're reading.
So does that mean
that doesn't make a difference, bro? That
Oh, it
doesn't
definitely
change
makes a fucking
anything.
difference. Don't tell me it doesn't make a difference.
It doesn't, bro. You're talking about a circle. You just said directions don't fucking matter. Now you're acting like they need to
Oh,
sum
can
up
we not?
to
Can we
0
not
is gonna
start
make a
doing
difference.
that? Can we not start doing that, please, dude? Like I just
we
can't deal with the screaming and the cussing.
Yeah,
If you start
sorry about
cussing,
that.
he'll start cussing, and it's like.
Yeah. Good
So
call.
is it does that mean there's like an overlap?
if once the unknowns are found, then they have to equal 0 because there may be an overlap. Is that what it's saying?
It says, of these unknowns, it's important to note that the X's are not required. They are unknowns introduced by the method of observation.
Okay. The end result is that for a particular net, that one station, all of the azimuths around it, that all the internal angles of all of those in between have to sum up to 360 degrees by the time that net is done.
Same thing on a plane, bro.
When
But
you
we can all
say by
agree.
the
We
time,
can at least all agree now that that this fucking is not a proof of a globe. We can at least all agree to that, right?
You don't even know what's going on yet,
Rufus,
Brian.
everything in the section that you're reading from, it states later on that all this stuff is field computations that were done before any corrections were done. So what you're saying right now, you're saying that after the fact they did this to make sure it all equals 0, right? Like, are you talking about corrections, or are you talking about the adjustments that were made before they were put into the triangulation?
I'm talking about station corrections specifically.
Yes, those are those are put into the observed angles. That is before, and it is. I have the place where it says it, bro.
Yes, I understand. They're put into the observed angles. The
Yes.
worked example that they did, the end result, the magnitude of that particular example was 0.09 arc second. You missed that part of the conversation.
Right here it says, is the readings upon the initial direction are taken as convenient approximate values of x1 and x2.
X1 and X2 are before 0.1 on the azimuth circle.
The readings upon the initial direction are taken as convenient approximate values of x1, x2, and a and b are approximate values of a, b. Then the observation equation shown may be written, blah, blah, blah.
Right, and as I just mentioned, X1 and X2 are before 0.1 on the azimuth circle.
Okay, so what is this convenient approximate value?
Let's see. Oh, that's after that part. Hold on. Oh, M1 prime and M2 prime are the convenient approximate values of X1 and X2.
Doofus, would you agree that if we use planar trigonometry and didn't insert some type of radius at that latitude or near that latitude, then we would get different distances, however minute, the calculations for all the sides that we don't measure, which is the majority of them, they are calculated. They'd be different. They'd be wrong within your model, right?
We're not even to the part of talking about distances yet. We're still working on angles on this particular topic, Brian.
We do have to, unfortunately, we do need to go through what they're doing at the beginning, because you guys are so sure that they're never using any approximation that would aid in a spherical assumption. You guys are positive.
Yo,
I'm okay.
Did Doofus just say
agreeing with you.
they did something to the observed angles before they measured them? You guys hear me?
Yeah.
Yeah, we can hear you.
Yeah, you broke up at first. Can you repeat that?
Did Doofus admit they do something to the observed angles, some kind of correction or something, and it's not just the average of all the measurements?
It's still an average. The station correction is the same for all of the measurements.
So there is a correction so there is a correction added to those observed angles. You're telling me that's not just a raw average of measured angles.
The correction is, in this particular example that they have, 0.09 arc second.
Yes, and the observed angle. There's a correction added in the observed angle. You're saying?
Yeah, has nothing to do with the sphere.
Okay,
either.
cool. Because I've been hearing for about 2 years now that those are just averages of the actual measurements that they made. But now, come to find out, there's a correction there. Okay, good. We're making progress, guys. Good work. Seriously, no joke. Good work.
Jeremy, whenever surveyors take a measurement or take an observation, they add the correction, and those two together are the measurement.
Why would they have to make multiple measurements from one spot if there's no refraction?
There is refraction. Refraction is one of the things they're adjusted for.
So is that the problem? Is that why they keep measuring it? It's because of refraction.
Well, I think that's how they're going to do it. Like, there's nothing wrong with that, but
Yeah, you too many cheese.
Even
so, Doofus, what you were saying about the adjustments that you were just talking about, you were actually talking about adjustments put into the observed angles before they were entered into the triangulation, right? I thought you were trying to say that they were part of the corrections, like in the correction column. All right, so at least we're on the same page with stuff being done originally, like with field computations of the actual like measured angles, right? We agreed upon that. Hello?
They're not trackers, they're crackers.
I think he's
Brian. Yeah, Brian. Why would you ask about taking multiple observations from one spot? I'm sure you do that when you're shooting grade, right?
Yeah, I do, right? I do. But that's completely different. What I'm talking about is if I have a precision instrument and it's set up and I'm shooting guys holding tape measures, shit like that. If I have a station and a light to zero in on, if I look at it an hour later, is it going to be further to the fucking left or further to the right? Bro, what's the excuse of why they're getting so many different angles?
Oh, it specifically says that just trying to get an accurate reading is very difficult because of deviation left and right, just because of the observer's inability to.
Let me tell you the reality of it. The reality of it is that they're basing the distances in between the stations off calculations. So they have to figure the calculations, and they have to go back. They have to look back and then look forward. They have to get the distances just right to make the math work. It's a big giant fucking model pencil whip.
We're not doing the
calculations are for accuracy.
But we're agreed
They don't measure hardly any of the fucking sides, bro. They're all calculated. They do measure some of them, but not many. They literally cross the country off calculations, bro.
And all those measurements are based on calculations too, but they are accurate. And they're tested when surveyors can do chain surveying, theodolite measurements.
The bottom line is that there's observation equations in each reading and in each angle measured. Like, those observation equations is what we have to kind of figure out all that goes into it.
But they should be able to quickly help us out and answer that because they're so positive that they know what's in it. So why can't they just tell us?
Yeah.
They certainly didn't do this survey to figure out the radius of Earth. They already had a radius and that they're basing it on, and they're trying to refine their model, which is good. Dude, what they did was fucking massive, But the reason it took so long is because it was damn near impossible to get it exact, even going off of prior shit. But you can't do these calculations for distance to even set your stations based on a sphere without spherical considerations, without radius consideration. It's not possible. And they're called like curve considerations or curvature corrections. But when we look at triangles in the real world, They're 180 line of sight.
Yeah, but these aren't regular triangles they're doing. First of all, it's a spherical triangle. Totally different from a regular triangle. Not totally, but very different. And those after they're measured or before they're measured? In the observed angle list. I'm only worried about the observed angle list.
Like that.
Jeremy, I think your internet is making you time travel. Some of your comments are coming in after the parts that you said before.
Yeah, I was gonna say like, like who even answered him? Oh, that's funny.
Hey, Doofus, what's the section talking about the plane triangle? When it's talking about plane triangles, what is it talking about?
What is the section of plane triangle? I don't know.
I dropped the pictures. I don't know. Fix them to it. The Kosho says that they're turning it into a plane triangle.
Turning it into a...
That's what he said.
I don't even know what you're talking about. Can you give me a page number or something?
Yeah, just trying to fix food. It's in the chat somewhere.
You're talking about when they map it, right? Odysee?
I don't remember.
They have to remove the curvature when they put it onto a flat map because flat maps aren't.
All right. So at 44 minutes after the hour.
At some point, Austin, I'd love for you to explain why I'm a liar for saying that surveyors add corrections to be more accurate. That'd be great.
I don't know if you're familiar with this, but I'm actually not. I don't like talking to you.
Oh, I see. Well, you know what?
Yeah, when you say I called you a liar, like I didn't say you were a liar for saying they try to be more make more precise measurements. The truth is that the corrections apply spherical assumption, and then your rebuttal to that is no, they just do corrections to increase precision. Okay, so yeah,
did I say no? Because later I and Stark Otter corrected me. I said
so your point was just irrelevant. Gotcha.
I'm sorry. Continue. Why don't you like talking?
Oh yeah, Doofus. There's what I'm trying to figure out what that's talking about, Doofus. It's I don't know. Is there a page on there? Yeah, 51. But I gotta fix this. I'm trying to fix something to eat.
Like talking because I don't kowtow to you. Is that?
Hey, just to be clear, to remember, the station adjustments. Those aren't like corrections or anything. That's just the angles that reference the station to the the station they're using to zero out their angle, their horizontal angle. It's not like a correction or anything, or it's not like a it's not like they're changing it from the measured values. It's measured from it's measured from the reference.
Kosho, listen. The essential difference between direction observations and angle observations, from the point of view of least squares, it is that with direction observations, there is an observation equation for each reading, while with angle observations, there is an observation equation for each angle measured. They are putting these angles in equations, bro, and some of them they're weighting equally. And then they admit later that it adds accuracy and it is preferred, but they say it isn't needed. So they are doing adjustments to these. There's no doubt about that.
You said the difference between
exactly
what?
Are they doing?
The difference between what two types? Say again. The beginning, what you said.
Direction and angle.
The
Right.
essential
And you
difference
said they
between direction observations and angle observations.
Okay, and what are the differences?
Yeah, what's the difference? That was great.
It says is that with direction observations, there's an observation equation for each reading, while with angle observations, there's an observation equation for each angle measured.
And what's the observation equation?
Well, it gets into it under that, like page 38. It'll show some things, but
and you said that is to increase accuracy.
Well, later on, yeah, it says that they use some of them. They use like weighted equations that aren't all equal or something, but some of them they use like an equal weighted average or coefficient or something. And they say it doesn't. They say it's not needed, but that they use it because it's preferred, because there's no discrepancy or like no arguing that it's more accurate way.
Yeah,
And then it goes
that's
into
kind of my point, is that surveyors add corrections to accuracy. Yeah.
Wait, hold on,
but we were getting argued. We had anti-flat earthers arguing that point over and over and over. But now we see that there are these adjustments being made
Yeah, I know,
to
Regis.
the observed angles. So we got to figure out exactly what it entails.
I know. I'm trying to tell you. I've been trying to tell you. You disagree with me. But go to page 37. Page 36 and 37. It says the local or station adjustment of horizontal angle and direction observations. And then you go to page 37, and it shows you. And that's what I'm telling you. That these adjustments are in reference to a local station.
The actual measurement.
Yeah, that's the only kind of correction, or it's the adjustment in reference. So it's referencing, the angle is referencing a station to another station is 0, and then every other station is based on that one.
Can we all agree that this survey doesn't prove a flat Earth or a globe?
I wanted to finish something with Witsit real quick, because Witsit did point me to this thing. This occurs after observed angles. It's the column labeled spherical excess, or the spherical correction. Where is that? Hold on.
What is?
Pages 51 onward.
Yeah, that's regarding the spherical excess. Yes.
Yeah,
and they have a formula with an R value in it that they use to.
It's not being done for the observed angle. It's the column labeled spherical angles.
Yeah, and I think they have to use the sphere to estimate what that would be, and then they subtracted the measured angle from that. And that, I'm pretty sure that's just to establish the what do you call it? The correction value.
You can't model a sphere without a radius assumption.
That's where the correction value.
Hey, what's up with the plane triangle section, man? I don't know. Did someone answer that? What's page?
I just did. Sorry, you might have been away, but yeah, that's all after observed angles. There's columns for spherical angles, spherical excess in the charts that you commonly see people post. That's what those pages are referring to. That's not to do with the observed angles.
But what's the plane triangle? How do we have a plane triangle? If we just looked at observed angles, how do we have a plane triangle if it's a sphere?
They're giving you the excess that they expect there for that happens after observed angle. All of this is after observed angle.
Where do you get the plane triangle?
That's what's measured. Line of sight.
No, it's not. It's not what's measured.
It's not in a single plane, Brian.
I don't know what's so hard to understand that if you have line of sight, you're going to get 180. Period. Without, bar certain corrections and all that, but you're not going to map or model a sphere without radius assumptions. It's not possible.
Okay, they're not.
I'll go ahead, Kosho.
There's no point.
The triangles that they are marking down, the angles that they're measuring are not in the plane that those 3 points reside in. It's not a line of sight triangle that they're writing the angles down to, Brian. That's the part you
Fair enough. If you say it's not line of sight, then we can keep talking.
Yeah, it's not that they don't have line of sight. They have line of sight. The angles that they're measuring are not in the plane that those 3 points reside in. Those are angles that are in a different plane than that.
That's why they're off then.
If the verticals were all parallel to one another, then the answer would still be 180 degrees.
Bro, they're using spherical math to get the distances to even project triangles that are a smidge bigger than 180. What don't you understand about that?
There's nothing about distances. Stop bringing up distances. We're not doing distances. We're just doing angles.
Yes, they are.
How do you think they're establishing their stations, bro?
What we're looking at is the angles they measure. and the conclusion drawn from those angles.
Hmm.
We're not talking
Fine, we're
about
looking at all of
distances
them.
at all in
Distance.
this
That's why
process, because in this process, the distances are not used
it
right
boils
now.
down to distance,
In
bro.
this
That's why you're
process that we're
dividing it,
talking
bro.
about, we're only looking at the fucking angles. We're not looking at the distances.
I know you don't want to look at distances because every station boils down to the distance for the angle you get. That's all the corrections have to do with the damn distances because the line of sight gives you 180. There's no getting around it. What don't you understand about that?
It's not
The
about wanting
triangle
to.
that
You're not
they
there
are
yet.
the angles that they are measuring are not, I'll say this again, the angles they are measuring are not in a plane that those 3 points reside in, Brian. For fuck's
That's not
sake.
what they're telling us.
It is
They're
what they're
telling
saying.
us the line of sight triangles are equal 180, and then they
That's what
measure
they're
different angles.
Right,
That's
but
two
the
people that
angles that
interrupted me.
they
Go
are
ahead.
measuring,
That's three
once
people that
again, are
interrupted me.
not in a
That's three
plane
people, and
that
that
is
doofus gets so upset when
what
people
those
All right, all
3
right,
interrupt
all right.
him.
Can
points
we? Hey,
He does
reside
listen,
in.
that
we're gonna let
and
Rakia
things like
finish. We're
that.
gonna let Rakia finish. He was in the middle of talking.
Yeah.
Can we not start like devolving, please?
Your tears could cause a flood there.
All right, Chuck, you're gonna get muted if you keep on
Right.
ignoring the moderation.
Yeah, I was just trying to plainly say that if you have line of sight and you take a measurement of a triangle, it's 180 degrees. They even state that. Plain and simple in the paperwork. What we're trying to figure out is when they take the multiple measurements of different angles from the same station and then apply something. Now, y'all say it's not spherical measurements. I'm saying it is. And an angle measurement over that distance is going to give you enough. It'll give you whatever you want. I promise you that. You can go take angle measurements 26 miles from mountaintop to mountaintop on however many days you want. You're going to get things you're going to have to throw out. You got to deal with that. But triangles measured from, they equal up to 180 degrees.
Cool. They're not measuring angles in the plane that those 3 points reside in. They're measuring angles in totally different planes.
Yeah, that's why I said that's why you get off. You're going to get further off the more acute the angle is and the further the distance is. So if you say that distance doesn't matter, I think you're fooling yourself.
If those 3 points had verticals that were all parallel with one another, no matter what plane you measure those angles in, the sum would still be 180 degrees.
We hear what you're saying, big guy. But when you measure small triangles, right, from short distances and you get less than 180, and then you go out further distances and you get equal to 180, and then you go out even further and you get more than 180. What does that tell you?
You're on a sphere. Yeah. Distance matters, right?
It's a little bit different. For the
How
short
can you
range,
be on a sphere and get less than 180 or equal
Yo,
to
what that
180?
tells me is the error margin is always over. So they should be, the farther they go, they should be taking some degrees off for their error that they're obviously having if they're getting under 180.
They're trying to claim that the measurements are more accurate the further they are.
Yeah.
Well, only
For
when
the
you're
short
trying to
range-
measure the radius.
This is a fun circle. For the short range ones that were pointed out to be less than 180 degrees, those are part of a net. In that same net, those triangles in other directions were greater than 180. The sum of that particular net from one point is still 360 degrees, and the triangles in that particular net, all of the corrections, not all of the corrections, all of the excess in all of those triangles were still greater than 180 degrees on average.
Yeah, I get what you're saying. Yeah, because their error margin is so great. They're not computing it right, obviously, because if they get less than 180, you would never, ever do that on short distances on a sphere. It would always be. Yeah, I've listened to you. You listen. It's not ever just you, right? Have you ever done this? Have you ever even held these tools or used them over distance? If you have, then you know what I'm talking about. If you haven't and you're just reading the data, I understand what you're trying to say.
Okay, I'll go ahead and continue my point. It's not
He's
about
gonna
the
repeat
distance
it again.
because it's not about the distance because the same net that has the same distances involved, the sum of those internal angles, on average, was greater than 180 degrees for that same short distance. It's just that a few of those triangles did sum up to less than 180 degrees. The rest of them
We
summed
heard
up
you the
far
first
greater
time.
than 180
We heard
degrees. So it's definitely not a distance issue, Rakia.
say because we heard you the first time, and I went through it. I actually agree with you, but you're so just want to be right or want to talk so much. As soon as you say the further we go in distance and measure more accurate, no one has to listen to you ever again past that point. You can say all the data adds up and this, that, and minus and plus this. It don't matter. The longer the distance, the more error you're going to have. That's why when you do shorter distance, you come up with 180 degrees. The angle measures
You didn't hear a
themselves
fucking thing I said, Rakia. You didn't listen to a single fucking thing I said, because what I said was the short
calm
distance,
down, sir.
the
I'm
sum,
talking about
the average was
that.
still
I
greater.
wasn't done,
You
sir.
didn't actually listen to what I
You're
said,
not
though.
gonna
You
cut
said it
me
again.
off.
You said the short distances are less than 180. No, because
Yeah,
the
I'm talking
bullshit
about
that you
error
said,
margin.
I refuted
You don't listen
directly.
to me, young man. You need to
No,
calm
no,
down.
no, because you're going to
Calm
lie
your
and say the
roll.
same shit again.
Okay, can you guys chill out?
Chill.
Say again that I said that you have to go longer.
I guess that's a no.
They had to zero it out, so they couldn't measure less than 180 and then not adjust it to their spheroid. It wouldn't work, bro. They had to do that. Okay?
What?
That's what the corrections are for, bro. Line of sight is 180.
Brian,
What don't y'all understand about
Brian,
that?
it turns out that you're a little bit behind the rest of us, and you're not even clear on what's being measured here because they're not measuring just the angle from point to point. They're measuring the horizontal component of the angle.
And the
That's
you're
why
right.
they're
So
called
they're saying the
horizontal.
direction and the direction and the angles are different. So they started the survey off based on stars. They ended it up based on stars. All the way through, they did it based on stars. It's calculated distances. They didn't measure what percentage
Brian,
of.
you're just wrong in every count.
Let me ask you a question. Let me ask you a question to see what you
Before ask
understand,
me
please.
questions, man, just to catch up. They're not basing it off stars. Those are two separate measurements. This is why they have different sections in the document.
Okay. What percentage of the sides of triangles? In other words, if they measured all three sides to every triangle, then that'd be 100%. If they didn't measure any, that would be 0. What percentage of the sides of the triangles across the continent do you think they measured percentage wise?
33.
And a third.
Thank you.
Wow, Mason's
How did they base their stations on the sides they didn't measure? How did they base where their station set up on the sides they didn't measure? Based on a spheroid, for fuck's sake. You can't do it without base assumptions. What don't y'all understand about that? For fuck's sake.
We're not using the distances, Brian. You keep fucking it up.
That's why I intentionally didn't say distances. I just said the position of the stations because I knew you were going to say there ain't distance. So I just said position
No, it
of the
has nothing.
stations.
They
How do you think?
didn't base it off
Do
the
you think
distance.
they established the position of the stations that they didn't measure
off
distance?
the angle, and they wanted it to be above 30 degrees and less than 120 or something like that. From the other stations, there was considerations that go into where those base stations, or where those stations are. There's considerations that go into that.
No, you ain't answered the question. How did they establish the position of the stations where they didn't measure the two stations where they didn't measure the distance? The two next stations, right off the get go. How did they establish the position of them stations without measuring the distance?
Well, they probably had measured distances. They just didn't measure them outright using I think they said what they say, like one of those. What do you call that? Like the steel wire thing or whatever it's called. Whatever it's called. Like that metal tape. They said they do that with one side. They do that with the base of the triangle.
Indica or sativa?
Yeah. Listen to this. Ready? So after the baselines have to be adjusted, they need to do a reduction of horizontal directions to sea level, right? The resulting directions at the station, as given in the abstract, still needs a small correction to reduce them to what they would have been had the object observed upon been at sea level. The altitude of the observing station and the distance between them does not enter into the case. The reduction is due to the circumstance that, in general, the verticals at the two stations are not in the same vertical plane, right? Then it says the correction is given by this formula, right? And then under the formula, it says what they all mean. So H is the altitude of the station is observed upon. And then guess what P is? P is the radius of curvature in the plane normal to the meridian. So that seems like an adjustment to the base adjustments of these observed angles that does have a curve that needs to be factored in.
Yo,
Where does this
screenshot that.
correction? Yeah, where does this correction go in the final spreadsheet or in the final list?
It is a initial correction to the base stations. It's just done after the weighted mean part with the inverse square stuff.
Yo, real
Hold on.
quick, if you screenshot something, get the page number in it so we know for the future.
Yeah, I got you.
That way we know the page. And you ain't got to go crazy looking for it and shit.
Be all Bob Seger turning the page and shit.
Yeah, sometimes it's stuff on the computer. Sometimes like I can't get the whole page in there with the page number unless you like minimize it to such a small. But whatever.
Okay, I'm gonna finish my point real quick. I'll be quick and then go on mute. I'm not talking to anybody specifically. I'm definitely not talking to Doofus. Whenever we're taking a measurement, distance, I'm not scared to say it, always matters. So as soon as you say the further we measured, the more accurate we got, no
I never
reason
said
for
that.
me to listen. This
Yeah, I never once
motherfucker
said that. That's why you
interrupted me again. I wasn't talking to you, Doofus. No reason for
Man,
you
but
to interrupt.
Dude, I already muted him. Just go ahead, finish your thought. Doofus,
Yeah, so
Doofus
it's
finish.
hard to even know what I was saying. I don't even know where I was.
Distance always matters. So whenever you say that the accuracy increased with distance, something.
Yeah, when anyone's going to tell you that they increase their accuracy by increasing their distance, you can stop listening to them right there. No matter who it is. Thanks.
I don't know if that was addressed to Doofus, but if he wants to respond, if he was
I was really hoping we get to the end of what Regis was talking about. Like, this seems to be the whole situation. Maybe just got boiled down to that. I mean, Doofus, whatever. If you want to respond to that idea,
I would like to mention if you're
said.
measuring a 2 foot, if you're measuring a 2 foot board with a 1 inch error on the instrument that you're using, you know that 1 inch is going to be a significant portion of that measurement. But if you measure a 10 foot board with that same error, it's going to be
then
much
you might
less
be a
in
redneck.
proportion to that distance. I mean, I don't understand why Rocky keeps throwing that in there
Give it
because
up,
he's
Howard.
misrepresenting what was said.
We're talking about using an optical tool through the atmosphere. That's what I was addressing, not a ruler on a piece of paper. Thank you.
Yeah, I'm just trying to put it in a way that's understandable, you know.
Yeah, just keep it in context, though. We're talking about
guess I won't
theodolites and auto levels and things like that through the atmosphere, miles and miles, and saying that.
Yeah, arc
if
seconds.
You shoot
So
one, yeah, hang on a second. I'll go on mute. I swear I will every time. If you shoot a mile and get a measurement, and then you shoot 2 miles and say you're more accurate with an auto level, an optical tool, or a theodolite, an optical tool, you're wrong.
So if you shoot a mile and you've got a 2 arc second auto level, and then you shoot 2 miles with a 2 arc second auto level, what proportion of that 2 mile observation is that error compared to the 1 mile one?
It progresses equally as far as the distance goes. The point is you can't see as fine of a line. So the progression equals out. You could say a fucking star light years away, then the distance you're off is just going to be 10,000 times more. So the distance it equals out. Okay, but the being able to refine your position gets harder over distance, bro. He's not wrong. It's common sense for anybody who's did this shit in real life.
David started to say something, and I interrupted him.
Yeah, the air was cleared for me for a second, and then everybody else got it. But anyway, if somebody says, when somebody says things get more accurate over distance, he's saying that even though nobody else in this room said that. Nobody in this room today at all has ever said that you get more accurate as distance increases.
Well,
Yeah,
actually, whenever I pointed out that a bunch of the Globers say that now in this conversation, Coach just said, yeah. But anyway, Regis, what's the page number of what you were reading?
47.
Clearly getting lost in the sauce. Okay, thank you.
Oh, Bob was literally telling us like a week ago that the longer distance you went, the more accurate you got. Verbatim.
Well, he was trying to estimate the radius of the Earth on a half a mile shot. And what Bob said was, I would need to take a longer measurement to use that as an estimate of the radius. I could more accurately estimate the radius with a longer shot. That's what Bob said.
Negative.
Yep,
He said
exactly
he clearly
what he
stated
said.
verbatim. The longer distance you go, the more accurate you get.
Yeah, they told me that yesterday in Blue Marble Sciences server as well.
Yeah,
the whole
for
room
what
told me that.
specifically?
For
if
this
we're talking
survey.
about no,
That's what they said. Yeah.
The end result is the calculation at the end is more accurate. What we're talking about, the angles alone, the angles do not become more accurate. If
That's
you
what they
increase
said.
your distance from when you increase your distance to an observed target, the angle's precision does not change. But what does happen is that the depression from a particular reference grows at a rate such that you can get a radius calculation that is more accurate with that distance. That's not the same thing as they get more accurate with distance. There's more words there that need to be used.
Okay. So I specifically was pointing out that they're getting a greater fluctuation or deviation as they go to greater distances. And I'm like, so you're basing your entire argument on these claims of greater distances, but we know that the accuracy of measurements decrease. Optical observations are as redundant, but optical measurements and observations, the accuracy decreases with distance. And they said, no, it's actually more accurate.
Right. The end result is more accurate.
Okay.
Yeah, when they're calculating for the radius of the Earth, there's a bunch of different signals going into that first. The final calculation gets more accurate. The measured angles do not.
Hey, can anyone respond to what Regis was reading so we can get to the heart of the issue? Because I'm about to be back to my computer, but I'm trying to do something. It's weird that the flat earthers are the ones looking for the answers because this is the globe earth claim, but whatever.
Yeah, this is after station correction.
Really? And you're sure about that?
Yes, because it's in the section after the section about station correction.
Okay, but it's only after they take their measurements, they write down the observed angle, and then what he read is applied to the correction column?
What I read?
What Regis read.
Hold on, let me go.
See, this is what happens. Every single time we pointed something out, every single time they say, oh, that's just after the observed column. Every time, no matter what it is. So apparently when it goes to the correction column, they're doing tons of stuff. All right. Apparently you're using the spherical excess formula. They're using the weighted equation. They're taking the radius of the Earth and applying. They're using the weighted equations according to the Globers. The weighted equations are for the corrected column, as is the spherical excess formula. So they're doing all kinds of stuff, and they're doing temperature corrections.
They're going wild. Yo, they're running wild with it afterwards. Yeah, we need to know about the observed angle column, though. That's the
yes, exactly. Yeah,
that's an important bit.
This adjustment I'm reading about, it is definitely done before entering into the triangulation because it says that the altitude of the observing station and the distance between them does not enter into the case. So it's only done for the ones that are not at sea level, right? So it is 100% an adjustment that is with like the station adjustments before any corrections are made. So this is not part of the correction column. So this is definitely done beforehand and includes, I quote, radius of curvature in the plane normal to the meridian. There we
What
go.
page are you on?
It can't not be, bro. It can't
Hold on,
not be. They
Brian.
can't set up their stations.
Brian, hold on.
All right, wait. We're
What
trying to
you
get to the specifics. 47, I think you said, right?
Yeah.
We don't want to have like a meta conversation, like a meta repeat our, like the globe Earth. Oh, this is done before, and the flat Earth. Oh, they assume it's. We don't want to have like the meta redundant conversation. I want to get to the specifics so we can finally move on. I want to figure out what's going on. You know, I think that's clearly the most efficient and beneficial to everyone.
Yeah, I kind of feel like we should be like doing this right now together. Like that's kind of how I feel, except for a few weird comments. But I think this is something that we're kind of looking at together, right? Let's just figure it out.
These are corrections.
I'll
to
sum
direct-
it up for you. I think it has something to do with the way we view things over distance, and when you try and measure them through something you're observing through, like an optic, and you're saying you're measuring it in its actual position, and then you're correcting for what again? That pretty much sums it up.
These are corrections to direction, not corrections to the angles.
Direction is angled.
No, direction is not angled. Don't do that
Yes,
again.
it is. In
Don't.
what they're talking about here, direction is angled. It
Okay.
literally says it in the PDF, and I'll show that if need be.
You just identified the difference between direction measurements and angle measurements. You know that they're not the same.
That's not what it said. So good try.
You
It
just
said
said that a moment ago to Kosho. Hey, Kosho, you around?
Yeah. You were reading the part that was to go back to the part where you were expressing the difference between them.
Yeah, sure. Because it didn't say that. It was between reading and angle. Let me read it. Hold on.
It was between angle and direction.
Yeah, direction corrections and angle corrections are different because, and then you read off.
Yeah, they're the same thing, except one's with the readings and one's with the individual angle measurement.
Dude, if it's a direction correction, that's how you get your. That's what the azimuth is, which means it's factored into the observed angle column before you put it down. So all this like, oh, let's just get into the semantic diversions and this pedantic weirdo stuff. No, well, we want to figure out: do they put the R value anywhere in the situation before the observed column?
Literally does say
if
a
you
bunch of
apply the
times that
same,
direction means angle.
if you apply a direction correction to every direction around a point, and that's the same correction to every one of those directions. When you do the difference between two of those directions, does that correction manifest in that final angle?
And the thing I read was from the point of view of least squares too. It
Yeah,
says
seems
in
my
many
question
other
didn't get out
areas
there.
that direction means angle.
Can I get an answer to the question I just asked, or did somebody talk over it?
I talked over it. My bad.
Okay. When you apply a direction correction to all of the directions surrounding a point, does that correction manifest in the difference between two directions?
I don't really know what you're asking. I'm like trying to clean something.
Okay, so let's give an example, a very coarse example. Say you have an azimuth of 10, another azimuth of 30. You apply a direction correction to all the directions around that point of 2 plus 2. So now you have 12 and 32. Does the correction to the directions manifest in the difference between those two directions?
If you correct it exactly the same?
Yeah.
No, if it's exactly the same.
There you go.
There you go. That's what you're saying is happening here.
Right. The direction correction, if it's the same to every direction around a point, does not affect the angle difference, or the angle between two directions.
This is not talking about measured directions anyways. It's talking about the directions when you're comparing when you're comparing different nets or whatever. And it also says that this wasn't used in anything east of what does it say? Selena base.
Right.
I don't know which
Yeah,
one.
because it says they have surveys that they already use for other areas.
Well,
They
no,
were
no,
using.
no.
They
It says
didn't measure the
it
whole
says that
United States. I
correction
don't know if you
wasn't
guys know
made.
that. They didn't actually measure the entire United States. Majority of the data was from other surveys.
No, the other surveys were
Yes.
supplemented, were part of this survey. So when they say that, when they including other surveys, when you go to those other surveys, they say explicitly that this data is being used for the transcontinental survey.
So with one of the asterisks on one of the pages, it says that the station adjustment of observed directions, and then in parentheses, or angles, is carried out as usual by the Bessel's method. Observations are taken as of equal weight with the resulting directions or angles are directly introduced into the triangulation, blah, blah, blah. So direction in many spots of this PDF is referring to angles.
All right. Well, this part that you were talking about with the
it's not in this part. Okay.
No, I'm not saying anything about what you just said. I'm responding to what we're talking about. Okay, originally, which is about how these are corrections that they apply to the curvature. They use the curvature and they use the radius. This is what you're talking about. This has nothing. This is not put in before the measurements are made or before the measurements are recorded. It's put in before they compared to base nets. And it wasn't done at all anywhere. So what is it? East of Selena.
Right. Kosho's reading this part that I pointed to in red. In addition, it's a systematic, as in it's the same for all directions for a point. It's a systematic correction. That means if you have a difference between two directions, that angle will not manifest that direction correction.
All right, hold up. I had to walk outside. So what do you mean? So what's it mean when they're putting it through that equation that has the curvature of the meridian?
Right, they're giving you a direction correction. If you apply that to any particular point, to all the directions around it, it's not going to manifest in the angle between the two directions.
What do you mean by direction correction? Direction as an angle or direction as in direction?
Direction as an angle. Again, a direction is not an angle.
Okay, but it says it multiple spots in this PDF that it is.
They specifically say a direction and angles. They separate those two items because they are different
I
things.
literally just read it to you. But either way, so what are you saying then? The
Right,
formula that they
apply
put
a
on that page is for nothing?
If you apply a correction to a direction and you apply a correction to another direction and you measure the angle between those two, that applied correction does not manifest in that angle.
I don't know what you're saying. It literally says the reason for this is when you have a station that is a different altitude, then
Yes, and for that station, all
it helps
corrections
reduce
apply
it
to all
down to sea
directions.
level.
Right, and for that station, the direction correction for all the directions measured from that station is applied systematically to those directions, which means if you had no correction, like my example I gave was an azimuth of 10 and an azimuth of 30, the difference is 20. When you have the correction of +2, now it's 12 and 32. The difference is still 20. The correction does not show up in that resulting angle.
So after you put the numbers through the formula here, you're saying that it doesn't change the difference between them?
Right, because the
What is
angle
the-
is a difference between two directions.
Why in the world would radius of curvature in the plane normal to the meridian be part of the formula?
For a direction-specific measurement.
What?
What is the
Okay.
formula? Because I just joined, so I'm wondering what the actual formula is you're talking about.
Right, that's just, what is it? 42 after the hour I posted the thing. I think it should be in there.
Okay. Thank you.
Kosho, are you there?
Mm.
Is Kosho there? Hey guys, how are you today?
What's up, Chris? I'm here.
What's up, Lil? You were funny as hell the other night.
Yeah, but you said about your pronoun. Fucking guy. But yeah,
What did I say about my pronoun that I forgot?
I don't want to talk about it, Chris. But what was what's up, man?
I'm sad you never come in Gem server anymore. You hang out here too much.
Hey.
You're being persuaded by people like Rakia and left lane.
He's damn near. He's more a flat earther than Jeremy is. Sad.
You just blew my fucking mind, Chris.
I know you and left lane are local flat earthers here now.
Have you ever considered that maybe it's because that place is super, super toxic?
Well, that's not the reason whatsoever. So,
so Jim's isn't toxic to you, Kosho?
You're trying to give him a reason for why I'm not over there.
No, we're trying to give him a reason.
Maybe that's not the answer.
We're trying to give a reason for Leo to come here.
I'm trying to get Kosho's reason for him not going to gyms very often anymore. Not anybody else's reasons for why you think he's not going.
Yeah,
there.
apparently he's no problem with all the vicious doxing, toxicity, and threats and stuff. So, Kosho, why don't you go there?
Maybe he just thinks we're cooler.
I think we're cooler.
Yeah, I think he likes hanging out with us.
Spend some more time over there, Chris.
He might think you guys need
I bet he doesn't dream about Geo. Not Geo. What's his name? The other server.
Yeah,
I bet he don't dream
I have
about
one more
Jim
dreams
during
about
the day.
He might be here for Jeremy.
We're all here for Jeremy. Come on.
I'm here
Actually
for
make a
P,
change
but
today.
I can't talk to P right now because he's muted. But that's the best time to talk to P because then he won't talk back and talk over you.
I'm pretty sure a lot of people could say that about you, though.
Yeah, that's true. But I'm not muted. That's probably true, though. I agree.
You were funny the other night, Chris.
Thank you. I'm not funny anymore.
Well, were you drinking?
No, I don't drink.
You don't
I
drink?
never drink any alcohol. Well, I had apple juice. Does that count?
No,
I could use
I don't
some
drink
reason.
either. But it sounded like you had been drinking. But you were hilarious, dude.
Wait, do you drink organic apple juice, or do you drink that fake, like see-through-ish, weird color apple juice?
I drink apple juice that I buy at Walmart.
Oh. They actually sell organic apple juice at Walmart too.
Well, Chris Lowe's a Walmart expert.
Dude, if you drink like that, like really amber or like it's like that orangish, see-through-ish apple juice, like GMO nonsense, watered down, gross artificial flavoring apple juice that's like predominant everywhere, and then you go drink a glass of like real organic apple juice, you'll never be the same.
Simply Apple is close enough.
It's in the right direction, but it's not the same. Definitely better than the other stuff. Like I get mad if I drink other apple juice now. All right, let's see.
Why is Doofus here?
That's a good damn question.
Ask him the same question, man. Tell him that Rakia is rubbing off on him.
No, only you, Kosho. You like Rakia rubbing off on you.
That's enough, Chris. That's enough, Chris.
We don't need to talk
You
about
didn't deny it.
rubbing. No
You have a
rubbing.
crush on him?
Kosho did dodge that question though. Kosho, why are you here and not in Jersey?
It's probably just by default. Sometimes I open up my Discord, check whatever server was open by default.
And then we talk about rubbing again.
We're talking about King Kosho right now.
Let's bring it back. Bring it back.
Well, we were talking about Jeremy earlier, and I'm just very upset that we don't have a Jeremy appreciation thread.
Wait, why don't we?
I don't know. I think we should.
What's wrong with Jeremy? Where is he today?
He was here not too long ago. He's fine. Probably had something else to do.
Probably buying more phones for the little phone scheme.
Maybe there was an explosion in the bathroom and he had to go clean it up.
Possibly. Maybe he started feeling Earth's spin and he got dizzy.
That's what I'm going with.
How could he feel a spin if it's not rotating?
Oh, exactly.
Kosho told me that he was a flat earther one time. That he just likes arguing against flat earthers to argue against them.
Never said any of that, Chris, but that's true.
You did. He even dates flat earthers.
Let's bring it back, Chris. Let's bring it back to the survey.
That actually wouldn't surprise me. Like any of that wouldn't surprise me.
I know, it shouldn't surprise you. He's a closet flat earther.
Bro, you wouldn't date a flat earther?
I guess I would date a girl if I was attracted to her, and it wouldn't matter. Like the first thing I would not ask her if she was a flat earther.
But if you found out, like, that would make her less attractive?
No, I never said I would stop dating her. It'd probably cause contention, and contention in a date in dating relationships aren't very good.
I don't know, man.
No, you need a little bit of tension.
I don't know.
If everything's like,
no, I was just gonna say, I don't know. That sounds like a boner killer, you know. Finding out she's a flat earther, like, oh man, you know, that's I don't know about that, you know. Like, I don't mind having friends as flat earthers, but I don't know about the girlfriend though.
Have you ever held girls' hand?
Careful. Left lane is driving, and we don't want him to get in a wreck. He is driving.
Getting
a wreck.
If you don't do me asking.
Armor, have you even held a girl's hand, bro?
Yeah, I think so. Like in school,
I think so.
You think so?
It's not.
It's not. You should try it.
But the point is, though, all right. I'm just saying, all right. Like, as a friend, flat earther, that's fine. But as a girlfriend, though, I don't know, man. That like I said, I feel like it's just never gonna work out. You know, it's just not gonna. You know, like it's. I don't know.
Well, what difference would it make? It'd be like, oh, I like Fords, you like Dodges, we can't date.
I don't know. It's just.
I don't like either. We're putting brands in my mind there, Godscapel.
Oh, that's just.
You guys are so weak.
Kind of.
I'm just kidding. How are you doing, Godscapel? Haven't heard from you in a long time.
I'm alright. Living the dream.
Sounds like a
What's the dream? Are you dreaming about Kosho again? Well, oftentimes flat earthers do dream about Kosho.
All right, Chris.
Well, hold on. I feel like I did actually have a dream where I was like, it was going to call or whatever, and I feel like Kosho might have been one of the people in the call. Maybe.
Definitely too much information.
Well, these conversations can deteriorate at a rapid pace, man.
Were the headlights on or off?
What?
Were the headlights of the car on or off?
Oh, whose car? What?
Armor's digging himself a hole to rival the Cola super deep borehole.
The car that Kosho was in. Were the headlights on or off? Was it daytime or nighttime?
Oh no, not car. I said a call. A call. Like this.
Oh, a call.
Yeah, it was like a debate or something. But
Oh.
I just Kosho,
Were
I
the windows
Did you
steaming?
say we were on a date?
No, what's that date?
Were the windows
I
steaming?
said a call, and I said there was like you know, like a debate. They see. I guess I'm just saying words short. Whatever. I didn't say car. I didn't say date. I said debate, and it said call. All right, you guys are hearing shit now. You guys are hearing what you want to hear, especially you, Kosho.
Armand, were the windows steamy? Were the windows steamy in this dream?
No, there was no windows. It was a call.
Oh.
It was a call.
No,
Yeah.
Well, there must have been windows unless you're a Mac user.
Oh, okay, that's funny. No, but yeah,
Were your windows steamy? Were Kosho's windows steamy?
All right.
Kosho's windows are always steamy.
All right.
They're steamy right now.
Let's bring it back.
I'm rather enjoying this, Coach.
I do, I do apologize if this was my dream though. But like I said, it was just like that usually happens. You know, like if something is like I'm focused on like a debate or something, or just something, whatever. Like there's always like the one person, whatever, that kind of sticks out. I guess because you're a pretty good debater, that's why. But
he's a good he's a masturbator. He's not just a good debater.
like I'm sure.
Yeah,
there's
I
also-
know.
I'm pretty sure
Anyways, Aram, You don't ever have to apologize for having kosho in your dreams, okay?
Okay.
Like I'm sure there was also like flat earthers there too. I just can't really recall because once again, like I'm sure
Well,
I've heard, but I just
do you
can't.
draw like anime versions of Kosho?
I don't even know how
Can
he
you?
looks like Resolve.
Listen, guys, can we try and bring it back to the angle of the day?
Offended because he's black, guys. Come on.
Look what you started, Chris.
It's Kosho who started it. It was his. He was in someone else's dream. It's Kosho who started it, not me.
Fair enough. But I should end it then. Let's just bring it back. I'm
How's
making
that
a
song go? Get out of my dreams and into my car.
Who else has had dreams with Kosho in it if we're bringing it back?
Kosho, get out of my dreams and into my car.
He might pick you up on that.
Oy vey. Okay, I'm making a meme. I'm making a picture. Hopefully, it's going to clear something up. We'll just start.
I don't know. If you're having a picture of you in a car, that probably doesn't clear anything up.
Kosho, I think you might be my favorite Jew. Just to let you know.
Oh, that's nice of you.
It's
Oh, you
you
said you. Okay, that narrows. I thought you said your favorite dude. I was like, wow, dude, that's
No.
that's real favorite
It's
dude.
between,
That's not
between
hard.
you and Zuckerberg. Sure, yeah.
Kosho, you do realize that his bedroom walls are white, right?
Is that racist?
Yeah, I was just gonna say that's how you know you're racist when you have a favorite Jew.
That's a good one, God Scalpel. And Kosho is Jew, so that,
You should have heard what Chris said the other night, dude. He said, what if my preferred pronoun was the N-word?
Yeah, I've asked people that before. There's no answer to it. It's dumb as fuck.
Funny.
I had a black friend of mine telling me I was racist if I could count all my black friends in one hand.
Really?
Yeah.
I mean, a lot of people, can only count all their friends in one hand.
Yeah.
Yeah.
I can't
Never mind. Never
I
mind.
can't even
Different.
count that high. I don't have that many friends.
Have you noticed how all of these rules about how racist white people are never applies to anyone else? Like, no one ever asks a Chinese dude how many non-Chinese friends he has.
That's right.
It's like the racism rules.
Kosho, how many non-Jew friends do you have?
A lot.
I'm sure.
Fortunately, a lot.
Name them all.
Okay. Anyway,
See, he lied.
Okay. Yeah, my sister. When we were younger, she only would date, or she wouldn't date white guys or whatever, white guys, and I told her she was racist.
Oh, hey, Kosho.
And it's not really. I knew a guy in the Navy. He was actually a white guy, and he always.
He was actually a white. You sound surprised.
No, I'm saying he was a white guy, but he only dated black chicks. Like he never dated white chicks. And I thought that was racist too.
Wow.
Why is it racist to have preference?
On a side note, my brother says you're not touching his account with a 20-foot pole.
Okay. Stop trying to trigger me, dude.
Genuinely, Kosho, do you actually have that opinion?
Do I have that? What opinion?
The opinion you said, is that actually your opinion?
Opinion
Like,
of not touching an account with a 30-foot pole.
Wait, which opinion? I'm sorry.
Like if someone has a preference for certain.
I don't. Not necessarily. Not
I
necessarily.
prefer girls that are attracted to me and that
Necessarily me. Come on, let's clarify.
Yeah, so I mean, I said that I said that in reference to both people, kind of jokingly to them, but in reality, I don't think so. I think it's like ice cream or something, It's like people don't like.
Yeah, you know what? Vanilla ice cream's the best.
Yeah, but what if you like cookies over ice cream? Does that become something then? Instead of just what kind of flavor, you won't eat ice cream, you'll only eat cookies. Does that make you like racist?
No, still it's not.
You know what? I only like chocolate with stuff in it. I don't like pure chocolate.
I bet you like stuff in it.
Yo, Brother Lael, I've got a question for you. Can men get pregnant?
No. Emphatically no.
Fantastic.
Well, what if you have a woman that transitions to a man and gets pregnant?
That's a
Not
woman.
Then it's what's that?
She is biologically a woman. She's a woman, whether she
No,
seems to
she
be a man or not.
transitioned to be a man.
No, if her chromosomes if her chromosomes
So you don't even
say
understand
she's a
then.
woman, then she's a woman. Whether or not she believes she's a man, she's still a woman.
I think you're wrong, Chris. Once they transition over, once the transition's complete, then it's complete.
Are you joking?
Sorry, they don't transition their chromosomes though.
Am I joking?
You know he's fucking with him, man. Come on.
You've got to be joking, surely.
No, I'm serious. Once the transition's done, then she becomes a man.
Yeah, of course.
You ever notice there's not that many women that try to transition over to be a man? It's all the men trying to transition to be women.
Yeah, why aren't there any women joining the NBA?
And not only that, but they're not very committed. They just go with the upper portion of their body. They do cosmetic surgery, but the lower portion, they never seem to want to go all the way.
There's not
God,
much you can do.
you better be careful. Kosho has had cosmetic surgery. He thinks he's a woman.
Well, I kind of always thought he was a woman too, so I guess it makes sense now.
Okay, perfect. And that's weird that that makes sense now that guy dreams about Armin dreams about Kosho because Kosho's a woman.
Okay, dude.
It does make sense now.
I should have never told you were funny last night. The other night.
There's a lot worse things I've heard Kosho do in the past, so I mean, it's quite mild.
Can't get any worse than now.
Well, I don't know, like some of the things that he's bought at yard sales or whatever, wherever he bought it used.
A doll? He bought a doll at the garage sale?
I don't think it was a doll.
A blow-up doll?
Well, something along those lines. Wasn't it, Kosho? Maybe just not quite as big.
I would tell you to refresh. Oh.
You want me to refresh it?
No, it's all right, man.
Was it a boy doll? Was it a boy doll that transitioned to a girl, or a girl doll that transitioned to a boy?
That's awesome. Oh, he stopped in his tracks. It's probably bullshit anyhow, but it's still funny nonetheless.
So we're all agreed that it's flat then? Thank
Yes. Yes.
It's especially Kosho.
Hey, Chris, if you were to transition to be a girl, what size would you make your boobs?
I don't know. I have to refer to Kosho, so I'd have to ask him.
Okay. Let's just.
That's a tough one. Let me think about that.
Yeah, like would you want big ones or just medium or just average?
The answer is I would never even think about it.
Oh.
You come on, Chris. We already know you thought about it.
I mean, it's like one of those fun things, like, oh, what animal would you be or whatever, you know? Like, no one's actually thinking, like, well, shit, you know? Like, I mean, like, it's just, make believe.
Like, yeah, like the ball. You guys should be good at it.
Like the flat Earth, all right? Flat Earth.
Make believe. Yeah, you guys don't mind that make believe shit.
Oh, but it does like make believe.
Dreams about Kosho.
Feels a lot like make believe around here.
Armor, if you had to fight an animal, would you rather fight a lion or a gorilla?
Ooh.
I would. Well, okay. So, is it definite that I have to fight them? Like, there's no way I can, like, kind of, like, maybe they won't fight me. Because if that's the case, then gorilla. Because there's a possibility that they might not fight me. But if they're going to fight, like, without a doubt, I feel like I still fight like probably a gorilla though. Because I mean, tiger.
Have you not seen Planet of the Apes? Are you crazy, man?
You just pick a gorilla.
Well, hold on. What was it? Tiger? You said tiger, or was it a lion? You said tiger,
Hopefully,
right?
no one watches.
Lion. Well, yeah. I mean, lions. I mean, like, don't get me wrong. All right. Like, obviously, gorillas are really powerful, but like a lion has a lot more. Like, I don't know. There's a lot more weight going around and shit. I mean, you're dead either way. But I feel like with the gorilla, I don't know. I feel like I don't know.
I'd pick the lion because the Maasai people kill lions every day in Africa, so it can't be that.
But bare hand or like what weapon? What weapon? Like we have like a weapon or something or what? Like bare hand? What are we doing here?
Yeah, you can have a couple of daggers. Why not? You can have a dagger in each hand.
A dagger?
Whatever's around you.
Well, then like a gorilla because I feel like I can get to their neck more than like a lion's. Like you know what I'm saying?
This is the animal that I would be.
Dude, if you think you get to a gorilla's
Yeah,
neck.
you'd be fucked. You better go after the lion.
Too, right? A lion would get to your neck faster than you can get to its. I mean, I'm just saying. Like, I don't know.
You asked if I were to transition to an animal, what would I be? This is what I would be.
I didn't ask you
And
that.
notice the color.
I was asking about your boobs.
Hey, hold on.
Oh,
You guys really think you can fight a lion? These motherfuckers are huge.
Easy, because the lion will jump on you, and then you can stab him with your daggers while he's over top of you.
There's a lot of things
You've got more chance against the lion. I think you've got way more chance against the lion than a gorilla.
I think so.
Rick Graham could beat you with it.
I don't know. I mean, I watched like this video. It was like gorilla versus lion. It was a 3D animated. It was so stupid, but it was like I don't think it was a lion. It was like another big cat though. But it was like a big cat versus like a gorilla, or whatever. And like it was animated really stupidly, but it was animated nonetheless. And it was just like no, like the big cat won that fight easy peasy. Now, granted, obviously it's me, a human versus a gorilla versus or versus a big big cat like a lion. But I still feel like I don't know.
Did the gorilla have daggers? No. See, that's the difference right there.
I mean, I guess if the lion jumps on you, but I mean, you're really underestimating. Like I feel like
I've been in a cage with a lion before.
I think I choose a gorilla. I think I choose a gorilla too because for one, lions have claws, so when it grabs you, it's gonna.
You think gorillas? What about their teeth, dude?
Well, how
you can get away from their teeth.
The gorilla grabs you by its fucking hands, dude. A lion's. I think a lion's claw. I'd rather a lion's claw be on me than a gorilla's hands.
I don't know,
It's just
dude.
gonna
Those
rip your skin open.
I've
Gonna rip
been
your
in a
face off.
cage with a lion, and those claws are literally at the tips of them. They're like needles. Like no word of a lie. They're that fucking sharp.
Well, yeah, I will give you this. The gorilla does have arms, so there is a more going on. Like he can grab you, dislocate your fucking limbs, whatever. You can rip them off too, depending on what he's doing. But okay, I'll give you that. But I don't know. I mean, that's
a lion's tongue is like sandpaper too. It feels like you're being licked by about 80 grit sandpaper, man. I'm
not gonna let it lick me.
Yeah, but that's
you might not have a choice. I didn't.
I mean, I don't. This is
probably dead in an instant if against a lion. If he does get you, then you're dead. He's gonna try to kill you. A gorilla's gonna do some weird shit to you.
Okay,
before it kills you, it's gonna do some weird shit.
Okay,
to you.
Yeah, but going in your favor is that gorillas have tiny penises, so it won't be sexual.
That's funny. But, I mean, that's tough though because I know there's certain animals where they get to a certain size, things just stop working on them, with bears, whatever. You can't just you need an actual big gun to take them down. If you use a pistol, whatever, it's not really gonna. You know what I'm saying?
That's not true.
Yeah, what's that movie with what's his name? Alec Baldwin and Anthony Hopkins when they're fighting that bear, and he uses that spear and he lets the bear's weight fall on it.
Okay, that's
what one man can do. What one man can do, another can do. Yeah, I've seen that.
There's been people that have actually fought off a grizzly bear. I mean, they pretty much may as well have died because they got mauled pretty good, but they survived it with a knife.
Yeah, not grizzly man though.
Yeah, a grizzly. Yeah, it's happened.
It's a grizzly man.
I'm not saying it happens all the time or anything, or that's a good idea to try, but
I'm saying grizzly man, the guy who lived with the grizzly bears every summer.
Hey, what about him?
Well, he took his girlfriend up there one time, and it didn't really work. He used to fucking yell at the bears and he'd videotape it and they would love him and.
Yeah, I've seen him before. Yeah.
Yeah, but then he took his girlfriend up there one summer, and I think that changed the dynamics. And there was a hungry bear it ate both of them.
For real? He's dead?
Yeah.
Okay. What if I have a really long spike, or just a really really sharp ass knife, but it has to be really long though, right? Like Sephiroth's length, but also a dagger on me, right? Can I fight the gorilla with that and the lion with that? like a really long fucking katana thing, and then also like a little short dagger just in case it like breaks through that defense, whatever. Like I can't use the long sword. Like I
You
just
can use a nuclear bomb if you want.
stupid. It wouldn't even matter at that point.
Machine gun.
I will take either one of them. I'd be like, okay, sure. I'll just drop it on, whatever. No, I'm being serious. Like if I can get like a long ass like katana, right? Like, but also a short dagger, just in case it comes through and I can't use the sword anymore because it's like inside my
If
bubble.
someone said you have to fight a gorilla and a tiger, if you're wrong on one question and the question is the Earth a ball or flat, what would you say?
Say fucking
I'd be like, thank God that's the question.
Yeah, but then you found out the truth and you're like, oh shit.
That would be horrible. Yeah, that'd be a horrible way to find out. I mean, honestly,
I'd be like, thank God that's the question they asked his ass.
I don't know, man.
Yeah.
What if they sick them
worse
like,
way to
oh
find out,
shit,
though.
I'd be like, ask that to paid NASA shield, please.
Ask anybody, man, because everyone you already think you're right. Like if you think you're right, you're going to say what you think is right.
Yeah, but here's the thing, though, right?
It's not going to change your answer.
Yeah, and there's no like, there's no like, oh, this is rigged, whatever. Like they literally like, fly you up into space, then they bring you back down to get you fucked by the fucking animals. So they go, there you go, look, it's round. It's like, oh shit, you go back down, whatever. You have to plan your escape because once you're down there,
No, you got the story wrong. They go, oh, look, there you go. That's as high as we can go because it's not round.
Kosho.
And then take you back down and you get your ass kicked.
No.
Kosho, ain't it funny that every proof y'all try to bring up, dude, there's so many holes in it. When we look at the detail, dude, it falls apart. Every fucking proof y'all bring up, dude, it winds up being horse shit, dude. Winds up being non-conclusive, man. Doesn't that piss you off?
Funny's not the word that funny's not the word I would use, man. Depressing, sad.
Yeah, it's got to be depressing to be in your shoes. I would agree.
No, not because there's actually holes in it, but because the people.
You're exactly just wrong.
They all wind up proving a flat Earth, bro. If you look at the detail, just about a lot of them.
How do longitude and latitude prove the flat Earth? Debunk the globe, whatever it is you said. Like the coordinate system. How does that debunk the globe?
No, I didn't say they all prove a flat Earth. I'm saying a lot of them, like we all talk about boats disappearing over the horizon, bro. With an in-depth look, bro, that y'all are screwed with like the whole geometric horizon with
my favorite
dude with
one is longitude.
with sun shining on the bottom of clouds, bro. That could never happen on a globe with a sun above the horizon, like with the shadows. What are you talking about? Equinox, sunrise, star trails, bro.
Brian, I would love for you to draw a diagram.
What's this about? What you talking about? No,
Brian, I would love for you to draw a diagram and show us how the light from the sun can hit the bottom of clouds.
Bro, if you understood the trick like Kosho does, you'd understand that a sun that's 1 degree above the horizon is, as far as the tangent from our feet, it's like fucking hundreds of thousands of miles. It's actually like 800,000 miles above our feet, bro. Just from the tangent of our feet. So if you go up, if the sun's 1 degree above the horizon and you go up in the air, the sun's going to follow you. So what about when you get above the clouds? The sun is now above the clouds with you. You can go all the way to the moon. The sun's gonna follow you all the way to the moon. So how is the sun 1 degree above the horizon hitting the bottom of fucking clouds? It's not possible on a globe.
Again, Brian, how does this light from the sun hit the bottom of clouds if it's thousands of miles above the clouds?
Bro, did you hear anything I just said?
I did.
Kosho, let me get an intermediary. Kosho, if the sun is 1 degree above the horizon, mathematically, how high is it above our feet, roughly?
At the distance that it is,
like 1,600,000, I think.
Okay, but what you have to give it some distance, don't you?
A tangent for a 93 million mile sun that's 1 degree above the horizon being 0. Mathematically, how high is it above our feet from the tangent from our feet?
Assuming that it's as far away as it is.
Yeah. It's over 1 million miles, right?
I forget the value. That maybe. Yeah, hold on.
It's 1,600,000. So the fact of the matter is, if you go up above the clouds, the sun's just going to follow you. So there's no way that a sun that's mathematically 1,000,000 miles above the clouds can hit the bottom of clouds, bro. Y'all
Brian,
lose that in the
think about,
lose that
hold
in
on,
translation.
Brian. Think about being on a curved surface, right? Now on that curved surface, the sun can fall below your eye level. So that means at some point the light can shine upwards towards the clouds.
I didn't say a sun below the horizon. I
Yeah,
said
that
a
was right,
sun
Brian.
above the horizon.
Brian, you were right.
That's
That
how
was
it
about
works.
1,000,006. That's right.
So if you could go all the way to the moon and the sun would just follow you all the way up to the moon, right?
Sure.
And it would still be shining on the bottom of them fucking clouds, B-ball.
Wait,
Dumbass.
hold on.
What image are you talking about? What image are you talking about, dude?
Yeah,
The
let's
sun is
first look-
visible and it's below the clouds.
Yeah, let's see that first. But also, right? Yeah, how you're saying it's above the horizon? How much so? Like, is the bottom of the sun touching like the horizon, or?
I know,
is
but
it...
let's find out if it's above the horizon at all. Because you're saying that, but all those images I've seen, I've never seen the sun above the horizon.
I've showed it as far as 4 to 5 degrees above the horizon, but that's the most extreme I can find. But
And it was still lighting up. It was lighting up only the
any of
bottom
the
of the
examples
clouds.
you look at, they're 1 or 2 degrees above the horizon.
What do you mean by it's lighting up the bottom of the clouds?
Oh my
like
God.
like around sunset.
Okay. First of all, okay. Well, hold on though, because no, that doesn't make a difference. Like okay, so if the sun is low in the horizon and the sky's red, that's not like it's not a contradiction or anything. I thought you were talking about like it was creating a shadow. It would be weird if it was below, if it was above the horizon and it was creating a shadow on the clouds of like a mountain or something. So this is
I
not
can show you that too. I can show you that too.
Picture, just in case you don't see that.
Well, let's see that,
bro. So you agree? You agree that if the sun's shining on the bottom of a cloud and it's 1 degree above the horizon, then you got problems.
If it's casting a shadow on the bottom,
just says no. He doesn't have no clue and
Well,
just
Brian,
says no.
the reason why I say no, Brian, the reason why I say no is because I can draw a simple diagram of how the light is hitting the bottom of the clouds, and you can't using a flat surface.
What are you talking about, bro? I could demonstrate it, and you can't. You can't
Yes, I
demonstrate
can.
23 million miles.
Yes, I can. It's easy. I'll do it for you right now.
Here I
Well,
am.
hold on. You know how slight of an angle you have for the sun to hit the bottom of the clouds? You have a window of about 4 or 5 minutes, and you have about a third of a degree, depending on how far the cloud is away. You have hardly no window at all. If you actually do the math, bro, it's almost impossible, dude.
yeah, but that doesn't happen though. Like you like when it's above the clouds or when it's above the horizon, the light's usually above the clouds, right?
When it's above the horizon, I'll post several fucking examples. Hold
Okay,
on.
let's see those first at least. But I guess you're not half wrong. You're not really wrong because I'm thinking about it now. If you treat the clouds as like a ceiling, right, and you were to be leveled with the bottom of the clouds, then that would be level, and then obviously the sun would have to be above that, right, because the horizon would be roughly around that level line. So I guess that would check out. There would be no way for the sun to actually, the light from the sun to actually hit that ceiling of a cloud, surface, whatever. So all right, yeah, let's see these pictures. Let's see if this is this is an
Wait a minute, hold on. Where are the clouds exactly? Because it actually depends on how far the clouds are from you.
Well, would it also depend on the tilt too of the cloud? Because if the cloud isn't like perfect, if it's like, I mean, not tilt, but like clouds aren't perfectly like flat at the bottom. Like some of them.
Well, no, yeah, it depends on. Well, the tilt of the clouds also depends on the distance of the clouds from you. So it depends on how far away the clouds are from you.
Yeah.
You have a cloud tilt measuring device?
Yeah, it's called the distance of the clouds.
It's also depend, like if you're in an airplane taking a picture of it, the shadow will still be cast on the cloud. So I'm thinking you might be able to try to think of these scenarios. Still casting the shadow. You'll be 2 degrees above the horizon with your view 3 degrees.
I wasted so much time in here today, man.
So is Brian gonna send?
Yeah, I'm posting it right now. I'm getting a screenshot because it wouldn't post the 3-second video. Hold on, here it comes. This is about 5 degrees. There's even a mountain and trees in this sun's well above the horizon.
Let's see this.
I could give you so many examples, bro. The day is long.
The day is long.
I can give you examples as long as the day is, and they try to use this as proof. This is ridiculous, dude.
The
This is a
longest
globe
day.
killer. This to me is probably the #1 globe killer.
What is that?
That's not. Those are not underlit clouds.
Jesus Christ. Are they?
That's
Aren't they?
first problem is no.
No, you can see the shadow on the bottom of the clouds, man. That's the clouds are obviously lit from above.
Let me see. What's the source? Like, you have like the original, or is this like a screenshot you took with your phone? Like,
Bro, just look up fucking sunsets with clouds. There's everywhere. I mean, I just posted one, bro. There's gajillions of them.
Yeah, but that's not underlit clouds, which is what we're talking.
No, but also, like I said, after I thought about it further, it depends on the distance from you and the clouds.
It gets worse. The further away the cloud is from you, distance-wise, it gets worse.
No, well, yeah,
The sun is higher up.
Underlit.
Compared to the angle, that means the sun would be higher above the horizon the further away from me I get. So based on the cloud, that would put the sun higher.
Let's see, sunset. I need to see some pictures.
All right, so you see the picture I just posted?
Bro, this shouldn't be something we have to show examples of, bro. It's every sunrise and sunset, bro.
No, never. It never happens. It never happens. You haven't, and you just displayed it, and you just displayed it, and you just displayed it without it happening. So I mean, you're laughing and you're cackling like a little girl, but it doesn't happen. At least I haven't seen it yet.
It never happens. I'm sorry, all the millions of fucking pictures. It never happens.
You see what Earth is Life just posted.
Well, hold on. I'm going to play devil's advocate with that because technically, like, where would the observer be watching this cloud?
The observer's on the top. The observer's at the top. The sun's not even near setting yet.
Yeah, but here's the thing though. With this picture though, the clouds are opposite to the sun. But in the picture that Brian sent,
the observer's not going to see those clouds. Yeah, that's true.
Yes, put the observer to the right of the clouds.
Put them right to the clouds.
Yeah, but if the observer's to the right of the clouds, then in that case, the sun's already gone below the horizon for him.
This is not to scale, right?
What are we on?
Why don't you look at the photos I posted?
What are you guys talking about now?
Gay stuff,
Jeremy,
Jeremy, just
how
gay
it's
stuff.
possible to have underlit clouds on a globe.
Trying to make the sunlight underneath. Another misunderstanding of how things should work.
I think the only thing that I can potentially argue is that, like, with clouds, obviously they're not like perfectly flat on the bottom. You know, some get kind of close, but like they're usually like rounded off and whatnot. So like the parts that are rounded off, they're going to be like tilted, and those can receive the light.
And curve with the Earth.
Okay, there's also the curve with the curve with the Earth. That would actually be against. That would actually work against, because in that case, towards the sun, they would be curving down even more. So then it would be facing even more away.
You can do it with a light source above a shed, and there's no light underneath. There's no shadow. And move the light away from you at the same distance above the shed, like the same height above the shed, and then the light will shine underneath the shed. I mean, y'all lost y'all's mind?
Well, hold on.
I actually saw that shed video. That was a good one, yeah.
Well, hold on. Earth is Life, though. Here's the thing, though. That with the observer in that picture, though, they wouldn't see the sun. The sun would be below the horizon at that point.
The angle changes as the source light goes away from you. Hello?
What are you talking about, Rocky?
The angle changes.
You got to think that the light hitting the clouds, from the bottom, is not as refracted as the light reaching your eyes from the ground.
So it's the same thing as when you're at like the beach, and you don't see the light. Like you're not in direct sunlight anymore, but yet the clouds are still illuminated by the sun.
Well, yeah, but that's expected. That's expected. He's saying that it's impossible on the globe if the sun's above the horizon and the clouds are, and it's being lit like that.
No, it's saying that. He's saying that because there would be just this small gap. But if you just take a light source, pretend that's your sun, put it above a metal roof, like 10 by 10 metal roof, pretend that's your cloud, and then move the light source away in any direction at the same height above the metal roof, and watch what happens. Be amazed.
It's not going to light up the top of the roof.
What are you talking about? It's already light up the top of the roof.
You're not going to see sunlight. If you have a light like that, it's not going to bring light and then create a shadow, for instance, above on the ceiling.
You don't. I didn't say anything about a shadow on the ceiling.
I know,
I
but
said
that's
the
what we're talking
light.
about. In
You're
order for
not
the light,
listening.
in order for the light to be hitting the
Oh
ceiling,
my
it'd have to
God.
be able to create a shadow.
Okay, so this. Oh, actually, we redraw that. This would be probably a better way to.
So does any Glober understand what I'm talking about? You can demonstrate this yourself. It's not very hard.
No,
B-Ball doesn't understand. Any other
no, I don't
Glober?
understand. No, you have to explain it a little bit better because I don't understand.
B-ball,
Yeah, yeah. Better
I
than
also
taking
don't
a light
understand
source.
Rakia.
Well,
Yeah,
then just do
can
it.
you explain it again? Can you explain it again? Because I didn't quite catch it either. I mean, I didn't quite hear it. It's not that I didn't understand it. I just didn't hear it. What you said.
You have a shed, 10 by 10. You have a roof on it. It's flat. Just make it flat. Put a light above it, 10 feet above it, and it's lighting up the top of the roof, right? Now move that light, still keeping it 10 foot above that roof in any direction for distance, and it's going to start shining underneath the shed.
Yeah, but at what point is it gonna shine inside on the ceiling?
It has to be shining light directly on the ceiling.
Yeah, he's saying it would do that.
I don't think
Above the ceiling, yeah.
It wouldn't do that though.
Why not?
Yeah, I don't get why
Because
not.
because the angle is always going to be above the roof. It's always going to come from above the roof.
No, you can do it with a flashlight in your house. It only takes about 20 feet. What are you talking about?
Demonstrate it.
You said the light is 10 feet above the roof, right? At what
You
point
put
is it
it-
going to be below the roof?
Well, the further you put it above the roof on your starting point, the further the distance has to be away from you for that angle to change, for the light to come underneath.
And it's always going to be above the roof, no matter how far away you go.
Yeah, right. But when you change that angle due to distance, the angle of the light shining on top and on the bottom will equalize. So it'll actually be shining on both. And then it'll start shining underneath just because you change the distance, which changes the angle.
Right. Yeah, it's about angles, B-ball. It's the actual angle. It's the angle and positioning, and also perspective and how perspective works. Like, for example, in the hallway, when the lights look like they're setting, the ones that are on the ceiling, they're not actually lowering. So there's a component of perspective. And over a flat planar Earth, when you're looking out at the sun and it's setting, you're pointing at it. The sun is not actually, horizontal to you. It would be above the surface. However, due to perspective, it is. And that light is coming and hitting your eyes. Therefore, it's lighting up the entire environment.
Yeah, but we're talking about the light illuminating the entirety of the inside of the shed, right?
Yeah, I think what he was saying, if you have the shed, he was saying if you have the shed and the light above the shed, and you start taking the light, if you have a big field or something like that, and you start moving the light away, he's saying yes, eventually it will light the underside of the shed. Now, I think I agree with the principle he's saying. Now, I don't know what the proportions with 10 feet and et cetera, what distance you would need and the brightness of light. So that's the only reason I can't say that personally, just because I haven't tried that. But the concept he's saying is correct, and it's also my understanding of how this works.
And right now, get a Frisbee and a flashlight. Put the flashlight above the Frisbee, and then move the Frisbee the same height above the Frisbee away from it, and watch it shine underneath the Frisbee at a certain point.
I gotta go buy a Frisbee first.
Yeah,
I'm going to say never happens.
Yeah,
the angle will get more and more oblique, and yes, it will start to eliminate more of the shed.
All right,
but
so if what Rakia,
at some point that stops.
All right, let's just get this down. If what Rakia is saying is correct and what I'm saying is correct, if this can be demonstrated the way that we're describing, will B-Ball and Moyak and you guys, will you agree to 1,000% concede that yes, this could happen over a stationary planar Earth with the sun above?
Make it happen. Because for one, the sun is
right. Hold on, because but the concession will be expected when it gets to that point because
So the sun is supposed to be thousands of miles above, right? So we're not talking about 10 feet. We're talking about thousands of miles.
Well, it's all proportions.
I'm confident it's 10 feet.
Well, first of all, I'm not claiming the sun at any distance, first of all. We're talking about whether the sun above a planar surface could do this lighting effect. So that's what we're talking about. So we're talking about recreating it on the small scale. And the way that Rakia described it is precisely my understanding of how it works. So it's a matter of can it be recreated in a scale that is acceptable to you guys, or whatever you would be looking for to understand how this can work over a planar surface?
I contend I could be 1 inch above it and not have it go under, like if I had a 2x4 or even something a little bit wider than that, and I put that light above that 2x4, I will never get it to illuminate the underside of that, other than like through reflections, and those become more oblique.
I don't agree with you, dude. You have to move it away. I don't agree with that at all. If you like take a Frisbee in a field and a flashlight and put the flashlight 5 feet above the Frisbee, have someone hold it up. Someone's holding the Frisbee at, let's say, 4 feet, and then you hold the flashlight up at 7 feet or 6 feet or whatever, and walk away. You got to go far enough away. You can't just do, you can't walk 5 feet away. You got to walk very, very far. Eventually, that dude is going to be all the way at the other side of the field with a light, and that light is going to be it's going to be lighting up everything, including the underside of the Frisbee.
And here's the thing: the sun 1 degree above the horizon is 1,600,000 miles above the tangent of your feet. 2 degrees, you're talking 3 million. So just half a degree above the horizon, you're talking 800,000 miles above the tangent of your feet. So if you go up, that sun will follow you up. So if it's half a degree above the horizon and I go up to the moon, it's going to follow me. It's never going to change angles in your model. And so it's going to be shining directly straight at me, where I was from the ground all the way to the moon, yet still hitting the bottom of them clouds. Bro, that's impossible.
Hold on,
globe.
Ryan. Hold on real fast. Correct me. Okay, so real fast. Correct me if I'm wrong, right? But when you go up, right, in elevation, right, the horizon pretty much rises to eye level, more or less, right? You would agree with that, right?
Yeah.
Okay, so if I was to go under that cloud, like right where the cloud starts, and I look out to the horizon is going to be once again rising to eye level, right? Which means, from my point of view, the horizon is going to pretty much meet up with the bottom of that cloud that I'm under.
No, yeah. That's why I give examples of an airplane.
Okay, yeah. So here's the thing then. So are you saying now then, if I was to look at the sun would be pretty much not above the horizon, but actually
No. The cloud. Yeah, I see what you're saying, but let me respond.
So we would actually see this. So we would see the sun actually above the ground, because I mean,
yes,
that's we have never seen a picture like that where the sun is above the ground, where it looks like it's local, like it's actually right there.
You've
like
never not seen one, bro. But here's the thing: so the when you're talking about distance, when you're talking about like a few thousand feet distance or whatever, that offsets the clouds that you're looking way off in the distance. So in other words, I'm a little above the horizon and the cloud's only a couple degrees above the horizon. So you could argue that it's close to sitting on the horizon or whatever. But if you went to them clouds, that's like 50 miles ahead of you. So that's going to bring the sun up too. So that's kind of an offset. The height is kind of an offset, unless I'm trying to give examples in like an airplane and shit. That would be unfair. But as far as just being up a couple thousand feet or especially around sea level, but the sun is always local, bro. No matter where it's at, it shines locally, bro. You'll never find an example otherwise. The sun is observer dependent and is a local phenomenon.
Maybe I should draw this out because I'm trying to figure this out. Maybe I should just draw this out real fast, but because I've never seen a picture like this before.
It's a globe killer, bro. You never won't see one now that you've seen it.
Oh, hold on. Okay, so clouds. Yeah, go on with this, but I'm gonna real fast draw this.
Can't work with parallel rays, bro.
What, you have a picture that you think is a globe killer? Where?
Which one? I posted about half a dozen of them. I got tired of posting, bro. Just look at clouds at sunset.
Okay, what's your name right now? Are you still Brian?
The sun's always local, bub. Always.
Are you still local? Doesn't mean it.
Flat Earth tests, friends, Brian.
Yep, that's me.
Okay, flat Earth cats or aging flat cats.
No.
I'm just sharing my screen real quickly.
Flat Earth test.
In this context, local could be referred to, let's say, anything within 20,000 miles, 10,000 miles, within the range of how our human eye actually sees, within the actual real physics of where we live, not 93 million bajillion fabricated space miles.
Well, that's a bold statement.
Everybody who's
we know how. I mean, the sun. We know how the sun tracks upon the Earth. Like it, right? You can. It rises and sets in different regions, different continents. You know, in terms of its locality, it's local as it's cruising over the Earth. How exactly local, the distance? I mean, I don't think anyone would be able to get an absolute measurement. I mean, is the sun even physical? There's a lot of questions with that. Nonetheless, it seems to constellate itself within a local region that we view it as the sun and, you know, day and night cycle.
I can prove it's observer dependent too, and not just far away. Because like if I see a hot spot in a lake, like I'm at the one side of a lake and I'm looking right in the middle of it, 10 miles in the middle, there's a hot spot shining through the clouds. If I go on the other side of that lake, turning around, or if I had a mirror stretch 20 miles, looking back, the sun would be behind that mirror or behind the guy 20 miles. He wouldn't see that hot spot. It only
You mean a reflection?
Observer dependent, bro. I thought y'all knew this.
You mean a reflection?
Yeah, specular reflection.
I used a hot spot, like an actual hot spot.
There is no hot. I've never seen a hot spot. I've seen reflection.
I've never, bro. Your mind is shutting you out of reality, bro. You don't even know.
Not a hot spot,
bro. There's arguments against this. That's not one of them saying it never happened.
I've never seen a hot spot. I've seen reflections. Basically, I see the waves on the water reflecting a streak of light to me, and that is observer dependent. Yes, I've seen smooth lakes where they're mirror like, and I've seen a complete reflection where you can see the sun or the moon sitting on top of the water. But I've never seen a hot spot.
Moyak, you've never seen this one? I just posted in the. Hold on a second, Brian. Hold on. You've never seen this one I just posted from a high altitude balloon, the hot spot of the sun?
Trying not to kill myself.
It's in the
hot spot.
It's a reflection off of a body of water.
It's a local. No, this one I just posted is a local lighting effect. This is from high altitude. I'm just saying. I'm sure you've seen
that's
these.
A body of water reflecting the sun.
In New Mexico. Yeah.
Hold on a second. Hold on. Let's just, you guys. Everyone's talking over. I'm just asking Moyak. Have you seen? This is not the water. This is a cloud layer with a high altitude balloon showing a hot spot of the sun. Can you see that?
I see a reflection on a body of water.
That's not water. That's the clouds.
Well, I've seen that video before. That looks like I'm pretty sure that is water though, because if you actually look at the clouds, they're actually like the part. You know, there's like the actual space between some of the clouds. So there's like it's not just all clouds. Like there is like it is revealing some ocean or whatever. Or
you're suggesting that is a little lake or like an opening in the clouds there.
Something like that.
Yes,
I remember seeing this video before, and I remember saying like, "But there's no clouds there" or something like that. But right. Do you have the video, like the original video for that real fast? So I can just like check that again.
I think one of the things that's a dead giveaway with that, and I'm not sure about this video per se, but what I've seen with ones like this is that the reflection moves with you, where a hot spot will not move with you. A hot spot where you illuminate something, where the main beam of something is touching, stays fixed.
Yeah, specular reflection.
Does that look like you're up above the perspective atmosphere? Does that look like a parallel sun ray?
Perspective.
Shut up, Brian.
Hotspot proves the sun. That's gonna be a hotspot.
Yeah, I mean, I don't know if I agree with what you said, Moyak. I mean, because like when you watch like when you look at the water and you get that line of reflection from the sun to you. That's like a personal thing to you, even though it is the sun reflecting off the water, and everyone else will have one too. So if there was a hot spot, I could see it working a similar way, depending on your position.
Like I said, well, hot spots are usually where the photons are reflecting so heavily off of an area, like when you take a flashlight, hold it close to the ground, and you can see where the beam is actually touching. That does not move. You can walk all around it. It'll appear on the same square on the chest.
Reflection doesn't have to be off of
the reflection that you'll get on the chessboard as you get to an oblique angle, that will move along with you as you move. But they're two different things. A hot spot and a reflection are very different.
Reflection doesn't have to be off of water either. It's just more noticeable off of water. Light is going to reflect off of everything. That's what gives us our light attenuation, whatever. You see a tree or something that's highly reflective on the shore that are the same size and the same height, you're going to see the white water tower more than you're going to see the green tree that absorbs some light or doesn't reflect the light as much.
I don't know if I've got you turned down or what. I can't hear you, and I can't fix it right now.
Might be me.
No, you were fine. He's got you turned down, probably.
Yeah, you're loud and clear. But yeah, I mean, the sun is obviously local and observer dependent. Like I used the example of the sun beaming through the clouds, making the hot spot, whatever reflection, whatever you want to call it, it's beaming through the clouds, like breaking the clouds. But if you go across the lake and you turn around to try and see it, the sun's at your back. You're not going to see that sun beaming through the clouds. It's observer dependent.
I agree.
So wherever it's at, like I posted to where it's in the mountains with diverging shadows. That's not a parallel ray, bro. And with the sun above the horizon and hitting the bottom of clouds, it's wherever it's at. It's going to shine all around it. Looks like it's at. The math kills the heliocentric model, but still, unless you just claim perspective, which is fine. But if the sun's sitting above the horizon, it's going to shine on shit according to where it looks like it's at. Period. That's just the way the sun works.
I don't know how to describe it any better than I did, so let's bow out with this.
Right, I'm looking for slides right up on that dog cam. Because that was excellent. Because there is a body of water there. I just can't remember which body of water it is.
I mean, I'm watching the specular reflection of the sun chase me along across the bridge right now.
You want me to call the cops?
It's chasing me, man. It's catching up.
So you're saying somebody on the ground can see that reflection also. They can see the hot spot on that body of water.
No, I'm saying that you can see hot spots. Reflections are observer dependent. Hot spots are not observer.
That's not a body of water, man. Watch it from the beginning on the way up. That's not a body of water. Y'all are tripping.
If it follows the balloon, it's a body of water. If it goes away, when your angle is no longer able to see the sun in line, it will go away.
Anyways, Brian, it turns out that all these arguments suck that you brought up, and you said that all our arguments just prove of.
I was just saying, the argument y'all threw at us wound up killing the globe, bro. That's not the only one, but I'm just saying.
Well, Moyak just proved that your arguments are actually the ones that suck.
Or you threw this spherical excess argument at us, and now we have measurements of a non-spherical Earth.
Is that right? What's the shape of the Earth then, based on those measurements?
It's inconclusive. The whole thing together is inconclusive, but we do have measurements of non-spherical Earth, right?
And how come, Jim? For years we've heard of the spherical excess, never heard of the ones that were minus 180. Seems like they would have told us and explained how that was a curve there too.
Those are expected.
We just talked about that today.
That problem goes away when you increase the distances.
Can I just ask a simple question about all of that? If someone's claiming to measure spherical excess with the satellites up on mountaintops, why wouldn't they just take the measurements, report them, and say, hey, I measured spherical excess? Now, I get that you might do it multiple times. You might want to, if you get several that are close, there's, as an extra, you could do an average if you wanted. I get that there's refraction claims, which is partly why this is a poor way to do this and not an accurate way to do it. But that whole document is so convoluted with so many corrections and so many, alterations. And several of them did come out at 180, which would be a planar measurement anyways. But my main question is, why not just take the measurements and show them and show spherical excess? Because without that, you guys don't have a measurement of spherical excess to this day.
The measurements that you have, the excess in those measurements is greater than the magnitude of all of the corrections and error bars present in the document.
That when you get to the long ones, that's true. Some of the short ones, it's within the error bar or whatever you call it, within the corrections. But when you get to the long ones, it just disappears.
Moyak.
That didn't really answer what I was asking, though.
It's not even about the distances, because even the short-range ones in the same net, you look at the other ones that are that same distance in the same center point, and those triangles average to greater than 180 in each one. The ones that are left than 180 are less in magnitude than the ones that are greater than 180.
So the ones that came out minus 180, like below 180, just more error. Same distance.
You understand
right?
the tendency for bias there, right, Doofus? Just to sway it in a certain way. It's a mess, dude. This is a mess. If this is the best you guys have for spherical access, it's absolutely terrible.
Again, the corrections and error bars for every measurement on there are larger or are smaller than the amount of excess measured.
Yeah, we heard you the first time, and then we asked you 2 questions. I asked you one, and Gio asked you one, or made a statement that it was a mess.
The excess is measured in the 5th decimal place to match the radius, and the error bar is way a couple factors above that. You're wrong.
No, Brian. All of the error bars in the entire document, you can look at all of them, are usually within 1 arc second or less. All of the corrections that need to be made are within 2 or 3 arc seconds or less.
The
Those
instrument
corrections
itself
and
is
errors,
an arc second.
all summed up together, are far less than 1 arc minute that is typically measured on those long-range triangles.
Bro, the corrections are way more than that. Look at some of the measurements are freaking ridiculous. There's some scattered in there that I could tell they
How much
whip
more?
the shit out of them. But the fucking instrument itself is a fucking full arc second theodolite, bro. You are wrong.
Yeah, and that's part of the error mentioned was 1 arc second or less. That's included in the instrument. Now what else? We've got more than an arc minute worth of measurement of excess in plenty of those triangles.
The
That didn't come
refraction is
from the error.
0.65.
That didn't come from the error, because if that was the case, then there would be some that are an arc minute below 180.
So you agree that if I take all the measurements and one that's farthest off, let's say out of all the dozen, the one that's farthest off, the angle to that, okay, has to be the error bar for all the other ones to fit within the error. So you have to say, you're saying that every worst measurement out of the averages is less than the spherical excess. That makes you retarded, bro. Sorry.
Okay.
Okay.
Just saying that you think that error is one way, even though it's actually something else, doesn't change what error actually is.
Well, you're saying that the error margin, like within the tool and the human and the measurement itself over distance, the greater the distance, the less the error margin it's going to be.
I didn't say that. Nowhere did I say that.
Mm-hmm.
You keep doing that, Rakia. You've done it several times today. It's fucking
What?
tiring.
Ask a simple
It's
question.
so fucking tiring. Every fucking time you do it.
Dude.
Because I know I don't say these things, and you tell me I say these things.
I didn't tell you anything. I asked you a question.
Yeah, you fucking did. You asked.
No,
well,
I did
of
not.
course you-
I asked a
it
very
must be
pointed
less
question.
if the distance is greater.
Trying
Nobody
to
here said that
understand.
shit. Nobody
Why
said
is
it.
this guy allowed to
Yeah,
be
nobody
this
said it,
angry and pissed
Rakia.
at me the whole time?
Stop doing it. It's been 6 or 7
So
fucking
I'll
times
ask
today.
anybody else because Doofus obviously can't answer. Did anybody else hear my question? I'm
I
trying to
fucking
learn
answered your
this.
question.
Is there a mod here?
I'm a mod.
I mean, I'm being serious.
Yeah, nobody here said it was less.
I didn't
error
ask you.
with
Yeah, I'm
Matter of
here.
fact,
I'm here.
I know,
What's up?
because you keep asking the same
What's up? Why
lie
are you
every
yelling, Doofus?
fucking time.
Doofus is
Relax.
definitely screaming. Yeah, I don't know what happened, but I muted him because he's screaming, and I don't know what he's targeting.
He is
and
upsetting
screaming
him,
at.
dude.
I asked a question. He didn't want to, like, he was aggravated because he thinks I'm asking it to get at him or something. I asked a question that I really wanted answered, and I even said, okay, Doofus, fine. I'm not asking you. I'm asking someone else. So if anyone else wants to answer it, go ahead.
I know, but I think it's because it's like a loaded question that implies
not
that
a loaded question.
That he said something that he didn't say.
It's not a loaded question. It's a very simple question. Does anybody want to answer it? I'm fine if you don't.
Nobody here said that the error margins get less as the distance increases. Correct yourself, Rock.
Correct my question?
The measurements become more apparent, and the error margin doesn't rise at the same rate.
Let me explain something real quick. if I have an arm that's bionic, okay, and it's the same power every time. So now I want to do an average, okay, and I throw a ball 10 times, but it lands in different spots each time. But I want to get an average, but it lands in different spots each time because of the wind, because of whatever the fuck's going on, but it lands in a different spot. Okay, the margin of error. Let's say I did 12. I threw up the highest and I threw out the lowest. Now out of the 10, my margin of error has to be the one farthest from the fucking average. Excuse my language. Or else it's not a true margin of error, because for every other measurement to fit within that margin of error, then it can't be less than the one that's farthest from the central average point. It's common sense, dude.
Okay, Brian, let me ask you something about that. Now use the same optical tool and move away 10 miles. Are you going to get a very accurate measurement on your arm?
Do I got to answer that? Hell no, dude. That's
And is the angle going to change?
I don't even got to answer that, bro. It's
So then
common sense.
perspective may be throwing off the measurement too, right? Because like
That's
when
what I
something
was
goes
thinking,
away,
man.
yeah, when something goes away from you and the angle changes, like an airplane, so it disappears at a point because of the angle. It just gets so skinny you can't see it anymore, basically because of
Right.
the
And
angle,
then,
right?
and then they say
Out
distance
of
doesn't matter. They say distance doesn't matter, but that's another scenario where distance has to be calculated in. Yeah. So they're
distance is everything. That's why there's guys on here cussing people out and getting so angry and talking about how distance doesn't have anything to do with it. What a shocker.
Distance does not change the error in angle measurements just due to distance.
What's at the station B that you're shooting at? That's giving you your zenith. What is that again?
Total station.
No. You have the total station.
Thank you.
You're at A. You're shooting towards station B. What's there?
a target distance.
What's at that target distance? Mountaintop to mountaintop's 15 miles. What did they put there?
At the target, they put like a mirror sort of thing.
And you're measuring different. So do they raise and lower that mirror to give you the different angles?
You just look at the horizontal component of the angle to the mirror.
So the reflector is giving you a zenith angle or a plumb straight up and down, and you're measuring that imaginary line, Kosho?
No.
Nobody said
Yeah.
that.
Okay, I'm asking a question to Kosho. Very pointed question. So no, they're not measuring a zenith imaginary line that's in the sky. They're measuring a reflector. So my question before was, do they raise and lower that reflector to give you the different angle measurements?
No. Let's say there's a mirror somewhere and it's a different elevation than you, and you don't have a theodolite or a total station, but you have this thing that has a telescope on it, and it's got a gear that rotates it upwards and a gear that rotates it horizontally, and you can get down to the arc second for each of those angles. You point it at that object, and the component of the gear that represents the horizontal component, you just measure the angle of how much you had to twist that.
Gotcha. That's one measurement, right, Kosho?
That'd be one measurement.
Okay, so then what do you do to get the second measurement from the same A to B, station A to point B? What do you do to get the different angle measurement?
Oh, you just do this.
Take a deep breath,
you
and
just
look back through.
do the same thing again.
To the same height? This would be the same angle, right, Kosho?
You'd expect it to be, but in practice, I don't think you get the exact same value.
I don't think you know what you're talking about.
Okay, well,
That's
just
why
go
I
with
asked.
it. They do it
So
six
they-
times. It says in the document they do it 6 times to take the average. So.
So from the same setup, same station, same height, same distance from A to B with the same reflector at B, they don't move anything, but they get different angle measurements, Kosho?
Slightly, but they might not. They might get the exact same and take the average of that and end up getting the same value.
And that's spherical excess?
So what are you talking about?
I'm asking you. We're going through spherical excess. I'm seeing if you know how they do it.
Oh, you were asking me about pointing the thing at the other thing.
Yeah, different angle measurements. spherical excess, right?
Yeah, you're talking about from the same station, at this pointing at
That
the
was
same other
very
station.
clear.
Yeah, from the same station pointing to the same other station, you're just going to take it, multiple times to get different
To the
measurements.
same height, same reflector.
Same reflector, yeah.
What you called a
Do
mirror.
they reset the equipment each time?
Yeah, they'll reset the equipment. They'll
That's why you get the differences.
right.
Setup.
You get the
They
difference.
don't just blink and then look twice.
Well, they also have refraction. Hold on, even if you did leave it set up and didn't touch it or didn't move it, there's still refraction at play here. So I know you
Not
guys said for
really.
years. I know you guys said for years that there was no refraction because it was left to right, but it comes to find out there actually is refraction involved with this measurement.
It's involved. It's minuscule.
It's
Yeah,
very
sure.
little,
That's
but
the
they wanted
claim.
this to be. They wanted this to be a
That's
perfect.
the claim is that it's minuscule. I know, but now we're wondering where the actual position is.
They wanted this to be a perfect measurement, so they wanted to account for every possible thing that. So they never would ever have to. So they could use this, for as long as they needed to, and there would never be any question of its accuracy. So they accounted for things that were even as minuscule as refraction. Left to right.
Like being too close. Like being too close to get an accurate measurement. You need to move further away.
Nobody made that claim.
I'm making that claim.
A lot of
Yeah,
people have made that
he
claim.
said nobody's made that claim.
Let's clear up some of the myths that they haven't claimed. Okay, so we're not claiming as Globers. Okay, I'm not a Glober, but Globers, you're not claiming that refraction. That there's no refraction with the azimuthal measurements. Okay, can we agree on that? There is refraction in y'all's measurements. Can we agree on that?
Yeah, nobody
Quit
ever
saying
said there's
that?
never refraction there.
Okay,
That's not the case. There's not consistent refraction there.
No, that's
and
not.
if you're doing a measurement like this,
I made a video.
if you're doing a measurement like this, you're going to account for every single minuscule thing.
Okay, I made a video where David Johnston says that this is why it's his favorite globe proof because there's no refraction. And then I put in the next video McToon specifically saying that there's no refraction with the azimuthal measurements. Okay,
Dude, all the Globers have said this for years, bro. They've been telling it
I've
us
said
for
it,
years.
but
There's
it's
no refraction.
So
I
yeah,
can
I've said
pull up
it.
every one of these guys. If Jem saved his live stream, I'd be able to pull up every one of these guys saying it.
Whoopee. We don't care.
Times.
Why don't you toot your horn a little bit more instead of
Hold on, I'm just saying. Hold on, so we can quit making that claim. And also, when and you don't say they said this.
It's not significant.
Every triangle measures out to more than 180 degrees. We can quit saying that too, right? The Globers can quit making that claim that every fucking triangle adds up to more than 180 degrees.
Go one further, Brian. I'd be shocked. I would be astounded if any surveyor I hired set up and shot over, did any measurement more than a half a mile and came up with a triangle that wasn't 180 degrees.
Well, there's a lot of
over half a mile. You're right.
Line of sight will always give you 180, bro. There's no getting around it.
Yeah, if you take the actual angular distance between them, but if you take the horizontal angle between them, which is what's done in this measurement, then you get something different, right?
Yeah, it really depends on, how you're going about.
If you want to assume that orientations change and all shit, then you say that the ground underneath is doing the curve. That's a model. Okay, good. That's a model. Make me a good model. I'm good with that. Give me GPS off that model, whatever. But it's only a model. In real life, line of sight is always going to give you 180. There's 0 ways around.
Brian, it offends me because it feels like you're not listening.
Yeah, you're not. I've mentioned it to him like 6 or 7 times today. Brian, the angles are not being measured in the same plane as the 3 points. Again, Brian, the angles that are being measured are not being measured in the same plane as the 3 points. You would have a point if those were the angles being measured. Those are not the
That's
angles.
an assumption, bud. Okay, I've
Okay.
already. It took
Hey,
me
hold
and
on.
Jeremy 2 hours.
Hold on, Brian. Hold on,
Brian.
Brian. Brian, hold on. Okay, so Kosho.
Oh, his internet.
Let's go with it.
We didn't hear
Yeah,
any
we
of it.
agree.
Repeat.
We agree, Jeremy.
Described how the
Yeah,
measurements.
we agree.
made.
We agree, man. All right. Anyway, no, I was fucking around.
They have a mirror. They're citing to this mirror. So in order for them to not be doing it on the same plane, they'd have to raise and lower them and change the mirror height, right? Can you guys?
No.
You guys
No,
hear me now?
Jeremy, the point that you're at and the other 2 points are not necessarily at the same altitude as you, first of all. And second of all, the angle that's being measured is in your local horizontal plane. The 2 points in the distance are almost certainly not in your local horizontal plane.
You got that, Jeremy?
Gentlemen.
Go ahead, Jeremy. You got what he said?
It took Jeremy's robot, and it took me and Jeremy 2
I
hours.
can't. I'm in a bad spot.
It took me and Jeremy 2 hours to explain to Rumpus and Zanuck, and we drew it out. They finally conceded that, yeah, line of sight. So if I'm at Yellowstone Park, standing on the ground, and I draw one line to Polaris and then another line to the top of the Statue of Liberty, it don't matter how you twist me. It don't matter how you turn me. If I'm
Brian,
only
try
one
listening for a second, dude.
if I'm one person observing two of the
saying,
points,
dude.
I'm going to measure 180 no matter what you say,
Brian,
unless
you're
you
not
make
talking about anything that we're talking
assumptions.
about.
Hold on. Well,
Thanks
hold
for
on,
letting me
hold on.
finish, bro.
Well, hold on, Coach.
Brian, you don't know how this works, man.
Well,
You're,
hold
you're,
on.
bringing up, you're bringing up a line of
why are
sight
you
like you're
interrupting?
taking angles from 2 different positions, dude. That's not what's happening.
Wait, Coach.
Yeah, but why did you interrupt him, dude? Like
I
3
thought it was
times.
a waste of time. What are you saying?
Yeah, because it's always this line of sight
That's
triangle.
a good excuse.
Well, hold on.
Right.
Well, that's my reason, yeah.
Go, guys.
It's
hold
the
on.
same. It's the same problem.
I'm
Brian.
going to interrupt
That's
Rufus
all day
here.
long.
Definitely a waste of time here. Just interrupt due to Kosho's logic.
All right, guys, for real. Anyway, so check this out, right? Maybe we should do a visual or something, right? As you know, I do Blender, all right? I can easily show you this whole, the plane
Bet
thing
you
or
already
whatever, I could show this if you guys would like.
Bacon
Not
has
without
something already
assuming an
prepared.
orientation change, bro.
No, but dude, it's as simple as I said it before, dude. If you have a telescope and there's 2 objects, like the Statue of Liberty and Polaris, as you said, that's perfect. Let's say that you're at the Empire State Building, and then you point one at the Statue of Liberty and one at Polaris, the telescope.
3 coplanar points, pal.
Well, hold on, Brian, because this is the important part. Your telescope, you point it at Polaris, and you point at the Statue of Liberty. You're going to get an angular distance between them. That's true. But let's say instead on that telescope, you have 2 gears, one that rotates it upwards and one that rotates it left to right. And so you do the same thing. You point it at Polaris and you point it at the Statue of Liberty, but you don't use the upward gear. You only use the horizontal gear as your measurement. So there's only one. They're only measuring the horizontal angle.
Bro, I can draw an angle with spherical excess on a ball. It doesn't matter if it's line of sight. It's 3 coplanar points, no matter how you turn it. If you are one of the observers, then the other 2 points. The only way to give spherical excess is to assume an orientation change. What's so complicated about that, bro? It's 3 coplanar points.
Right. You keep asking what's so complicated. Brian, I need to ask you, what is so complicated about the fact that the angles being measured are not in the same plane as the 3 points? What is
I got
complicated?
it. I got it, Brian. Do you get it?
Bro, if it's line of sight and you are one of the observers, then you have 3 coplanar points, bro.
Right. Try
But they don't
answering the
measure
question I asked
coplanar.
you, Brian.
Bro,
Brian,
why
can you
don't
answer
you?
the
Why can't
question I
y'all
asked you or
concede
not?
to this, bro?
You guys,
Brian,
To get
Brian,
to
can you answer? Hold on a second. I need an
Now-
answer to the question that I asked Brian.
you interrupted.
You need a massage is
You
what
guys
you need, dude. You
can't
don't need an answer.
right now.
No, you're roboting.
You sound good, man.
Why can't y'all be honest and say that if I assume orientation change, then I get spherical excess? Without the assumption of an orientation change, you have 3 coplanar points.
Brian.
Why can't you just be honest?
Because you don't need to
and
do
admit
that, Brian. Check it out, dude. Let's say you're on a flat plane. You're on a flat plane with me. We're on a flat plane. And you do exactly what I said with a telescope. You point it at one place and you point it at the other place, and you take only the horizontal component. It turns out that if you're on a flat plane and you're doing this measurement, the spherical axis, and you take only the horizontal component because the verticals are parallel, you're gonna get you're gonna get the same measurement as if you just took the entire angle. Okay, so
What's that got to do with
so you don't there's not a distinction. You're not fluffing any data or putting it in like a spherical axis by taking only the horizontal. The horizontal is it only causes there to be excess is if you're on a sphere and you're doing it.
or at the
So
very
you're not
least,
going to be honest
they're not parallel.
and admit that if I'm one observer looking at two other locations, that's a coplanar triangle. Unless I
Not measuring angles in
assume an orientation location. Can't y'all be honest and
You just don't listen, man. You just I literally.
Well,
I'll say
if you
something to
assume
you, don't
coplanar,
listen to what
then
I'm
your
saying.
numbers come up wrong.
Right. Brian, if you have 3 points and you're measuring angles in a horizontal plane, it is not coplanar with those 3 points at each of those points. You
put
have
3 toothpicks on a globe.
God damn it, Brian.
He almost let you get 3 words into that.
Just wait a second, Brian. If you have 3 points and you're measuring angles in the horizontal planes at each of the 3 points, if all of the verticals are parallel, then you will get 180 degrees, even though the angles you've measured are not coplanar with the 3 points, are not in planes that are in the plane of the 3 points. However, if you get something else other than 180 degrees, then those verticals are not parallel.
Fair, dude. Okay, now put 3 toothpicks on a globe, and and then tie a string around all 3 toothpicks, and then measure the angles from your one orientation.
Why would that be?
Unless I assume an orientation, I'm never going to get X. I'm always going to get 180. Why can't you be honest and admit that?
Brian,
We actually
I've
do
told you
admit that.
several times. I've told you several times today. The triangle that is line of sight is going to have 180 degrees inside of it. The reason that we're having this discussion is that the angles are not those angles. We're not measuring those angles, Brian. That triangle that you're creating with those toothpicks, the angles you're measuring are not those angles. You're measuring angles in the horizontal planes at each of the 3 points.
What plane do you think I'm talking about? Kosho might have confused you with all the with the vertical. We're talking about azimuthal angles, bro. Now,
Yep.
without
Azimuth angles
assuming
are
an
all
orientation change, at least you agreed the line of sight is going to be 180. I'll stop.
Interesting.
Did he cut out?
I think so.
Oh shit! What was that?
I think the problem comes in when you do these measurements and you find out that your assumptions are not right.
No,
Assuming it's flat, they all straight through.
No, I said I'll back up. He agreed that line of sight's 180. Okay, without assuming an orientation
didn't.
change, it's always 180.
You don't
Measure
listen.
it, it's
Hold
180.
on.
Yeah, he did. He did say that line of sight's 180, pal.
Right. The triangle that you make with line of sight, the internal angles of that triangle will be 180 degrees. However, the angles that they are measuring are azimuths, or between 2 azimuths. Azimuths are in a horizontal plane, so that the angle that's being measured between those 2 azimuths is not in the same plane as those 3 points. Do you get it now, Brian?
Fine, bro. That's what I said. If you assume orientation changes, then you can try to put in spherical excess. But that is necessitating a radius. Hold on. That necessitates a latitude, so you can get the radius of whatever reference spheroid or ellipsoid you're referring to. There's no fucking way around it.
Well, assume a flat plane and
There's
see how
no-
your numbers work out geometrically.
Hold on a second. There's no assumption necessary there for orientation change. We're measuring the orientation change. If the measurement was 180 degrees, the verticals at all 3 points would be parallel with one another.
So they're not line of sight
The
then, right?
measurement being greater than 180, or the sum being greater than 180 degrees, shows that the verticals at those 3 locations are definitely not parallel.
Okay,
with
so
one another.
not line of sight. Fine, not line of sight. Okay,
Dude.
here's my thing.
Brian,
If
you're not
we're doing it if we're doing it on a flat Earth, I would think that the shorter the measurement, the closer to 180 it would be, maybe even a little under.
On a
And then
flat plane, it would always be 180.
the further my measurements might start getting even more off. So I would just make these little arc second or arc minute corrections to give them all 180, bro, and you'd have a few feet difference over fucking these mountains and shit, bro. Y'all are delusional.
Brian, on a
if you
flat
think this
plane, it
proves
will
the
always
globe.
be 180, okay? Just pay attention. Just listen. If you have the 3 toothpicks in orange and put 3 toothpicks in a slice of pizza, okay? And you are measuring only the horizontal component of the angle between points that you can see from the other points, okay? So on the pizza, they're always going to be 180 degrees, even though you're only taking the horizontal component, okay? On the orange, you take only the horizontal component, and there's going to be excess, even though it's the same test. You're not adding anything in there. There's nothing being added in for that to take place. When you take the horizontal component, you're measuring the deviation from the verticals, which is the excess.
What deviation, bro?
If there's
Assumed deviation.
No,
Be honest. 1 second, dude.
Yeah, if there's no excess, then there's no deviation. The measurement still works on a flat plane as well.
Bro, there's no excess without assumed orientation change.
No,
Why can't
there's
you be
excess.
honest?
There's excess in the measurement. Whatever you want to say, there seems to be typically be excess in the measurement. Now, if that's the case, you've now got to figure out why that excess is happening.
Well, unless there's
said.
not excess, unless there's negative excess, like excess in the opposite way of excess. Unless that. Then what do you assume? The measurement's too short to be accurate?
Over the long distance measurements, every error you account for, you get all the corrections.
Right, I
and
understand.
there still is apparently a excess. When you get down to smaller measurements, you have to be much more precise to get the answer. And it's going to fall into the 5th decimal place and stuff. But going to a nice long distance,
The margin
you
of
got
error,
your globe.
it does
Yeah,
fall
well,
in
you
the
can
fifth
throw in
decimal
all
place.
your calculations. That's the measurements are better, right? Like, it just fits right.
The margin of error is magnitudes greater than 5th decimal place. Every single measurement.
Yes. But the error, it was up to, let's say, I forget which one it was, because I think it was the 19th measurement. You look at that one, and that one is, maybe it was 16 to 9. And those were over exceptionally long distances, and they had like 45 arc minute excess. The corrections were in like the 1 arc second range, 1.5. No way to fix that. You can get rid of those corrections, throw them away, and you're still going to be 44 or 43 degrees a minute off.
But so line of sight always going to be 180, right? Once the orientation change is assumed, then you could start putting in averages and then calculating the distance, even though they're not measured. And then you got a model. Okay, that's what you get. Can we all agree that fucking survey does not prove a globe?
You can actually eliminate the model entirely, especially over the long distance. And you're going to have to account for 45 arc minutes, I think, of spherical excess.
Bro, we have demolished you over the course of the last week, showing you that
that's wonderful.
Many fucking margins of error and corrections and all this fucking vague bullshit. It's, dude, if you don't understand yet, bro, I can't help you.
Look up the big measurements and show me where you could correct for it, get it to go away.
There are no raw
Take
data.
out all
So
the
quit
corrections.
saying that there's no refraction correction. Quit saying that every triangle adds up to more than
Eliminate
180.
all of that.
Quit saying that
Eliminate all that. Don't use any of it.
You got to interrupt me so I can quit saying all this fictitious shit y'all been claiming over the last couple of years. Just quit claiming it.
You can now answer the question: with all those corrections eliminated, do you still end up with spherical excess? It doesn't matter. You can totally not address the surface of the Earth, and you're now going to say, how wide is this angle? When I set up my vertical at each of these locations, and I measure my azimuth, and I get spherical excess. Why the fuck do I have that spherical excess?
Watch your mouth.
The spherical excess is in the 5th decimal place to match a radius anywhere near 3959. The margin of error is in at least the seconds, much less the ones in the device itself is in the minutes. The margin of error is magnitudes greater than your spherical excess, bro. You're not being honest, or you're ignorant.
Close range.
You're saying that I've got a 45-minute margin of error on this measurement?
I'm telling you that the spherical excess is in the 5th decimal place to match a radius of 3959.
What?
45 arc minutes, bitch.
Oh damn.
Oh my God, that's a fifth decimal place to you?
No, you're saying something that is factually incorrect, and you keep repeating it over and
Look
over
at
and over
McToon's
and
chart.
over and over and over.
Look at McToon's chart, bro. It's 0.000. That's the excess to get 39.59, bro. Go do the math.
I don't think you know what you're talking about.
Savage.
Phone's hiding. Oh, wait, look at those clouds underlit. That shit.
Underlit.
It's about that time of day for you.
Sunset. Kind of. Oh, wait, yeah, those look there. Probably about 10, 15 miles down towards the sunset.
I'm glad you were able to get away from that sunspot. I was worried.
Yeah, you lost him. You Good.
I'm living on my boat right now.
Who do you think would win in a race, you or Rakia in a boat?
Rakia? Oh, probably Rakia. Especially if it was endurance.
It's not about
But I think
speed.
he's got me on top speed also.
It's about the motion of the ocean, not the speed, though.
But I definitely won't be able to go as many miles as he.
Oh, well, that's not good then.
I probably can go 150 to 100 miles if I open it wide open. Oh, even less than that. Shit. I probably get like 70 miles open.
Hey,
Do
Rakia,
200 gallons.
if you're here, Rakia, actually, I had somebody suggested a good test for you and your radar thing. I thought was interesting. I forgot what it was now.
Rip.
Hold on.
It's pretty sad.
I think it's funny though when they talk about how perspective works and stuff, and talk about the flashlight being above a surface. When I move it the first foot, light moves 45 degrees because it was like right on top of the hatch that I'm going over, or the roof. The next one it's 20 degrees. Next one it's 10. Next one it's 2. Then it goes down to next 100 feet will be 1 degree. And the next 1,000 feet will be somewhere between 0 and 1. But it never goes negative.
Right.
Interesting.
Yeah, my computer froze up when I did it, but I showed in Blender how it just doesn't.
Sure, it did. You showed it, but you can't show it.
Right? It's crazy to be like that.
Promise.
I'm bored right now. All right. Topic. Come on, bring up a topic. Anything. Why did Brian die? We had a whole thing with the angles. I even set up a fucking 3D thing too for it, but he wanted to refuse my 3D model. So yeah. But anyway, yeah. I think the underlit cloud argument is a bit weird because in the pictures that he sent, like there was also like clouds being overlit, quote unquote overlit anyway. Really it's just like the more transparency parts of the clouds like kind of glowing. So like that was at least in that image that in one of the images he sent, it was like just doing that. It was more like an outline almost, and that's once again I think it's more of the more transparency parts of the clouds. So I do wonder how much of that is happening in that one picture he sent, but also I also wonder the angle of the cloud and whatnot. Because like I said earlier, there was an angle thing that that could play a part in that because I mean I don't know how much a cloud may angle, but clouds are rounded, kind of at the edges and whatnot. So those rounded parts are angled obviously, and so those can catch the light, I imagine. So that's how I see it.
I concur.
And I
didn't
also
see any of the brilliant, wonderful underlit clouds that we see that are underlit clouds. Shining through the edge of a cloud doesn't
I posted half a dozen of them, man. I mean, if y'all,
I know, and every one of them
might be the worst. This might be the worst. I even showed the mountains, the shadows from the mountains in the distance diverging, bro. This might be the most denial I've ever seen in this room.
Okay, that's cute of you to say.
Mm-hmm.
Well, no, with the cloud. Okay, well, real fast. The one with the clouds, with the mountain, or whatever. I mean, okay. To be fair, all right. If I'm going to be 100% fair, I don't even know where the sun is actually in that picture. Like you kind of circled it with blue, but like it's kind of just really bright there. If I'm going to be really honest, like I don't really know what's going on. So that one's a little bit tricky. But also, if I'm going to play, technically it wouldn't be devil's advocate, it'd be on my own side. But if I'm going to play reverse devil's advocate, which is fucking stupid. Those clouds are also once again kind of bumpy at the bottom. So I do imagine
That's like the most redundant position.
I know it's stupid, but anyway, the point is those clouds. It's not perfectly flat at the bottom of those clouds, so the angled parts can technically catch the light. That is possible. It really depends on that. Yeah, the angle. I think to some extent, because I guess the clouds next to it though. But if it's like a ceiling though, then that's a tricky one. Depends how much cloud there is. If there's not too much cloud ahead, then I think there would be an angle to it. But if there's just like a whole ceiling of clouds, then yeah, I would agree. I mean like a real ceiling of clouds where it just keeps on going, because then I don't think there would be an angle. But if it
that looks underlit, man. The sun's completely gone.
That one's a tricky one.
Actually, did I post it? Yeah.
I am thinking of scenarios where it would be okay, because it's only not okay if the clouds form a ceiling that when you're up at the clouds, right? Like let's say you're level with the clouds, right? Where that meets the horizon, because at that point, yeah, there's no way the sun could hit those clouds, right? But if it's not like a full-on ceiling where it's like there's a lot of clouds, but like they don't like reach the horizon, like if they end before they reach the horizon, then yeah, there'll be enough sky for the sun to be visible. So I don't know. I feel like this. I get what you're getting at, Brian, but there are scenarios where this works, and so we just have to figure out if these are the scenarios. And I'm pretty sure I didn't make any sense when I said that, but I'm just saying it makes sense. I do think it's possible.
Earth's a globe, but you can keep claiming it's not.
Shadows diverging.
You watch grown-ass adults play What If, but pretend. I bet it's the wind.
You know what?
Yeah, Carnivore's picture's pretty damning. Every time I look at it, I want to say damn.
I wonder if we measure the distance between the posts and the distance between the shadows at the end of the shadows, what the difference would be.
That's a good point. That's a good point.
Anybody not notice that the land is different heights?
I did notice
Is it on a hill?
There you go. Yep, they got a little hill there, throwing the whole thing off.
So then how come the shadow's still in a straight line?
Maybe that's what's causing the straight line.
Above the top of the hill.
Then the shadow wouldn't be a straight line. It'd be all wonky.
It is. Look at it.
It's not. It's in a
Look at
straight
it.
line.
It's not a straight line. Look at it very carefully. Either one of those are
See it.
straight lines.
It
Either
is.
one of those lines are straight.
Yeah, it is.
I mean, for all intents and
Okay,
purposes.
so you're literally looking at two lines, right, that are not straight and saying they are. Okay.
You're literally looking at two straight lines and saying that they're not straight.
So anybody with eyes can see.
I mean, listen. For all intents and purposes, they're straight. Like, if you want to get like technical, if you zoom in, yeah, sure. There's some, terrain that the shadow's going over, so there, maybe a little bit of bumps, but for all intents and
Makes
purposes,
it not a straight line.
But for
There you
all
go.
intents and purposes, it's a straight line.
Why don't you go ahead and tell me it's not a line because it's not one-dimensional as well?
Yeah, exactly. It's like
They don't do for all intents and purposes,
Yeah, because if they're gonna play this,
unless it's their measurement.
I thought I heard you in here, Harp. What up, man?
Hey, what's up, dude?
Right on, man.
I think this might be the first time I ever opened my mic over here.
Yeah, dude. I'm glad you're participating, man. It's a cool server, dude. Hope you come in more.
Yeah.
So what are we
Gotta
proving?
get my, I gotta get my dinghy up here, man.
Arguing over some stupid lines, but what are we actually trying to prove there?
Because they appear to be not parallel from one perspective, but in reality they are parallel.
Oh, so you're using perspective. Okay.
Well, perspective, the way that it's expressed in reality, not the magic perspective where the ground magically absorbs things.
It absorbs things like
the ground magically. Wow.
Yeah, it goes.
Nope. I'm gonna have to say, Dicela, you already left in it. No, I may not be here too much. I mean, why?
Ground sucking perspective.
Yeah. So obviously, you've never seen flat surfaces absorb, things from the bottom up, or are you denying that actually happens?
I've seen it done in a reasonable test.
We showed you just by opening garage doors. We've showed you with actual atmosphere it happening right in front of your face. We've demonstrated it with magnification. We've demonstrated it with just cooler air. We've showed it over and over.
Cooler
and they
air?
just act like they've never even seen it. Thanks for interrupting, bro. I was almost
You
done.
mean? Oh, well, that's okay. You do it constantly anyway. Who the fuck are you to talk about interrupting?
Oh
shit! So what did you demonstrate again?
What's about to get fucked?
He has. They open up a garage door.
Can you guys hear me?
Yes.
Yeah, I can.
Yeah, Jeremy.
You guys are off the spherical thing already. I wanted to touch on that real quick. If Coach told us how they're sighting them up, but if you guys are on to something else now, it can wait.
I was just wondering what.
So you had to interrupt to say that? I thought you were going to do some moderation. Get out of here, John.
Yeah, stop interrupting, man. What do you want? You complained last time Brian interrupted, and then you interrupt. Just stop interrupting.
I yielded.
Please. Okay. Thank you.
Unlike Brian, who doesn't yield.
We've demonstrated what again?
Don't know. Brian wanted to say something and then
over and over. I know. I just heard somebody over and over in the driveway where what were we demonstrating? Things coming up over a curve or something? Or I don't know what.
Oh, right. What he did was, or I don't know if it's Brian per se, but on a cold winter's day, they take a garage and they set up an object by the garage door, and then they open the garage door and let the 30-degree outside air come in with so probably like a 30-degree delta in temperature. Same as using butane.
Pretty much.
Butane's a little bit more aggressive, but no different.
They dismiss all the videos that show things disappearing from the bottom up on flat surfaces. This is where
What didn't happen was that the tops didn't come down because of that. In that video where he lets the cold air in, the ground comes up to it, but the top of the object doesn't come down, which is, you've got two observations when you look at a ship go over the horizon. The water comes, or the bottom boat of the boat sinks into the water, and in an equivalent rate, the top of the boat deviates from its original height. It goes down the whole damn thing. When you have like refraction and stuff, where like the people's feet disappear into it, their heads are still at the same height they started.
Yeah, compression. I used to talk. I remember you, Coach. Up to. But I
made a video. It just so happens I just made a video this morning about what y'all are talking about. Everything he's saying is just he's like, I'm done talking, bro. It's like no matter what we show him, bro.
Stop.
No matter what we show them, bro, they just act like they didn't see it. It's just it's weird.
What are we talking about?
Like donkey talk, dude. Talking to fucking donkeys.
What are we talking about, Brian? What are we talking about right now?
What are you showing?
We're talking about whatever Brian's confused about at the moment.
Brian? Come on now.
What are you showing?
He showed not underlit clouds, lots of images of not underlit clouds, and not understanding how light comes through the edges of them.
I know Rakia Life ain't a baller, so he's like showing kind of baller proof, but he's saying different days. Look at all there is. You get refraction, you get the air, the humidity, you get the water, you get the stuff in the air, you know, this, and then they try to survey. It's comical. It's like 8 years of this is too much. Really, it is.
What's comical? Well, why don't you guys get off of their your little play pretend game and come back to the real world?
Where's the play pretend game?
Yeah, dude, you're gonna attack everybody the whole time. Where's
I mean,
the
are you
mob?
trying to incite a riot?
I'm just fucking up. I don't think they're actually fighting words.
I mean, I know, dude. You know, Kuma.
Well, Jeremy, you know you're playing pretend.
See, that's stupid, bro. Why would you do that?
Virus?
I don't know why you do it.
Definitely not pretending.
Why do
I don't know
kids
what
do
you
it?
think I'm pretending. Huh?
I said, what do kids do?
Right, so I'm just
Not
trying to
pretending. I don't know what you think this is, but
I'm just trying to give you a little example, right? So, Akuma virus.
Kids believe
been
in
asking me a question.
kids believe in Santa Claus, and then they believe in the globe Earth, and also dinosaurs and spacemen in space. That's what kids do.
And then they don't believe in dinosaurs where there's evidence of dinosaurs. You don't believe in the globe Earth where there's evidence of globe Earth. Yeah, so you're like Santa Claus.
and then the kids believe in a NORAD satellite tracker.
That
Hammer was trying to say something about Akuma virus.
Yeah, I wasn't Hammer. Please, for
Oh,
God's sake, don't ever call me Hammer.
Hey, Hammer.
Wait, who is this?
It's Harp.
Harp. I'm sorry.
Well, Akuma virus.
Yeah,
I asked
only a
him the
few letters
question.
off.
I asked him the question. And any of you Globers, right? So you're born with no knowledge. Nobody tells you anything. You're going to come up with in how many days or years of your life that you're living on a spinning water ball flying through an infinite vacuum of space. How long is that going to take you to figure out?
I don't know. It took a long time to do it.
Or you're just going to never, ever even entertain that thought because everything's flat and fixed.
It's going to take a really long time to come up with that because you have to come up with precision measurement. You have to have big ships. You got to make the observations that make it become clear to you. And you're going to have to come up with math and stuff like that in order to take on these small
You haven't
problems.
seen the flat Earth measurements at all. You're just going to die.
Yeah, odds are. I mean, it's a single person isn't going to come up with it. That's a body of work that comes up with it.
Okay. So you're dismissing the black swan and shit like that, right? So
No, the black swan has got very distinct reasons why what's happening is happening.
Okay, explain to me the black swan and how you getting 15 miles of refraction.
The miles is irrelevant. It's angle. It's the amount of degrees. You'll get with shallow angle. You're going to get a big difference in how many miles you can see. So if you just have to go and find out how many degrees down it is, and if you made that reversed, you'll be able to see it. So if it comes up by 1/10 of a degree, all of a sudden you can see 10 10 more miles.
Moyak, what kind of background noise you got? I feel like
It's
somebody's
incredible.
messing with you.
I mean, these
Yeah, with
people
a fart
make
soundboard.
Creaking? No, that's my my ropes on the boat.
just making shit up, bro.
Somebody was fucking with you with a fart soundboard.
No, it is the ropes twisting as the boat rocks.
Yeah.
Jeez Louise, I could hear that. Yeah, it's like.
See if I can get them out with
Roads look like
some of
that?
the sound options.
So Moyak, how does your angle allow you to see around, not only see around a sphere, but it also extends your idea of a sphere out exactly with a planar geometry? How's that happening?
No, it doesn't. It does never, ever, ever send, or I should say, so rarely as to be insignificant.
Every day.
Extends it out to never. It's always below eye line. The horizon is always below eye line for
Holy
any reasonable
crap.
number of measurements.
Wow.
You can say "holy crap," but
I haven't done this for a while.
every measurement I've seen shows it. You look at the center of a
Hey,
frame on a
that's not
camera, and
true.
you say
Have I
that's at eye
never
line.
showed you George Hanichuk's? Have I
Yes.
never showed you George Hanichuk's measurement where the horizon was over eye level?
Did I not preface that for all reasonable points and of contention, it is very, 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 very rare and under
No, it's
very
not that
critical
fucking
conditions.
rare.
Goddamn.
Hey, but then
rare.
the next sentence, but then the very next sentence, you said, "I've never seen a measurement of it above horizontal."
Oh, okay, yeah. I personally have never seen it above horizontal. I've seen
I showed you the measurement. I showed you the
situation. Yes.
measurement. I showed you the measurement when it was above horizontal. You've seen a measurement of it above horizontal.
Yes. I have
Okay.
seen somebody else's measurement, and my measurements, my observations.
Yeah.
So if you want to go with somebody else's measurement, which could have been wrong, could have been faked, I don't know,
George
man.
Hanichuk.
So you believe him, then you should believe his measurements, which show curvature.
There's plenty of days looking over the ocean beach that the horizon line is just barely under the fucking horizon.
Just under, yes. That's called under.
And, yeah, Slice Barcane and Jesse measured it way under at the Salt Lakes, trying to get to shoot the mountains behind the Salt Lakes, and what George went to question him, and Sly, or either Sly or it was Sly or what you call it, forgot the other guy's name, but I'm pretty sure it was Sly. I'll post a video where I pulled the clip, but Jesse Kozlowski set the outer level, and the fucking Great Salt Lakes was above the crosshairs. It's not as rare as you say. It's not as drastic as people might be thinking.
All right. How often would you say it happens on average for you take 10 measurements at random throughout a month? So, how often do you think it comes above?
It's about
On
as
the
often
ground, you're
as-
much
it's
closer
about
to
as-
the ground than you are the sky.
It's about as often as a day without inferior.
It's about as often about a day with
Not very
what?
common. It's
No,
about
why
as
would he
often as
expect it
a
to not be
day
rare?
without inferior mirage. So
You
it's not very
expect it to
common.
be rare because of how we see and how we measure and how we look over long distance and how we're
Yeah.
usually closer to the ground.
Yeah,
You-
usually we get an inferior mirage, bro. You can't say anything usually because usually there's a fucking inferior mirage, and you can't say shit for sure.
The frick are you talking about? The whole point is
And
that
it's
the
talking about
conditions
a
change.
reflection. Doesn't know what he's talking about. He's talking about an inferior mirage.
Optical
Inferior
illusion.
mirage is going to make it typically move close. The horizon move closer to you.
That's
Just
not
debunk
true.
that picture. Just debunk that picture.
This
real
is
quick.
not true.
Debunk that picture.
Inferior mirages happen on the surface, therefore they happen between you and the horizon. Therefore, they typically move it closer.
They don't. They can happen above the surface too. Travis pointed that out. You seem to be wrong a lot.
Oh, it's
Well,
funny.
you're always wrong, so I mean that's not a problem.
This is funny,
No, I'm just
right?
pointing
So
out
this
how you're
black-
wrong. Everything you've said
black
so
swan,
far has been
right?
wrong. We have pictures, we have videos that prove
I'll
you're
put
wrong.
my wrongs up against your wrongs any day.
Okay.
Here, just do me a favor, right? Just debunk that picture I just posted. Debunk the piss right out of that sucker for me, please. Tell me how
Hold
I'm
on.
seeing that as flat as it is. Tell me how. How?
How are you seeing what? Where is the horizon? Where is horizontal? Where's
Dude, this is
horizontal?
3 years old, bro.
Where's
Thing is
horizontal?
QE. Come on.
Where's horizontal?
What?
Where's horizontal? Where's horizontal? Can you hear me?
You losing your mind, bro?
Yeah, they're all. You hear Doofus, you hear him. They're all the same now. Broken.
You know, relax, please.
Where is
Come on now.
horizontal?
Some of us are wearing earbuds.
Just broken, dude. How can you be sitting on a boat enjoying the day and act like that, man?
I don't get it.
I get it. I know why. They live in a lie. They know
How
it.
do you do
Okay,
it? though?
where's horizontal, Rakia, smartass?
Living a lie.
Horizontal, where is it, Rakia? You just gonna babble?
You
Horizontal,
sound
where
just
is
like a guy that's angry, just like Doofus, that's living a lie, and it comes out here so easily.
Says Mr. Screams a lot.
All right, you guys, let's not go into the personal bullshit. So,
Where's horizontal? Come
yeah,
on.
what's your question, Moyak? What are you asking?
Where's horizontal? He showed a picture of the black swan. He's indicating that is above horizontal. The horizon is above horizontal. I want to know where horizontal
What
is.
does that even mean?
Yeah, he didn't say that.
Like level.
No. Where is the horizon? Is that what you're trying to say?
No, where is horizontal?
Horizontal is. What do you say?
I think it means like level. I think
We've been talking about where that the horizon is almost always below. I say colloquially is always below, but it's almost always below eye level or below level the horizontal.
What the hell does that have to do anything? You're looking out.
That's what we've been talking about. If you're having trouble understanding that, then why'd you bring up this piece of evidence?
Okay.
The conversation where we're talking about
So you're
horizontal
not caught
being
up to
below
this
eye
point.
level.
You're not caught up to the part where I'm saying to you, please debunk what I'm showing you. I'm not talking about
No,
eye
because that's
level,
not what we
dude.
were talking
Listen,
about. But okay,
listen.
what's the new
I'm
subject?
not talking about eye level. What is
Hold
eye
on.
What's the new subject?
Hold on.
Why do people? Why? Wait a minute. Let's clear this up real quick. Eye level? No, sorry. Sometimes it's above. Sometimes it's below.
Rarely above.
It's not always to your eye level. It's very easy to see because it's right there. It's not going down like a ball would. So
How do you know? It should go down about
how
what
do you
at that
know? Because
distance.
you're
It should go down like less than a degree. Definitely less
Here's
than a
the
degree.
thing, right?
Degree.
Debunk the picture that I'm showing you, please. Do that.
See what are you showing now? Yeah.
Same thing. It's nothing changed.
Dude,
Nothing
Moyak,
changed?
he posted the black swan and asked you to debunk it. So
That's all.
you haven't even addressed it yet. You started talking about horizontal, which is not.
Well, that's because we were talking about horizontal. He threw in a non sequitur. You don't expect me to respond
How
to
is the
every non
horizon
sequitur, huh?
about the horizontal? How's it?
Because we were talking about the position of the horizon.
There it is.
Now, if you go and look at that image and you try and find out where the that rig is, we'll find out that rig actually dropped with reference to the horizontal.
Where's the horizon?
I don't care. Horizon is an optical thing.
Good job. Don't care.
Okay.
I love my balls, and I don't care.
You take the most refracted image that you can possibly get with the cranes bending 50 feet.
Right in front of
Those
my
cranes
face.
are bending. Those cranes are bending 50 feet, and you're ready to say, "Oh, that's the one that we should trust because it looks a little distorted to shit."
Wow, that's incredible. Where's the horizon? Okay.
Yeah, Moyak, it's about the position of the horizon.
Where's the horizon? Real quick. Where's
Yeah,
the
if you want to, if you want to measure the horizon, you can find out whether the horizon rose or fell.
Can you see the horizon? Yes.
Use
or
a
no?
horizontal.
Can you see the horizon? Yes or no?
Sure.
Where is it?
I don't know. I don't have a reference for where horizontal.
You just said you could see it, and now you're saying no, you can't.
I don't know where it is. I don't know with reference to the
You could see it.
the rig. I don't know
You
what's
could see
happening.
the horizon. You said yes, and I said where is
Yep.
it? And you said I don't know.
Where is it? What do you mean? What do you mean by where is it? It's
You
right
see
there.
the horizon.
Why are you asking a stupid question?
Can you see the horizon?
When? This is a
In
moving
that
image.
picture.
This is a moving image.
In that picture, that's still
There.
picture.
It's halfway up the rig, and then it's at the bottom, or it's beyond the rig.
You can't do it, can you?
I just did.
It's a horrible thing.
You have problems with your
There's
ears?
the horizon, bro. Come on, there's one horizon.
Well, what do you mean by where is the horizon? It's,
You
I
looking
told
at
you,
the same
it's
picture
halfway up the rig. Yeah, they go really slow for you. It's halfway up the rig, and
Wow,
now
why
it's
is this
behind the
allowed?
rig.
This is
Obviously,
good.
That good?
dealing with someone who's
This is
not
good how
capable
he
of having a
thinks he's making
conversation.
me look stupid. Let him go. Let him go.
I don't think
Because
this
he's
is the
making
place for that.
himself look so stupid. It's
Oh,
incredible.
you don't think it's a place for that? Come on.
There you go,
No,
buddy. Good
I
job.
don't. I wish the mods would step in and mute you.
There you go. It
Well,
ain't no
hold
big
on. To
deal,
be
brother.
fair,
He
I've heard
laughed.
flat earthers do that too. The whole
Dude,
baby
did
talk
you
thing.
hear
So
him
Nah,
start to shake?
I wish they would mute them then too.
Come on, man. I made
I'm
the
just
boy
saying.
shake. Did you not hear him shaking?
Can I maybe?
Had
I don't
no
know, take over?
understanding of what he was looking at. He could not say that the horizon was beyond where it's supposed to be by way far. He couldn't do that. He had to leave.
Here's
I
the
mean,
problem.
Oh,
They're so
realize.
caught up in
Hold
the
on,
they're
one
so
second,
caught
one
up in
more
the
second.
long distance. Hold on, they're
One
so
more
caught
second,
up in
bro.
the long distance laser beam observations that they missed the elephant in the room, and that when
Yeah.
they apply their sugar water and gradient, the way they say the atmosphere works, the bottoms of the shit disappears. They missed the elephant in the room. They're so worried about the long distance lasers, bro. Every
Oh my
single one
God.
I've found so far, the bottoms of the shit in the background disappear. And if so, even if it's working the way they claim it is, then they just explained it on a flat Earth. They just demonstrated it. Shit.
What are you talking about?
You're saying
The horizon's only off in the black swan. The horizon's only off by a little teeny tiny angle. Not a
Okay.
lot.
Well, hold on. This sugar water thing, Brian. You're saying with the sugar water, the shit's being cut off bottom up? Brian? Hello, Brian.
Well, the air is made of sugar water. Good job.
I didn't say that. Brian says
You didn't say that. You had to have said that.
I didn't.
No,
Well,
I just posted, Arma, I just posted, but in every example, every single one, I did an action, I did a Mick West, and in every single example with the sugar water, when you're line of sight down low, the bottoms of the shit disappears. So even if refraction's working the way y'all claim it is, and that shows refraction with a line of sight. It shows obstruction with line of sight. Even your own observations and explanations back up a flat Earth. So check out that video I just
Yeah,
posted.
you're exactly correct. Back up a flat Earth, bro. That's correct.
Okay, but in the pictures that you've shown, because I'm pretty sure we've done this convo before. It's not that they're being it's not that it's being obstructed. It's just literally being squished. It's just being really squished.
Can't see. How about that? So you can't see it. So if I hold on. If I say if the laser was was crosshairs to a auto level, okay, and so now as we get lower, the laser works its way up due to fucking compression, whatever, due to not seeing the bottom. So the crosshairs, being the green laser, are going to line up halfway up the fucking buildings due to refraction, bro. So you should check out the video I just posted or skim through it, and I illustrate it perfectly.
Here's all you got to do. Check this out. You go across a lake, try to make it at least 10 miles. Get your buddy on the other side, and you each have a fucking mirror. Hey, now it's daytime, so the sun's out. Now all you got to do is hit each other in the face with the mirror, or it's flat. Period. Yeah, that works. Period. If you can reflect the sun, a great shot across a 10-mile lake, hit your buddy in the face. Earth is flat, and you cannot find curving water because it's not there. Please, anybody that finds me curving water other than these goofy refracted pictures, show me. It never happens. I've been
All right. Have you
fishing-
ever seen
I've been
a
fishing
raindrop?
all my life.
Have you ever
brother.
seen a raindrop?
Yes, I have.
That's definitely curving.
There is. Does that prove a curved Earth?
No, it's just curving water,
How
though.
quick is that teardrop once it is?
Listen, man, I'm trying, bro. I'm trying.
Oh, you're playing.
Raindrops.
When I came into
Drop
this,
top.
when I came into this 7 years ago, they were telling me that the tool that they've been talking about, the sextant, proves a globe Earth. And I looked at the sextant. I had no idea what it was Looked at it, I was going, wait a minute, this is all straight lines. What are you talking about? How does this prove a globe? And so it went from there. And then people were telling me about, spinning around and not feeling it. On the outside of things, it's different because they're giving me an example of an enclosed train or some shit. So from the get go, 8 years ago almost, about 8 years ago, this was all bullshit, very easily recognized.
Yo, real
Hey,
quick, is Kosho here though? Because there was something I
hey,
wanted
he's
to
right
go
there,
over
bro.
with him. There was something I wanted to go over him when we're citing these triangles. You there, Kosho? Kosho?
You're roboting, dude.
You're roboting, bro.
All right, never mind. Whatever. Carry on.
I think he's got to ask his mom for permission, but give him a few minutes.
I said, never mind. Carry on. Ask your mom for.
All right.
Oh, wait, so, okay, he isn't here. So he's just chat skanking. I'm stealing these QE fucking. You know what? I'm sorry. And I don't even care if you start accusing me of talking like QE did, because I understand why he gets so crazy and nuts and out of shape. I don't actually believe half the shit he says. So that makes it weird, doesn't it? But I understand how freaky crazy he gets over brain dead idiots who continue to deny reality. I mean, 8 years, why are you still here defending insanity? I don't get it. It should be so easy to show me the curve, bro. So easy. But I can't find it. I go fishing a lot. I've been fishing all my life, most of the time. Like, wow, 2/3 of my life I've been fishing. Never seen water curve ever. This dude in the chat says, Harp is half you believe that is embarrassing for you. Yeah, show me curving water. He says it's right out front of his house. This dude is nuts. Come over to my house. I got curving water right down the road. Come on, dude. Holy crap. Open your mic, bro. Stop chat skanking. How does the sun disappear bottom up? There's so much information out there. It's incredible that nobody really looks at it. They just come in here and ask dumb questions.
I think that's a good question about the sun being supposed to be whatever 3,000 miles high. How does it get below eye level?
I don't know. Who said that?
Me, Leftley.
Oh, I mean, who said it's 3,000 miles high?
Oh, well, I mean, we
I think
don't have
I'm with
anything
Left Lane on it. I
definitive.
think the question, how does the sun set on a flat Earth, I think that's a good question for a newbie. People like us, though, that have been in it for years, not a good. If you're still asking that question, I don't know. You haven't been paying attention.
See the picture he just posted?
Yeah, that was an excellent answer right there.
The picture he just posted of Lake Pontchartrain just lets you know you shouldn't be talking to someone who thinks that is a picture of Earth curve.
Dude, are you the guy who lives out there?
Yep.
There's a dude that lives out there and it takes pictures like on a.
There's a lot of us right here. A lot of flat earthers here. Oh yeah.
Over at Lake Pontchartrain.
Everywhere in Louisiana. Everywhere. There's so many people here, dude. That it's starting to get where there's more people taking up for that than there is the globe. It's getting crazy here. Yeah.
You know, all it is common sense.
Nobody lives in Louisiana, dude. They got like Canada's population or some shit.
They got a little Wayne out there.
Jeremy's just jealous because I got more guns I need to reload than he's got guns. Louisiana, baby. Good thing that balloon didn't fly over us. Cajuns would have took a couple pop shots at it.
You know, and how much more do you need? It seems like this illusion is coming to a close. And that kind of worries me a little bit. Because I remember Frank Zappa wrote this thing about the illusion. When the profit is, there's no more profit, they're just going to pull back the curtains and show you the brick wall at the end of the room, right? So that's not a good thing. So that means there's no further to go. And what does that mean? Like, see, when they're illusion, when this delusion, and people start really checking out what's happening, and I don't know what's going on right now. I really can't tell you. I'm not a prophet. But when the profit, the whole thing turns to crap and there's no more use of it, then what happens? The United States is ungodly in debt. I mean, they print their own money. I mean, they say 31 trillion, whatever it is, 50 billion trillion, who knows? Who cares? The thing is, they're creating the entire reality that we live in. Everything they tell us is a lie that is so horrifying when you find out that you're just going, oh my God, is there any truth anywhere at all other than what I could see in front of my face? Gases, the metals, all the things that they tell are precious and semi-precious, and the oxygen in the air. I mean, everything they tell us is a lie. It's a freaking lie. There's no, okay, I shouldn't do that. I'm going to do it anyway. There's no oxygen in the air.
What?
There's no nitrogen in the air.
What?
No oxygen or nitrogen in the air that you breathe. That's correct.
Okay.
Prove me wrong. It'd be very easy. It'd be very easy. Prove me wrong right now.
It's pretty easy to prove you right. It's easy to prove you right, bro. Like the fucking the what you call it, the oxygen condensers that you check the exhaust out of them, and there should be no oxygen, and exhausted the nitrogen. But the exhaust is the same thing as the oxygen that it intook. That doesn't. So it's just gas is just something they named. Process and shit. That's a good argument.
Well, I mean, I don't know about that.
Good Lord.
Here's the thing, right? So this is the thing. Oxygen is it's a pharmaceutical thing. It's a lot of money. There's a lot of money involved in oxygen. Any way you look at it, whether it's medical or acetylene oxygen welding, oxygen is not in the air. It's something that's produced by man.
Yeah, I was just gonna say it's
incredible, dude. All you got to do is start looking into this shit, and it's incredible.
So what is it about the air that you're breathing that is giving you life that enables you to live?
That's a darn good question.
Can
Darn
we
good
just
question.
Harp? Couldn't we just name the oxygen though?
Why? We what?
The thing that gives us life, in the air, or whatever. Couldn't we just name that oxygen? I mean, like.
Here's the thing, right? Because the lie gets deeper, bro. And this is what actually started me thinking about it, because I'm a fisherman. So somebody asked me, how does the oxygen work with fish? So I remember exactly how they tell me. Then I start thinking about it as I'm fishing, especially looking at the fish, thinking, this ain't right. There's no oxygen here. Something ain't right. This is how I started thinking about this. I'm a fisherman, and it led me into where I'm at now. Whatever we live on, they're not telling us, even if they know. They could say oxygen and all that shit, but you get a jar of oxygen and start breathing it and see how long you last standing. People get killed because they're diagnosed with COVID. Next thing you know, they're on these ventilators getting killed.
And watch the medical talk. Be careful with that.
Yeah, I'm sorry.
That's okay.
But the ventilator is oxygen, so you've got to be very careful about the ventilator. And all these things, I mean, you can't just obtain oxygen unless you're a welder or in the medical. You have to literally have a prescription. So then they say, and I've seen these things, and I'm going, my God, and I've been looking at this for like 3 or 4 months now, and I'm going, oh my God, I can't believe this. I'm just seeing thermodynamics at place, right? So I'm seeing where they're trying to prove by sucking the water out or pulling the air, sucking the water up into where the supposed oxygen just got sucked out of because the water came up, right? But what they're doing is they're using heat. So they're using a candle, which is causing a vacuum because of the heat from the thermodynamics. So it's causing this water to be sucked up into the displacement of what just happened. You know what I'm saying? And if you don't, you can look at these things. You can look online how they prove oxygen in the air, but watch carefully what they're doing. I mean, you can look up any of this stuff because there's lots of people out there saying, yep, this is how you split water or whatever, and this is how you do this. And you look at it carefully with understanding, you're going to see thermodynamics is happening and entropy is causing what is happening. It has nothing to do with oxygen in the air. It's not there. No such thing. No such thing as 70-odd% or whatever. Nitrogen? Are you kidding me? Shouldn't we be talking funny?
Well, hold on. I'm confused. So,
If
I put a bag over your head, right, and I start strangling you, right? Why do you suffocate? I mean, there's still air in the bag, right? I mean, there's still stuff. Go on. What's the answer to that?
So you put a bag over my head and you're telling me there's still air in there?
Yeah, there is. Still...
I breathe and I exhaust whatever's in that bag, and there's no longer any whatever is happening there.
Okay, so but we can still name that oxygen though.
It's just oxygen.
No,
that's what you run out of.
It's air.
Yeah, but here's the thing. We could take patients in that have had, like, they've got something cardio or respiratory going on, and they have low blood saturation, low oxygen in their blood. We can put a O2 sat monitor on there, and then we can put them on oxygen and turn the oxygen on, and we can watch their O2 sat come up from administering the oxygen.
Look at the moon.
Show me
Look
that.
at the moon, everybody. Oh my God, the moon is fucking huge.
Oh, really? Hold on. I'll be right back.
Is it? In any case,
I've seen it big. I've seen it bigger, but it's big.
Oh. Well, anyway, yeah, but back to the oxygen. I really don't buy the oxygen argument. Because there's just so many examples where I guess you could argue it's not oxygen in the way that we know it to be, but we could still name it oxygen. Like it's still.
Yeah, we could name it. Yeah, we can name it oxygen. It's processed though. All the gases, don't really occur naturally separate. So we produce it, and we can call it oxygen. Yeah, but as far as like it being natural, there's only a handful of natural things. It's a tough argument when you get down to the nitty gritty.
Are you sure? I mean, it's not much of an argument. The shit's measurable. It's really in the air. Oxygen, why he thinks the voice should be funny on nitrogen. I have no idea. Ooh, everybody. I mean, I don't understand this line of reasoning whatsoever.
You ever
It's
hear?
worthless. It's
You ever
fucking
hear?
worthless.
You ever hear what?
You ever hear when a couple, well, probably been a decade now, a lot of tire shops started advertising, oh, let's put nitrogen in your air in your tires. It's a lot lighter.
Yeah, dear, yeah.
No, it's not really. It's not any lighter. It's a little bit larger molecule, and it'll maintain pressure in your tires longer than just regular air.
The point is regular air is mostly nitrogen.
It's atmospheric areas, yeah. But you put pure nitrogen in there, it's supposed. I don't agree with it necessarily. I just think it. I don't know.
It's going
just
along
seemed to me like kind of a gouge or something like that.
Yeah,
maybe.
I'll argue 2 points. So it could just be like a little like thing to just sell, to make money. But it could also be sure, most of the air is nitrogen, but it's not all nitrogen though. So you could make the argument that pure nitrogen would be even better or something. But yeah,
Airplanes use it.
It might just be a money thing, like we're just trying to make money.
Yeah.
Airplanes use this because it doesn't leak as bad and it maintains pressure better.
Yeah.
There you go.
I don't think it's practical to have it in your car tires, though.
They
Because
do
if
put it
you-
in car tires. What are you guys talking about? Nitrogen?
Yeah, they put it in there, but I don't think it's practical because when you have a low tire, what are you going to do? You're going to go put air in it. You're not going to carry
Yeah,
around a
not
bottle of
normal.
nitrogen,
Yeah, normal people don't do it, but there are people that do that.
Yeah.
He's just saying it's not practical. I agree with him.
Yeah. The practical thing would be to get tires that just don't go flat.
Yeah, that nitrogen thing is a bunch of crap. It's like we were
the thing
colonizing
is,
in 1978, bro. Why aren't we not colonizing the moon again? It's 1978. I'm sorry. What happened?
Can't go there?
They destroyed the technology, and it's a painful process to build it back.
Nah, they never had the technology. You can't go there.
But it's painful.
Yeah, you can.
That I agree with.
Nah. They would already. You think man wouldn't
It
be
is
there
very
right now if you could get there? You don't know men very well.
We'd be on top, swinging our dicks.
Absolutely.
Just like them astronauts would have come back going, fuck yeah!
Name a place. Name a place that men can go to that aren't
bitch.
there.
Yeah, exactly. They went, oh, I don't know. Were there stars? I don't know. I think there were. Jesus Christ, stop. I can't lie. God damn. When they showed us that movie, Capricorn 1, they pretty much told us exactly what they did. Exactly.
You think Elon wouldn't be walking around on the moon in a spacesuit right now if he could get there? Shit. You better believe
His
he would.
name is El. He is God. El. He is El. Why don't people see this? He's going to Mars. He's El. He's God. He's Saturn.
Men want to be the fastest. They want to go over sand the fastest, water the fastest, air the fastest. They want to go the furthest. They want to go the
talking about,
highest. They want to go everywhere. They want to do
talking
everything.
about L from the Stranger Things.
Oh. Oh my God! I show that video all the time. I throw the video in there, right, and I plop it in word defend. It's comical watching Globers defend this crap. So seriously, it was red, white, and blue sparkles to push that thing up. It looks like tea kettle on a wire.
I mean, imagine saying, hey, it takes like 3 days to get to the moon and then not going there for 40 years. It only takes 3 days. Well, you can get there in like 3 days, but
They'd be going there on the weekend, dude.
yeah.
You better believe it. You don't know rich people, dude. People like Elon. He acts like he acts, and you don't think he would go to the moon on a Friday? Shit.
Of course he would. thinks he's God. He literally has named himself God. Are you getting this? Hell.
Pick up that book that most of y'all don't like, and it just happens to say that man can't go there, can't ascend into the heavens.
Right.
Funny, ain't?
Everybody wants to attribute everything to some supernatural satanic Satan. But in all reality, it's man. It's mankind. They're nuts. You had kings back in the day that were declaring themselves as God and to become above God, like Nebuchadnezzar. And everyone mistakes as Lucifer, who is a fallen angel, which is a load of shit. They just changed it conveniently just by a word. So they made it sound personal like a person, and they told you a story. And all of a sudden, they switched from talking about a king into the fall of Lucifer, became Satan. And they go on to explain what happened to the same man. Even though, and this is another thing that I started questioning when I was not right. We're talking about a king. They never switched off from talking about a king. This is not a fallen angel story. They're making this shit up. There is no enemy of God, the creator. There is no enemy. There's no other God. That's all bullshit. Is
Is Kosho back yet?
People who believe that way. I'm sorry. I mean to stress.
Yo, is Kosho back yet? We need to go over the spherical excess thing here because the way he said they measured the angles, I have questions.
Are you talking about surveying, bro?
Why are you asking
No.
Christo about spherical excess? I'm just asking.
Because he told us how they measure. He told us how they measure it with lights, with mirrors. Remember, on top of the mountains, and they don't
You
raise
didn't hear
them
me
up.
laughing, right? You didn't hear me laughing when he said that, right? That's why I said then I'm not going to
That's why
talk to
I
you
wanted
anymore
to get
because you don't
into
know
it.
what you're talking about.
That's why I wanted to get into it with him. Over that.
Yeah.
Heads let that shit slide. If you're taking an azimuthal angle, you're not going to be able to line them shits up with the horizontal on the other mountain. They're either going to be way higher or way lower. Like, no one caught that? Can you guys hear me? What's up, Ray?
I can hear you, but I wasn't there, so I don't know. Are you shooting distances
No.
that are beyond? Are you shooting distances beyond the capability of what you're trying to do?
No, they're using theodolites. But Jeremy, I think that's what
Hold on.
Doofus was talking about, that these 3 points are not coplanar. Each one has their own horizontal plane, and they're not coplanar. I think that's what Doofus
So
was
if you're
trying to get
lining,
at.
so if you're sighting mirrors on the tops of other mountains, but they're not coplanar,
It defeats the whole purpose.
how are you even doing that?
Yeah, it defeats the whole purpose.
No, you're just looking up at it or down at it, and you're measuring those angles.
So you look at a mirror. You aim your shit on one mirror. Horizontal anymore when you're looking at this, right?
See, on the azimuthal measurement, I don't think it matters that you're looking up and down. It just depends on what direction you're looking in relation to the other observation. You know what I mean? You're looking at the 2 different points. But I'm very limited on the understanding of all this stuff, so all I've done is picked up a few things.
You completely lost me.
If you're taking an azimuthal
you need to
angle,
explain what you're talking about, because are you talking about
Go ahead,
measurements now?
Well, yeah, there's a big argument going on currently about spherical access and geodetic surveys.
Okay, hold on.
Those
It's
documents.
not access. Hold on. It's not spherical access. It's excess.
Excess. Yeah, excess.
Because I did that the same thing the other day. Yeah, I've been on this. Yeah, it's crap. How far do you think you can measure with a theodolite before you have to mark that place and start over again?
Well, they're not limited. They're not limited to distance. Theodolites can look as far as you can see with them.
You're gonna have them saying cold fusion for 3 fucking days.
Is that infrared? Or are you talking about theodolite with infrared? Because that would work.
No, just theodolite.
Oh, okay, because that don't work.
Yeah, it does. Yeah, if you look in the manuals, there is no distance limitation to a theodolite.
Well, air doesn't count at all. They don't even talk about air. Really?
Yeah, they do. They do talk about air and accommodating refraction. Yes, they do correct for that.
Oh. So instead of doing it the right way, like measuring as far as you can and then citing that and then starting over again, they're having you use refraction calculation. Correct? Is that correct? So instead of measuring it the right way, we're going to just boom, shoot the breeze and then calculate refraction. All right. Dude, I've seen this newest one that just will give you any kind of refraction to bring any kind of bend straight up into view. I forget the guy's name, but this is pretty recent, within the past month or so. I think Jeremy over there was talking about it. A couple of people were talking about it, but I was going, oh my God, he's just turning a knob. Oh, Craig, what's his name? FTFE, right? He uses it.
Mm-hmm.
Right. Recently, very recently, he acquired that tool.
I mean, I don't know if you even knew about the spherical excess thing, but did you know that we don't even actually have any actual measurements of it?
Yeah, it's just refraction in the air, and then they just assume that it's sphere. That's all.
There's no actual. We'll stick around. We'll probably get into it deep, but yeah, they don't have any actual measurements of it.
Right. They just don't get the 180 degrees that they need, and they assume sphere.
No, they get more than 180 is the problem.
Did they show me one measurement? Show me a
They're
single
all over they're all in that document on the big area triangles. All of them
Yeah,
have excess on them.
Show me a single measurement. Just
Oh, I know
one
what
measurement.
you're saying. I know
Just
what you're
one
saying.
measurement. Do you have one measurement of spherical excess?
Well, the numbers that are recorded, I think, are averages of the observations and recorded as the measurement.
So no measurements, just an average.
They have to be, because if you
I know
ask
I
them
sound
to
silly to
calculate,
you, but
they have to be within a certain number. So if you ask them to calculate that, you have to come up with that 24,901 circumference. So they have to throw out numbers that don't work. When you have a number that's more than 180 degrees, because the air happens, and they automatically say sphere. Period. That's it.
well, yeah, they also told us that there was no refraction involved with this, but come to find out recently, there actually is refraction involved in this. They're just saying it's a little tiny bit, but nonetheless, there's refraction involved, and now it's just where is its actual position? They're just playing guessing games at this point.
Well, they were talking admitted to the vertical part, but the lateral refraction, I've heard that denied. Yes. Yeah, I've heard it said explicitly there is no lateral refraction, but apparently there is.
Apparently, yeah. They told us for years that there wasn't, right? They told us for years there wasn't, right? Left lane, yeah. It's fucked up, bro.
Hold on. I mean, from my understanding, I mean, there's no reason why they couldn't be like left to right lateral refraction. It's just that it's not going to be strong. All right, like because like the thing is, from my understanding, the reason why we get like, up down refraction is because you have, just the way like heat does its thing, like with the body of water, whatever, right? Like usually, like I guess the water's cold, whatever, and therefore the air above it's maybe cold, or or maybe the water heats it up, whatever, and there's like that lag or whatever, and then the air above the water is hot or something, and then like so like naturally that the layers being vertical makes sense, but horizontal that doesn't make any sense. You're not going to get those layers naturally, so you can have it like left to right, but it's only like it would be really weird extreme cases, whatever, where you got like pockets of like warm air or some shit. You know what I'm saying? I don't know. It's just not. It's not really, something you usually get.
Well, isn't wind caused by there being pressure because of temperature differences? I mean, isn't wind due to temperature differences?
Yeah.
Wind is always left and right.
But I don't think it's but it's not like probably not like a gradient though, and even then, it's probably not like a strong enough gradient for you to really get any like crazy effect though. So, like once again, like it's not like you can't have left to right, but it would be it's so like like you're not really gonna pick up anything like anything crazy with it. I imagine like if you are gonna get any refraction, it's probably gonna be like very tiny. It's not gonna be something you're gonna be like, oh shit, it's moved this much. That's
Okay,
only
but
happens vertically.
in the end though, you don't have any actual measurements.
What you mean?
You don't have any actual measurements of spherical excess.
Oh, I don't know.
Yeah. There's not. Well, everyone else knows.
But I don't think it's wrong to say that left to right refraction isn't really a thing. Like if you want to get technical, yes, like a lot of things are always being refracted because it's just you're not gonna have like a perfect. There's no such thing as like perfect. Like what do you call it?
A clear day? You mean a clear day? Yeah, there is. Yeah, there is such a thing as a clear day. This bullshit about there's always refraction is bullshit.
There's always refraction.
Always refraction.
Do you think that
Is there always sugar? Is there always sugar in the air? Is there always salt
usually
in the air? So if
There's
you're gonna,
always a density gradient. Always
so
a density gradient.
if you're gonna believe in standard refraction, you have to believe in minimum refraction as well.
Minimum is still refraction.
Oh, okay, yeah, that helps.
Do you think these surveyors are just incompetent or something?
Yes.
Okay, just making sure.
Yeah, so Jeremy thinks so. Yes.
We don't know yet because we don't have any actual measurements to go over. As soon as we get some measurements, we can figure out if they were competent or not. But as of right now, we have no idea if they even were competent. Yeah.
Well, why don't that's not even accepted? Then let's throw the whole thing out. We have no idea who these people. I don't know any.
There's
of their
nothing
names.
to throw
I know
out.
one
You don't
guy's
have
name
any
is
measurements.
William. I don't know any of the rest of their names. I have
There's
no idea if
nothing
they're
even.
religion or anything. So
Osho,
yeah,
there's
throw it all out.
nothing. There's nothing to throw out. We don't have anything to throw out because there's no measurements.
Well, it's easy day then.
Easy peasy, right?
Yeah, why not? I mean, these guys
Give me
are
some
losers
measurements.
for all we know.
Give me some measurements at least that I could throw out.
You guys are so fucking.
Listen, I wanted to talk to you.
I'm not trying to be racist or not
Alright.
saying anything against
I
black
have to do this again, right? I'm gonna
Hold
throw
on,
it.
I want to ask Kosho a couple questions real quick. Harp, is that cool?
Jeremy is low.
Yeah, bro. Ask him about this picture
Wow.
I just posted.
Give me
too,
2
while you're
minutes. All right, just give me 2 minutes.
All he needs is 2 minutes, man. That's what I heard.
2 minutes. Ask your girl. Yo. So when they measure these angles, they're lining up they're lining up mirrors on top of mountains. That's how they always do it.
Mirrors. Sometimes they have smoke signals. No, yeah, it's usually a reflection. They have like a little reflecting thing.
Yeah. So, but they keep their horizontal, right?
I'm not sure exactly which method they use, but they're only measuring the horizontal.
Yeah, left to right. But they keep a horizontal though, right? The tool. They make sure their tool's horizontal and they measure it left to right.
Like I said, I'm not sure. I'm not sure exactly how they do it. Like because you can do it that way, but you'd have to measure to the vertical. Like you'd have to measure to their vertical, but keep your horizontals the same. Or you can measure. You could just measure the horizontal component of your swivel. That would work too, and that actually seems easier. Like I said, if they had 2 gears on it, they could turn it to the, turn it on the horizontal axis, and then turn it using like a vertical component of a. You know what I mean? Like it's like if you had a telescope that only went up and down on an axle, and then you had it sitting on a table that only went horizontally. You could point at it anywhere around you, and you'd only look at the horizontal component of that. So you'd only look at the turntable, how far the turntable rotated, and that would give you the horizontal component.
That's dope. So how big is this? How big is this reflection they're seeing?
Sometimes they're small. Some of them are bigger, but I've heard some of them were 3 inches, 3 inches by 3 inches.
So is it a point?
No, it's a light source. So that's why they get a reflection off of it, so that they can use it as like a light source.
Yeah, I'm just saying when they're looking at this thing through their crosshairs, right? How much is the crosshair taking up of the reflection? Is the light bigger than the crosshair? Is it smaller than the crosshair?
That's a good question. I think it's just a point in the distance, and they're just pointing at that point. But I don't know exactly how big it takes up. I imagine if it's
These
only
guys could have
point.
been incompetent for all we know. We don't even know what they were doing.
Yeah, they could have been.
Are you saying they could have been? These guys could have been incompetent?
They could have been, but they've otherwise did a good job. I mean, most of the places that they mapped out, they weren't horribly wrong. So it'd be weird if they mapped everything out correctly, but then just messed that part up that there was spherical excess. So who knows?
I mean, we don't know what they were seeing in their scopes or anything. What they were sighting up. You think it was mirrors? Maybe. Who knows? They have vertical component to their tool. How many arc seconds could they measure up to? Was it to a fraction of an arc second? Do we know anything about this at all?
Well, I mean, they have pictures of the mirrors that they used.
Hey, what's it?
Yeah. Anyways, go ahead, guys.
Time's up, Jeremy.
Time's up.
Did you have to do chores to be able to come on here, Kosho?
Yeah, but I skipped them and I got in trouble.
Nah.
Hey, what's it? You there, buddy?
I think he's feeding chickens or something.
He's joking. I was gonna say he might be feeding the chickens.
I see what you did there.
I just want to say real quick that I've never seen anybody debunk the Black Swan. That's the whole reason I started listening to Nathan back in 2020. Right in like as soon as I saw that, I was like, "Damn, son of a bitch!" About time somebody declared something because we see all these pictures all the time. So there you go. And he did that because of the landmarks, right? So the oil,
I don't know. I've seen people like refract a bunch of butter out and baste it up and cook it. I didn't even think the black swan was a thing anymore.
Black swans do not debunk white swans.
What?
I said black swans do not debunk white swans.
So
that's not the point of the black swan.
bunks.
That's not the point of the black swan
exactly.
argument, though. That doesn't even make sense.
And all swans are
even
not
the Glovers
white.
are like, huh?
All swans are not white. And white swans really are the black swan. Because you need to show me some actual curve. That would be a killer black swan.
I bet you Jeremy can debunk the black swan right now.
Go ahead. Let's see that.
Let's see what you got, Jeremy.
Well, we know refraction. We know refraction is happening, right? Yeah.
So read the talking about we're 1 foot off the ground.
Do you know refraction is happening at the thing, right? Things are higher. Sometimes things are lower, right? Oh, shit. Hold on.
I don't think this is gonna go well for you, Jeremy.
Yeah, I was just kidding, man. I wasn't really thinking you were going to debunk me.
I see the wreckage coming.
What's up? All right, my AirPod's good.
There you go.
Anytime
ready
they
for
want
this?
to show me how they can debunk this. I mean, without.
I'm doing it right now. For
I'll post this so it's nice and fresh.
He can't even get his earphones mic to work.
That shit, robot, bro.
You've got technology on your side, Harp.
He's fake having technology
There's
problems.
a fucking asshole outside of my goddamn house with a fucking front end loader. That's what I can't believe. Holy motherfucker!
Go beat him up.
Video it.
Yeah.
Pretend he's Jeremy. Take
I
out
hope
all your
it's not
aggression.
me.
Yeah, Kosho, you'd have to prove your periscope refraction if that's what you want to claim.
Hey, that wasn't my periscope refraction. Whose periscope refraction? Who was that again?
That's what you guys have to use for dude. The observations we make are an extended plane. That's what we actually see. You guys have to come up with a periscope refraction fabricated thing to make that explanation work on your idea of a sphere Earth.
Oh, there was yeah. Go ahead.
So where have you validated or in any way shown that there's a periscope refraction effect happening?
I haven't, but there was a dude making that argument the other day. That's funny.
Is that me?
Periscope.
Yeah. He was seeing around corners and shit.
Yeah, that was me.
That was you. Yeah, there you go.
Yeah, that was
See,
talking
this
about
is the guy you want to
apparent
talk to, man.
versus physical.
It has to not only periscope it, but it also has to lift it up and extend it with a planar geometry. You got to do two things.
That's the same thing happening, but sure.
That's going to flatten out the horizon and extend it outwards? No, a periscope would let you possibly see around a curve, but it's not going to extend it out in a planar with a planar geometry.
Well, the periscope changes the pathing of the light, which changes where the object appears to be, which is what the atmosphere is doing.
Mm-hmm.
So not Earth curve then. That's what you're saying.
I don't know how you got that from what I said, but sure.
Well, you're saying this couldn't be on a flat plane? Like those effects that you just described couldn't happen on a flat plane due to the atmosphere? Because you still have atmosphere on a flat plane,
right? Do you?
So these conditions could affect the way we see and could make these things appear like we see them. Like, I don't say we see too far, right? I say we see exactly as far as the conditions are allowing. The only difference is over a flat planar globe, but both things would happen, right? It's just on those clear days, the water would appear to fall away from me when it's not being loomed up. The sun wouldn't always set and then be loomed up every day because the conditions are perfect every day for that on a sphere. It's not what would happen, right?
Well, on a flat plane without gravity, I don't know why you would have a density gradient in the atmosphere that would cause the light.
So just take a flat plane with an atmosphere. I'm not sure with a density gradient caused by whatever you want to say it's caused by. If you want to use gravity, that's fine. You don't know that's the cause of anything. You can't even give me the cause of gravity, which is weird, but invoke it all you want. Just do it over a plane. These effects would still take effect, right? They would still happen. We still see the same thing, right?
What I'm saying is, I don't know that we would.
Okay, well, I'll prove that we would. So I posted a picture of a shrimp boat that's less than 4 miles away. I'm the viewer at 8 to 9 feet. The same thing you see over distance as a windmill, a ship, or a building be obstructed bottom up. I'm showing you a shrimp boat on this day being obstructed bottom up. I can show you a different day at the same viewer height, the same viewer, which is me, using the same camera, shooting out from the same beach, a shrimp boat that's not being obstructed. So obviously it's the conditions, right?
I don't mean to interrupt, but Rakia, did you say you observed, you made that observation from the shore?
Yes. Yeah, B-Ball gets it wrong like he does everything else. It's from a beach by my marina. I go there, not on the weekends usually. But I shoot from the same spot. Thousands of videos, thousands of pictures of different objects that are close. I don't replicate that effect very often, but I captured it that day, didn't I? I have it on another day where 2 shrimp boats, one is close, one is a little bit, a half a mile or a mile away further than the closer shrimp boat. And one of them is not obstructed and one of them is, but neither one of them are far enough away from me, the viewer. That's how I know I'm not lying. Because it's me. I'm not claiming to be 1 foot. I'm like 8 or 9 or even more.
You were on the beach?
I'm on the beach with a tripod. And these shrimp boats are like halfway cut off. It's a phenomenon. They're close.
What beach was it, Rakia?
Grand Isle. I'll show you Lake Pontchartrain Bridge from 7 miles away from the walkway. You can go there. These phenomena happen up close. The bridge appears to be underwater and curving. It does neither. It's above water bridge, and it doesn't curve. It's just a phenomena that you're experiencing on how we see.
Yeah, I always thought you were in your boat. I didn't know you were on the beach.
Yeah, because you listen to B-Ball, not me.
Well, yeah, of course. That's the only person I listen to. No, I know that really. I think I just assumed it.
I have pictures I've taken from my boat, but I don't use those because I'm moving more than I don't have a gyro that stabilizes my camera. So the sunsets and stuff I take from 100 miles offshore, you can tell because the boat's moving over now. Yeah, this is from a beach. There's an oil rig right there. You can look at the Grand Isle area. There's tons of oil rigs, but the closest ones to the beach that's how you can judge the distance. But on this day, I was actually talking to the captain, and he told me with his radar how far he was. Plus, I could scan over and see the oil rig. He was in front of the oil rig. That's where they shrimp most of the time. Hello? That's not curving water, right? That's an optical illusion caused by the conditions of that day. It's called a mirage.
It's a refraction.
The very definition of a mirage. You can look it up right now. Optical illusion, which is what that is. Water appearing to obstruct the boat, which we know it's not. Optical illusion part caused by the conditions of the day, which we know that affects things because I can show you on a different day where you can see the shrimp boat.
From 3 miles away.
Yeah, that's going to be your contention. I would, I'm not calling you dishonest. I'm not saying you could make a mistake or whatever, but I would say that shrimp boat is no way is that close. That's what I would say.
I would say the same thing too, but I'd use his words as well.
You'd have to, right? Okay, how far would it have to be? How low would the viewer have to be? You can go out and do these observations yourself. I'm not a miracle man. Like I just bought a camera and went out and spent time, right? No one wants to spend the time. They just want to, say, I'm not calling you anything, but in my opinion, that boat has to be further away over curved water and deny the mirage that's taking place. What about the bridge?
Those bridge pictures are crazy. And I just want to say, I didn't say that. All I said is I'll say what he said. That's all I said.
Yeah,
but
the bridge. I went to both sides, the east and west side. I'm on the south shore, right by the Marriott, and on the east side, it appeared to curve towards me, and it's actually straight and it's above the water. It appeared below the water on that day. 6 days later, it appeared more normal. It was just mirage. I went to the other side, the west side, and it curved that way. Appeared to. It don't actually curve, right?
Can I ask you a question?
It's made out of concrete and steel. It doesn't curve.
How do you know it doesn't curve?
What are you talking about?
I'm asking you, how do you know? You're saying it doesn't curve. How do you know?
You can drive. Oh my god, dude! You can drive over it. That's a simple answer.
Fair question.
Okay, I'll post a picture.
I was just saying, Ricky, those are crazy pictures. That one that you had, but do you have one from both both sides? I've seen one, I think, but I don't know if I've seen one from both sides.
Yeah, I got them from all over. I don't know if I got it on my phone, but I'll try and find something. So I'll show this guy what it actually looks like, and then what it looks like 6 days difference. And the only difference is the conditions of that day. It's the same bridge, right?
That shrimp boat picture I always thought it was kind of scary looking. It looks like something sneaking up over the horizon coming at you.
Nah, I'm not trying to convince anybody. I just have proof. I proved it to myself. I don't need an expert in photography or how light bends or whatever to tell me that the water can appear higher on one day, the sky can appear lower on one day. I have physical pictures that I've taken myself that show me this and video.
So when you've determined that the bridge is straight, have you done it by looking at it?
Driving over it, researching it, taking pictures of it. What are you talking about? It doesn't. You see how it's curving?
Yeah, but what you've just said is that different days it can look different, right? So just because it looks straight or it looks curved does not mean that it is straight or curved, right?
You can see the difference, though, right? On those
Hold
2
on,
days.
sorry, hold on 1 second though. I'm looking at that hump that's there. Is that a real hump? That's really what it looks like?
Well, no, it's distorted on the right because
No,
the
on the
bridge is
left.
on.
On the left.
Yeah, that's basically it.
Okay, I mean, I've
60
always
foot above the water.
I've seen Soundly's pictures, and I always thought I was like, dude, that looks exaggerated, but that
No,
almost
that's
looks like
compressed.
smooth.
His pictures are compressed.
His are compressed, but I'm saying, but yours aren't, right?
That one's more realistic. It's refracted a little because see how low the bridge looks to the water? It's actually 16 foot off the water, and then that span going up is like 60 foot.
Yeah, Stanley's picture makes the entire flat part of the bridge look like that hump, and then the hump part look like a tower going straight up and down.
But I always thought, like, when I saw his pictures, I thought that it was like, I was like, yeah, those are exaggerated. That's just, whatever you call that, perspective compression or whatever it's called.
Yeah, that's what it is.
But it looks like it kind of looks like that. Like it looks, I mean, it doesn't look exactly as steep as his did, I guess, but it looks steeper than I thought it was.
The bridge has 2 of those tall things, and it has 3 that are shorter than that you can't really even, like, you can't see them very well. And I'm just grabbing pictures off my phone. Those might not be just showing you that the bridge isn't curving, right? It's just curving because on that day, the mirage makes it appear to curve towards the viewer and go underwater. It does neither. It's just a mirage.
Can you imagine getting close to that bridge and seeing that and thinking, "Oh my God, what?"
Yeah, yeah. I've seen some crazy
Some
stuff.
people would be going, "Yeah, let's jump up and shoot over it." Some people
Yeah,
would be going, "Oh my God."
the picture Kosho posted is of Lake Pontchartrain Bridge from the Marriott 15th floor, but he took that with a telescope and like a camera attached to it through 2 panes of glass, and then that's multiple pictures. That's not one photograph. That's he can't tell me how many, but he said over 50 and under 200.
And those green signs on
499
the right side, are those 1 mile marks? Are those green signs on the right side like 1 mile apart?
Those green things?
That would be a radical ball. That's so weird.
Yeah, there's mile markers on the bridge, those posts, and then there's those white things that appear white on the left side.
Those look like they're mile markers.
Those are electrical boxes.
But how far apart are they? Do you know?
I used to know all that. I don't.
Like if that's 1
those
mile,
things are not a mile apart, man.
No, those electrical boxes are not a mile apart. Like that's 24-mile span bridge.
They're probably about eighth.
Eighth of a mile? Well, I mean, I don't know if
That's what I would assume. That's just a guess.
somebody could look it up, probably.
They kind of look like they might be a mile apart because depends on how much of the bridge you can see. It looks like there could be about 20 of them.
I don't remember. I mean, we used to discuss this all the time. When Stanley told me he could see Earth curved from ground level, but you had to have 20/20 vision to do it, I just quit talking to him about stuff. But he did teach me about compressed perspective. I didn't know. I was brand new and learned about that with this picture. Him and Jesse taught me that. I never knew what that was.
Yeah, I knew a lot about perspective as an artist, but and when you get out into the air, things get kind of weird because when you're an artist, you like to see everything on a clear day.
What's also weird is look at the water tower on the top of that where the boats go in the estuary, and then look at the further point of the bridge that cars are driving over. They basically, look like they're tree height for some reason, and I think that's just because of how we see over distance, right? You get what I'm saying? You see the deck of the road in the very distance, like 20 miles away or 23 miles away. It's almost as tall as the tree level. Well, you know that can't be, right? It's only 16
What are
feet
those
off the
two
line.
giant humps of the highway? They're not bridge openings, right? That's just
Well, they used to have where they would open it, but they redesigned it and put these. They have 4 of those where boats go under. See the left and right of the humps. There's wood, like that's a place where boats go in between. You just can't tell. It's 60 foot off the water.
It has nothing to do with those roller coaster roads, is what I'm saying.
No, it's just compressed so it looks steeper than it actually is.
Which causes you to have a curve.
I think a lot of things cause that, but
Well, it doesn't cause a curve. It causes an angle to look steeper than it is.
yeah, I mean the bridge looks like it's
I'm talking
rising
about the
up.
overall. When you're looking at the overall thing,
Right. But in any
it's not
case,
curving. It just looks like it.
well, I'm saying in any case, it won't cause you to see curvature if there's not curvature.
Right, and bridges are not built like that. Or see that?
Well,
Yeah.
they are.
Okay.
They're built to match whatever
They are. Yeah, which is level.
Yeah, whatever level is. Yeah, they match whatever the level is. So if it's a flat Earth, then yeah, they're built flat and level, and if it's a round Earth, if they're just built level.
It says that the markers are one.
They never compensate for a curve. That's the thing. You
It
might
says the
get a
markers
Y
are-
here and there where you get 1.5 inches here, but that's because of the bridge expansion. It has nothing to do with curve. I mean, I don't even know how they could put that on in public. Beyond changing everything they've been changing, like all the definitions, it's insanity. Insanity. What we're seeing, guys, is our knowledge disappearing. Like, I'm 63 in April. And everything I know is being erased.
Mandela effect.
No, shit's being erased. I've known shit and made videos about stuff, and I can't find it anymore. It's being erased. It's gone.
Well, they didn't erase this info. It says that the markers are placed every 550 feet, or 1/10 of a mile. Those green markers.
Those green markers, yeah, but those.
You need a tenth? A tenth of a mile, did you say? Tenth?
Yeah, 1/10 of a mile.
Yeah, the electric boxes are 1.35 miles.
They're 1.3 miles. They're okay.
1.35 for my calculation.
Wait, you did a calculation? Why don't you just look it up like a normal person? I just looked it up.
Well, I measured it, is what I meant to say.
Yeah, you didn't measure
But
shit.
I interchanged those words, so.
Yeah, you don't say measured when you calculate it, bro. Know that.
Well, those words are interchangeable to me, so that's what I use.
Oh, they're
I
not.
measured it.
I never understood this objection to measure versus calculate. Like, for example, I can dispense with this nonsense right now. Can you ever measure the radius of a basketball?
Sure.
How would you do it?
You'd have to divide the diameter.
That's a calculation.
Okay. This is this is Gambino. Okay, I got you.
Gambino,
A
guys.
simple calculation, which is actually provable, right?
Okay, so calculations
Actually
are okay to know
provable.
something.
No, you can understand the measurement because you got a physical measurement.
You'd have to measure the circumference and then divide.
You know,
That's a calculation, though. Is that a valid way of knowing the size of something?
All you got to do is have the diameter, bro. That's it. Yeah. Oh. Yeah.
The thing is, you can derive dimensions of something through maths from knowing other things about that
All
something,
you need is the radius or the diameter or the circumference, whatever. Any one
and
of
it's
those
legit.
Yeah, like how did you claim to measure the radius of the Earth or the diameter of the Earth?
I didn't.
And we measured the radius of the basketball.
You measure the diameter of the Earth.
Well, that's not what just. I mean, I think somebody
You
said
didn't.
the circumference.
You didn't measure any of it.
You know what I would
It's all
do?
refracted.
If you gave me a whole year, I would spend the whole year. I'd spend the whole year every day. I'd measure 4 minutes of the subsolar point moving, and at the end of the year, I'd find out which day it was the longest distance, and then whatever distance that was, I'd multiply it by 360 and divide that by 2 pi, and I would have the radius, and I'd be sure of it.
Like right
Right
now,
on.
like it's getting long. Like the days are getting longer right now. All right, and you can notice it. Like if you're in the north, right, you can notice the days are getting longer right now. If you're on a globe, you have to believe
Yes,
that
they are.
it's wobbling. Yeah, it's wobbling, so that the days are getting longer, and you
Yes,
don't
that's
feel
true.
it.
Bubbling doesn't cause that.
Yeah, that's not true at all, man.
The tilting and wobbling, and you don't feel it.
Not
So I
wobbling.
It's tilted, but it's
I
not
think he's being
tilting.
facetious.
I posted the video of the Lake Pontchartrain Bridge that I went as high as I could get.
Oh my God.
In that area, and took it on a very cool, crisp, clear day. That the best day I thought I could take. I've taken other videos where it's just all miraged up. This one kind of shows it as unrefracted or unmiraged as you can get.
Can you see any of the electric boxes on this one? I can't tell if you can see them or not.
I have pictures of them.
But I'm just saying, like, is like, can you recognize them in this image though? Because I don't know if I can or not.
Hey, I got a really crazy question.
Yeah.
Are those humps real?
That's what I thought. I didn't realize that at first.
No, I'm on the east side on that picture. The electrical boxes are on the west side.
Oh, so you can't see them at all. Okay.
Yeah, but I have pictures of them on the west side. Let me see if I can find them.
I was trying to figure out. Well, you know what? Somebody said those markers were a tenth of a mile apart. I'm trying to see if I can determine the range of that image, or the range of the bridge that it is.
I got to clarify for this. Okay, so are those humps real? You telling me that's not refracted?
That's what he's saying.
Depends on what picture you're looking at.
I'm looking at the last picture that was posted.
649. Yeah, that's a real hump. That's where boats go under. The boats go underneath the bridge.
They're literally built that way. Okay, but sometimes they get crazy and look way different.
Right,
Okay,
like right there is where I took the picture where the bridge appears underwater, and that part of the bridge appears to curve towards me, and then that hump is like flattened out. You can't even see the tower. Like that tower is further away. It's in the middle of those two bridges, further away. But in the picture that's so mirage, you can't even see the tower.
I think I can now. The center between them.
I'm saying
it looks really skinny.
Right, but I'm gonna show you a picture.
I can see that. I'm that is awesome.
There's two of those
shaped that way.
Yeah. There's two of those high rises where boats go under, and then there's three smaller humps where you can go under. Let's see that picture. That's basically from the same spot.
Yeah, okay, so that looks like less of a hump. See, that looks like an easier.
It's just stretched. It's just mirage. See the tower to the very right of the picture? Like you can barely see the tower in the picture. It's all distorted.
Yep.
See how the bridge appears to curve towards me? The view, because I'm east of the bridge. It's actually straight, but it at the bottom where it meets the water, it's appearing to curve towards me. It's just a mirage. Yeah, it's just a mirage reflection. Whatever.
Yeah, Sally's images doesn't have any of that.
That's a reflection, bro.
Sally's doesn't have any of that.
Looks like it's coming. It's curved around into the water. That's wild. That is awesome.
Yeah.
Air exists and disturbs the path of light. We know that. And Earth curvature exists and atmosphere exists. What's the big deal?
No one's disagreeing with that. The hell are you talking about? I'm posting this as a proof of mirage.
So you don't disagree that Earth curvature exists and mirages exist?
I don't agree that water
Earth curvature exists.
I agree that water appears to curve because of all the things you listed, but
where's the mirage in my satellite images?
Your satellite images.
Yeah, the thing I talked about a long time. Don't pretend you haven't heard about it before.
Yeah. I mean, I think those just are. I answered already. I don't think there are mirage.
Okay, and they show water curving and Earth being a globe. So
yeah, but I can put a lens on my camera and show a flat wall to curve. I have an image. I have an image of a boat in a river that appears to be curved. The whole boat is curved, wrapped around, touching itself.
Okay, well, we didn't use that
What's
type
your
of
point?
lens. We didn't use that type of lens, so that doesn't matter. It's irrelevant.
What type of lens did you use?
The one that I linked, the Arduino camera.
How
I gave you
high
the
up
focal
were
length.
you?
500 kilometers.
How many miles is that? Just to give people the reference.
About
It's like
310.
300 something.
And you see the whole, like that portion of the circumference.
Yes.
I don't know.
Mhm.
Seems very small to me.
Okay. It doesn't
That's
matter. It
weird.
still shows a globe.
Got a question.
Okay, good for you.
So, like, how do you dismiss that? And how do you
I
go on
just
saying that
I
Earth is
live
flat?
here. I've never been up there. I've never seen it like that. I've only seen what you claim to be your satellite
Are
pictures,
you a
which
paid show?
I
Bro,
could care
listen,
less about.
seriously, I got a serious question, bro. Seriously. Big Gambino, are you a paid show?
What the hell is a paid shell?
Yeah, same
You know what a
question.
paid show is? See, that's what exactly a paid show would say. You're
Is
nervous.
there anything
your
that I
voice-
would say that you wouldn't respond with?
your
That's
voice is
exactly what a
always
paid
shaking,
show would
bro.
say.
Every time I listen to you talk, you're just scripted and shaking all the time. It's just weird. You're weird.
Okay.
You know
Deny
why?
reality as much as you want. I'm like one of the calmest
Yeah,
talkers
I know,
here.
I know. You keep saying deny reality.
So surely someone that has their own satellites and their own camera and
I
knows
haven't
what
seen
lens
it
and
for
how
years.
far away they were would know how to measure curved water, right? Can you give me that? Because I want to go do it.
It's 8 inches
Yeah,
per
just take a
mile
picture of
squared,
it from
bro.
up high.
It's 8 inches per
Measure.
mile squared, bro. 8
I want to
inches
go
per
measure it.
mile squared.
Yeah, I know. It's kind of hard to
Wait,
do from the
I
surface.
said I
If
want
you
to go
wanted to.
measure it, and you said take a picture of it.
Yeah, you can measure it
Are
with a
you?
picture.
With a picture.
Yeah, because you can draw a straight reference line on a picture
8
and
inches
There
per
you
mile
go.
squared,
monitor
no curve.
deviation from. Why do you guys ask questions and then talk every time I answer?
Sorry.
I'm on mute, dude. So don't lump me into that, please.
That was a good question, though.
Please debunk that. Somebody.
Which one? Oh yeah, this
Black
makes
Swan.
a false statement. The debunk is
Sure
that
it does. Go
it's
ahead.
making
Debunk.
a false statement about the distance to the horizon.
Is it really?
Yeah.
Where?
When it says max distance to the horizon, it's saying 1.22. It's wrong.
Man, we never had an answer for this one, man.
Of spherical geometry without refraction.
Yeah, it ignores
Not
refraction.
This
That's my
has
point.
refraction. Again, this has refraction.
That's my point. It ignores refraction. That's exactly what I was
Everybody
getting
calm
at.
down. Everybody calm down. 1.22 miles, bro. Without refraction. Now, don't go crazy with 15 miles worth of refraction. It's not going to work.
Sure,
Stop.
it can.
Calm
Walter
down,
Bisman
everybody.
did it. It works
Calm down.
just fine.
It doesn't work, bro. It's a
Yeah, it
flat
does.
as fuck. Dude,
No.
you really looking at that, denying what you're looking at and seeing?
You're denying refraction.
Yeah.
Seeing severe refraction.
Yeah, I think
Walter
actually
Bisman modeled this.
Seriously,
It
bro.
matches perfectly.
the funniest
Show
thing
me
about
an example of how you bring shit over a hill.
you don't even have to
I mean,
do that.
that,
though.
yeah, that
The
Black Swan
argument
is just
Everybody
crap,
calm
man.
down. Calm down. You bring me a tank and you fill it with this and butane and cold and freezing cold, and then you put sugar water and a laser. You know, nothing you show is reality, bro.
Okay,
When I'm
but you
showing you in
understand,
a picture, a simple picture, is
Harp,
reality.
Harp, you understand that the argument that Quantum Racer made, the one that's written there on the screen, let's just say that you're right, okay? And that can't happen. You can't do what you said can't happen. It doesn't change the fact that that argument that it says right there, that the observer height determines that max distance is whatever it says there, that's wrong. I can every flat earther in here will tell you that that's wrong. It's just a wrong
Once again,
statement.
let's
So it doesn't it doesn't matter if you don't think the
try again. I
picture.
know we've been here before, bro. I'll give you 3. I'll give you 5. I'll give you 10. Not
It doesn't
20.
work that way.
Empty
Personal
promise.
opinion.
Oh,
Your
yeah, it
personal
does work
leeway
that way
doesn't.
because you can't even bring me 5 or 10 in
The
a reason.
fallacious argument.
Tell me how you're working that out, bro.
Oh, Walter
That's what I'm
Bisman did
saying.
it. It's easy.
You
Very
give
easy.
me 5 miles in
Why do you determine what determines what you give? That's just like the most pseudoscientific statement I've ever heard.
Dude, tell me how you get 20 miles of refraction.
20 miles
Where
refraction
did
is not
20
a
come
unit of
from?
refraction. It's not a
I
unit of refraction.
thought the horizon was 10 miles. Now it's 20.
I think it's only 10 miles.
Horizon is 10 miles?
Yeah.
Who said that?
That's
I
right.
thought
True,
that's what you were saying. You were saying it was 10 miles and then it went to 15 and now it's 20.
That's true.
I'm sorry. When did I say the horizon was 10 miles?
And that's the argument of the black swan,
Yeah,
right?
no. The platform habitat is 9.41 miles.
Okay.
I
How
didn't say
far is the
anything about
horizon
the
here?
horizon. I'm just showing you the numbers, right? So the platform horizon or habitat is 9.41 miles. So the horizon is far beyond that.
It's kind of hard to tell,
Okay.
actually, but I'll
I
admit it
know
is
because
further
you
than
have
that.
no understanding of perspective, and you're just going to say whatever it takes to move your globe. I understand.
Well, let me give me a chance to
Understand.
respond before you assume what I'm
Can
going
you
to say.
tell me how 15
Harp?
miles? I'll give you. Let's say 15.
No,
Because
Harp,
you got
come
an
on. You got to
easy
trade
15.
here. You got to compromise. You can't just keep talking when
You
someone
got
else
an
is
easy
talking.
15 miles there to explain.
I don't know how you got 15, but I will admit it's further than
You
9.4,
just shrunk it
which is
from 20.
perfectly.
I'll go back to
Harp,
20. Explain the 20 then.
what 20? Well, I don't know if it is 20, but
Because
I
you
would like to
have no
see.
understanding of perspective. So there you go.
Okay, what am I misunderstanding, and how did you conclude 20?
The distance and the perspective, how far you see. And have you ever drawn a picture?
That doesn't
Yeah.
Is there
explain what you're trying to
is
say.
there an equation? Is there an equation that you can give some approximation of that rather than just saying
You know,
perspective?
there would be, but I never learned that shit. Okay, so that's why I shrunk it to 15.
So you're making a conclusion based on something you admit you never learned.
Incredible.
I think that's a little pseudoscientific.
Something I never learned to calculate that type of a picture with the distance. Have you?
Okay. Well, Walter
And
Bislin
you?
learned it, so I'll trust him over you.
Who?
Walter Bislin.
What did he learn?
He learned the physics of refraction and this math that
Tell me all
you said that
about
you
how
don't
you
know.
bring in 15 miles back to flat. Tell me all about it.
I'm unable to tell you that because that's not what I'm saying at all.
That's what the picture is showing.
I disagree.
Okay, well then if we can't even agree what you're looking at, and I guess we can go nowhere.
Can you back up your opinion of what we're looking at in any way?
Yeah, the black swan is like old news.
It's not an
That-
opinion.
Yeah.
There's a flat earther in here. What did you say, no tanks?
Please.
I wasn't saying that the black swan is old news. I just posted here's seeing Hawaii 2,600 miles away. I mean, from Nevada. Yeah.
Looks like clouds. I don't know. Let me look at this video closer.
Hey man,
All
you
right, check
can't
it out and
if,
get back
if
to
you
me.
can't knock the black
See,
swan, bring up
here's what just happened, right? Dude come in and said, fuck you and your black swan. Go look at infrared and shut the fuck up.
Look at it.
That's what he
Look
said,
at it.
right, bro? Yes. Gotcha.
Calm down.
Oh, I gotcha.
Sorry?
He just came in and said, screw the black swan, right?
Who?
Oh, look at, I think it was No Tanks.
Okay.
Go look at infrared.
He's a fucking ass.
Go look at infrared, bro.
I've seen the infrared videos where he like sees clouds and claims it's the Hudson Bay and stuff. Yeah, it's not impressive.
Really? So you're literally denying reality again.
No, I'm just not convinced by what
You've
he
not
says
seen
he's
these
saying.
things that are 1,200 miles away. Okay.
No, it's
That's
not.
okay. Fine.
It's been debunked. Bob the Science Guy did a good debunk of
And
that.
debunked. Jesus Christ.
Yeah,
My
why is
God
that
in
funny?
heaven.
You must not have heard it,
My
Harp.
Father who art in heaven,
Somebody
hallowed
walked
be
in
thy
and
name.
then they said, nuh-uh. So, I mean, you must not have heard it was debunked because they said, nuh-uh. They got you.
No, someone made a whole video about it. And
They
they're
did
right.
a whole video saying, nuh-uh.
That's good job. Good job.
No,
Show me the
it wasn't
debunking,
that.
bro.
He was identifying the landmarks
Go
and how
through
it
it with
doesn't
me,
match
bro.
up.
Debunk it with me, bro. Come on. It's been debunked.
Why do you keep asking a question and then talking when someone
Because
answers?
you talk shit.
Calm
It's
down.
been debunked. And then you move on to some more talk.
Okay.
Well,
let
I
me
mean,
post the video then.
Harp, I mean, you think what he says is shit. He thinks what you say shit. But we still need to have back and forth where each
I'm
other
sorry.
gets a
Well,
chance
that's
to
cool.
respond.
That's all good. But I'm throwing down pictures and stuff, or at least that one, just one picture. I still haven't had a satisfactory debunking at all.
Which
Not
picture?
even a little bit.
Which picture?
You can just say whatever you want to say. What
Back it up
picture?
with science, though.
What picture? Dude, I
Which picture are you
presented this
talking
to you
about?
so many times. All
I'm
of
sorry,
you.
which one are you talking about?
Black Swan, bro. Come
Oh,
on.
okay, let's finish talking about that one. It makes a fallacious statement in the beginning, so we can just
Of course it
ignore
is.
everything else based on it.
There you go.
Well, Harp. Actually,
Oh,
I have a
hand waving
black
right
swan.
off the bat. Show me the curve.
I have it right here. Hold on. I'm posting it.
Where's that from? Are you kidding me right now?
No,
He's
got it in his
What's
back
it?
pocket.
What's it? You alive? Please come in here.
You need rescued, Harp?
We need a Witsit
No,
signal.
I don't need rescue. I need somebody to fucking else that has reason. I'm
I
not
don't
saying
think you'll
you
find
guys.
that with Witsit.
That's no, that came out wrong. I'm sorry. That's totally wrong.
Well, let me
I
just
mean,
try
I'll
to
be honest
understand
with
what you're
you.
saying. Go ahead, Kosho.
Just a hope. I mean, just in all honesty, like I said, that's why I tried to just point it out that you might be right. Well, you're not about the what's impossible, not impossible, but the argument on itself is not valid. So I think a lot of people realize that some time ago, and so it's
What
probably best to
argument
just
is
drop
not
it.
valid again?
What?
Are you unvalidating this argument again? In other
Well,
words,
the
stop
argument is
just
that
saying it's invalid and
I know,
show
I
me
know, I
how
know.
it's
I'm trying to
invalid.
tell you. I'm trying to tell you. It says right there that the observer height's 1 foot, and it says the max in red letters.
Yep.
The max distance of the geometric horizon is 1.22 miles. That's true for the geometric horizon, but the geometric horizon is not a name for the horizon. That's a geometric horizon. The horizon is the thing that you see. The geometric horizon is not expected. It's not related to something that you see. That's not what it is. So the argument's just not valid.
But it is when you're got in a boat going over it, ain't it?
No,
Yeah,
it's still
sure
not.
it is.
No,
Sure,
it never is.
son of a bitch. When I want that motherfucker to be there, it will be there. And when I want it to disappear and become, that's how it is. And whether you understand invisibility of what should be seen or not is your problem. That's right.
That's a good point.
You people are fucking nuts.
Hey, man. There you go.
Okay.
Right? You people have lost your minds.
His
You are
insults make his position
insane.
more believable.
Here we go.
When do you agree with?
What's more insane? Real quick.
Go ahead.
Flat stationary plane that has things revolving back and forth around us, or the